Alright, you gonna work this time, Restream, or are you gonna just... Oh, you're gonna work. Thank goodness. Holy frick. Y'all can see me now? I'm gonna wait a second to make sure this is all going. Hi, Ichigo, how you doing? Alright, y'all can see me now. Epic. So I streamed for like 17 minutes or something like that, and I was talking and everything was going great. I had no idea it wasn't displaying on YouTube. Apparently Restream screwed up. I think it's because of last stream. Yeah, it's because of last stream. I had to do some weirdness when I streamed Core 3.5 because of I had to like restart the stream because of OBS, and that must have tripped up Restream and made it separate this into two different live streams. Yeah, so then that's why Taz was having issues joining the chat today, because Restream basically he was trying to join and he was trying to join the old one basically that was deleted, and YouTube was telling him it was deleted. And, okay. And it makes sense in my head, but I don't know how to explain it. Anyway, Restream was being dumb, and YouTube was being dumb. Mostly YouTube. So, it's fixed now. Sorry about that. If you want to see what happened in the first 17 minutes, nothing much. But I guess you can go to Twitch. I'll try to summarize it real fast. Anyway, let me put on the display. Die! It's invisible! Hey Sonic, Manic, and Ichigo and everyone. I'm gonna be honest. This is really funny because when I was looking at the YouTube chat, no one was saying it wasn't working until Mega Kid did, which is what caught my attention to it. I genuinely was just like, huh, slow night. I feel so stupid, but I was genuinely like, huh, I guess people are busy, you know, it's understandable. Alright, well, cool to see you all. Anyway, so what I was saying, apparently I was talking to a wall, but yeah, so we're doing HedgeLib again. I'm gonna actually stream wait, that's not the tweet, that's just the funny one. This one. I'm actually gonna stream something else next Friday, because I know I've been doing a lot of HedgeLib lately, and I know some of you are probably tired of it. So yeah, I'm gonna do something that's not Sonic or programming next Friday, and then of course I'm gonna do Sonic 06 on Saturdays as always. And yeah, if you want to say in what that is, there's a Twitter poll right here. Feel free to vote on this. It can be whatever you want. There's already 26 votes. Jeez, thanks everyone for like existing. You're awesome. Like seriously, holy frick. Yeah, if you don't have a Twitter account, that's cool. Just let me know. Let's see. I guess either here or on Discord would be a good place. And I don't know how, but I'll count it somehow. You don't have Twitter. Yeah, it's cool. Oh, thanks, wannabe dev. I'll follow you back. Yeah, it's cool, man. Just, if you want to vote for something and you don't have a Twitter account, just post it in the chat or on Discord or whatever, and I'll count it. I don't know how I'm gonna count it yet, but I'll count it somehow. I think I'll just keep a notepad note or something, and I'll tally it up with the Twitter ones. But if you already voted on Twitter, you can't vote again here, I got it. That's cheating. 1 vote per person. You vote for Nekopar or HedgeLib if that's an option? Alright, you know what? I'm just gonna genuinely make a notepad document. Like... alright, and then... There we go. Alright, anyway, so as I was saying before this happened, so there's a few things that changed about the HedgeLib code style since last stream. The first one is the big one is I'm using Pragma once now instead of the include guards. If you remember before, it used to be like if, not, def, H, ice shader, variant, H included, basically, and then you would say define it, and then at the end, oh frick, and then at the end, you would put like end if, right? And you had to do this every time, and yeah, it was tedious. The only reason I did it was because technically Pragma once is not part of the C++ standard. It's not a Microsoft only thing, don't worry. It's actually supported by pretty much any major compiler these days. Supported by MSVC, which is the Visual Studio compiler, but also GCC, the GNU C compiler, and well, the GNU compiler collection, and Clang. So basically, the compilers are going to use, realistically speaking. Yeah, so the only reason I wasn't using this was because it wasn't the C++ standard, and I was like, oh, but I want it to be standardized, I want it to work everywhere! But it's like, that's kind of silly, being honest, because realistically speaking, we're never gonna use this on something that doesn't support Pragma once. Like, come on. And if we do need to for some reason in the future, it's gonna be a really bizarre corner case that no one's ever thought of, like freaking porting HedgeLib to the Leapfrog DG, or whatever the frick, I don't know. In which case we can deal with it when we go to do that, right? Yeah. I'm trying to. I want to be mostly standards compliant, but I want to be a little. I'm gonna be a little less strict than I was being, because I realize it's kind of stupid. The direct, like, for what I'm doing here, the whole purpose of, like, direct memory loading, the whole concept of it rather, is something that the standard kind of doesn't say is even okay to begin with. Like, for example, I was saying this earlier before I had to restart the stream. If you have, like, a uint, and it actually contains, like, bytes in memory, like, let's say it contains ASCII string ABC and then a null terminated 0 at the end, right? So 4 bytes, right? ABC and then the 0. Let's say you want to, like, treat that as though it's a C string, right? So what you could do is you could make a char pointer, and you could actually cast whatever to this, right? Technically, if I understand correctly anyway, and I might be wrong here, but if I understand this correctly at least, this line is actually against the C++ standard, even though it compiles on pretty much any compiler you can imagine. Isn't that stupid? And the reason is because, technically, you're not supposed to, again, if I understand correctly, you're not supposed to cast something to a type that it wasn't. So, like, a char pointer, oh, this wasn't a char, this wasn't, you know, oh, well, actually, I didn't even type that right, but you got what I meant. Sorry. Oh, this wasn't a pointer to a char, that's a pointer to a uint, you freaking moron. You can't do that, and this will compile just fine. But the C++ standard says you're not supposed to do that. So then it's like, what's the point of a cast, even? Well, the point is supposed to be if you have, like, a base type and then a derived type, you can, like, cast between the base and derived, and that's fine. But in that case, it's like, that's dumb. You know what I mean? If you're doing direct memory loading, you're gonna need to do stuff like this sometimes. And of course HedgeLib does, sometimes. So, you know, I figure I need to be a little less strict with how much I'm following the standard, because I'm never going to be fully standards compliant just because of the concept of what HedgeLib is trying to do, right? So might as well make things a little bit easier for us and not try to go exactly by the book and be like, no, you cannot use Pragma once because it is not in the standard, even though we're already kind of breaking the standard anyway in some ways. Anyway, beyond that, I'm also adding a new line to the end of each source file, which I'm actually enforcing by, I have this editor config file, which is supported by Visual Studio and a bunch of other editors. It's not just a Microsoft thing, don't worry. It forces spaces instead of tabs, which works nicer with GitHub, and it forces a final new line. So what I mean by that is, like, if you actually write a file like this, and you don't have a final new line at the end and you hit save, notice it actually put the line in there, it added it for you. So anything that you edit in Visual Studio or any other editor that supports that editor config file, it's going to automatically put that line at the end, therefore you don't have to worry about it. And it'll handle spaces and everything. I think it's nice. Now you might be wondering, what's the point of the final new line, right? I used to not like them because I was like, this is stupid. Why do you have to have this wasted space? But actually, there's a reason for the final new line. There's a reason that it's there. Basically, to put it simply, in Unix anyway, a line in a text file is essentially a bunch of characters, one after another, that ends with a terminating new line character, so like /n, right? If it doesn't have a /n at the end, it's technically not considered a line. So yeah, if you have this, what's happening is, like, you have like this curly bracket character, and then you have like a /n, right? Which says, put this line here, see? But if you don't have this, then you just have a curly bracket, and so according to Unix, this is not actually like a line. That's just a curly bracket, and so it's only going to compile that much of it, which is going to be an error because you need that curly bracket. You get what's happening? So, realistically speaking, tools usually aren't that stupid, you know, especially like GCC and whatever. they're smart enough to go, well, you meant this is the final credit bracket, and it'll compile just fine. But there's actually some older tools, and even newer ones that are being created that rely on this final new line being there, and it's actually in the C standard that you're supposed to put there too. So, yeah, that's not just being standards compliant, I just think it's a good practice, even though there is a part of me that's kind of bugged by having that empty space there at the end. So, yeah, that's why I'm doing that now. Minor style changes, but that's a big thing. Okay, one more thing that changed. Instead of calling things like whatever base, I'm actually calling them I whatever now. So like in C#, if you made interfaces, you would call them I whatever, right? And I always liked that. I always thought that was a good prefix and a good way to do things. But I kind of thought it was a C# thing. I was like, oh yeah, but it's like that because it stands for interface, and interface is a C# thing. That's not in C++. So I'm like, you know, I don't think I should use it in C++ because, you know, it's a C# thing. It's not going to make sense here. Then I looked at the Unreal Engine 4 source code the other day, actually, because I wanted to see what they how they stylize their code and everything, since they're, you know, Unreal Engine 4 is obviously a professional project. They know what they're doing. And I wanted to take advice from them and see how they stylize things. And actually, to my surprise, they do address their interfaces like this. Exactly like this. They do I whatever, and then they do abstract classes. So they actually recommend it because they say it's a good practice and it makes it clear that it's an interface without you having to type it all. So I was like, okay, well that's cool, I'll do that then. And I've been changing up my code to do that. Instead of actually having an archive base, now I have iArchive. And instead of having a file base like in original HedgeLib and everything, I actually have, it's now called iFile format. So it's like this, any class that extends from this and implements this is a file format in it. So that I think makes things a little more clear. And I'm really liking how it's organized. It's all working out nicely. Yeah, so tonight what we're doing, if I can get to it. Oh, this song's so good. I know I always ramble at the beginning of these streams, I'm sorry, I just want to explain where I'm at. What I want to do tonight is, I want to keep working on HedgeEdit. I want to actually get it to load up a shader, and I want it to actually draw something. It's not going to be anything crazy. I don't think I'm going to, well maybe I'll do a Sonic model. It's not going to have textures and stuff though tonight. It's just going to be, if I get it working tonight, as planned, it's going to be like a cube or something, and then I'll try to probably do a Sonic model. And then hopefully that'll all work, and we'll be good. And then next time I'll work on textures or whatever. But next week, we're not probably streaming HedgeLib. I plan on streaming something else, depending on what the result of this poll is. Hi, Twitter. Can you play Minecraft? Sure, I'll count that towards the votes. Yeah, Minecraft actually would be fun, like legit. I'm seeing people, it's like coming back sort of in a way. People are like memeing it again a lot. But actually, like, unironically, I loved Minecraft. I know it's like corny to say, but like seriously, like it's a good game. It's fun. All right, so hi chat. Hey Bluecore, Cora Baker, how y'all doing? Store all the pointers and addresses in longs, then cast the longs back into pointers to access the data, just for the heck of it. Basically, Unix is garbage as usual. Well, I wouldn't say garbage. They have ways of doing things that actually make sense when you hear it explained. It's like, oh, okay, that's clever, that makes sense. It's just, it's not compatible with like the Windows mindset. You know what I mean? So when you're like when you're doing Unix stuff from a Windows mentality or Windows perspective, it seems really garbage and complicated and dumb. But like from a Unix mindset, it makes sense. Like for example, most Unix tools wouldn't display that blank new line at the end, from my understanding anyway. They wouldn't show that. It would just look like this. But when you save, it's gonna save this. See? But then Windows doesn't think of lines as working like that. So Windows is gonna show the blank line. It's kind of dumb. GitHub actually follows the Unix mentality, where if you look at files on GitHub, like this one for example, this one looks like it doesn't end with a new line, but actually it does. It just doesn't display the new line because it's using the Unix mentality. So there's actually a /n at the end here, which doesn't show it. If you actually don't put the final new line there, it puts a special character there that looks like this, it's like a little cross sign that says no new line at end of file when you hover over it. So it actually wants you to put the new line. But anyway, yeah, I agree. Unix has a lot of weird mentality, but I think a lot of times it's not that Unix is being garbage, it's just that it's like, we're looking at it from the Windows perspective. And from Windows perspective, it looks like garbage. Anyway, is HedgeLib gonna support Sonic Sharp? What do you mean by that? Sorry. Why is it supposed to support wavefront object 3D files? Yes, I want it ideally to be able to support importing and exporting models to or from object, like OBJ, DAE, the Collada format, and FBX. Those are my big priorities. Other formats, I don't know. If there's demand for them, then sure. Well, okay, I don't want to copy from libgens, but libgens had this library that had a weird name. It was called this. It stood for a set importer, but it looks great. And actually, what it does, it's actually really good. I did not mean to click donate, but not that I don't want to donate. It's just I don't want to show payment information on the stream. But anyway, it's a good library. It really is. This actually supports importing and exporting to various 3D model formats, including all of these. There's a bunch of them. But yeah, amongst them are the ones that I want to support. DAE and FBX is there, and actually Blend, like the Blender format, you can straight up export a blend instead of having to even go... That's crazy. There's 3DS, like 3ds Max format, I believe. I forget, actually. I think it's a 3ds Max format. I know it's not the 3ds Max format, but I think it's one of them. An object, and yeah, it supports all that. And a bunch of formats I've never even freaking heard of, like VTA, ZGL. Holy frick! But yeah, it looks cool. So I could use this. Oh, actually, it's not. It doesn't support exporting all this. Oh, it supports importing in a ton, but not exporting in a bunch of them. So that's interesting. But it still is pretty much has support for what I need. This is the experimental part at the end here is the only part that's a little concerning, but I'm sure it'll be fine. But yeah, I could use this. It seems neat. I think it's actually under a license I can use it under. Yeah, it's like slightly more complicated than MIT. So that should be compatible. The only thing with this is, it's not anything to do with the library itself, it's just in general, I'm trying to avoid dependencies if I can help it, because I kind of feel like they're a pain. You know what I mean? Well, that was one thing that I never liked about C++ libraries, especially when you go to compile them. You have to download like 200 million separate dependencies, and you have to make sure they're all the correct version, and you put them in correctly, and it's a nightmare sometimes. Like, my gosh, it should be like, you clone the repository, you open up the solution, you hit build, and it builds. No errors, right? But sometimes it doesn't work like that at all, and it's a nightmare. And yeah, I like libgens a lot. It's really impressive. It's a great library. I mean, nothing against it when I say this, but that was one thing about libgens that I wanted to do differently with HedgeLib, because yeah, when you set up libgens, you have to get Ogre, you have to get the Havoc SDK, which that one in particular was a nightmare, because until, you know, when Microsoft bought Havoc, they took down the links, so you have to like dig up. There's this pastebin file somewhere that has all these links to mirrors of the Havoc SDK stuff, which technically I believe the EULA says you're not even supposed to do that, but whatever. I guess. So then you download that, and you have to install it, and then you copy the stuff into the depends folder for libgens, and then that's just one dependency, and you gotta get a set importer, you gotta get, you know, I don't think Qt actually, because I think those are, yeah, the deals for that are actually included with libgens, which is interesting. But it obviously doesn't include everything, it just includes the stuff that's absolutely necessary to compile libgens. I could have done that with HedgeLib, but I thought it would be better to just have people like compile with their own up-to-date copy. But actually, I've had multiple people already mention that it's a nightmare to download it because it's huge, and it seems a lot of people actually haven't compiled HedgeLib yet simply because they didn't want to download it. So maybe I shouldn't just do it like libgens does. But anyway, yeah, if I do use the set importer, I'm gonna I don't know how I'll do it, but basically, yeah, you get what I'm saying. I just want to avoid dependencies if I can. So I need to think it through when I go to do all that stuff, because I want to make it easy for people to stream things. Anyway, people Minecraft, it better be Windows 10. Oh yeah, there's Windows 10 version, I forgot. I have it, actually. Yeah, we could do it from, like, any console then, right? Yeah, people could even join from their phones and stuff. That's cool. That's really awesome, like, finally. It took so many years for that to happen, but I'm glad that Microsoft actually made that happen. It is indeed huge, but you can spend a weekend into downloading it. Oh, it's a nightmare though to download it, I agree. Yeah, sorry, I didn't realize how big it was, but it's really good though once you have it. It's like, oh, nice, and you only need to get it once, right? But yeah, maybe I should just include some duels. We can crossplay, that's awesome. We can do a great build battle, that sounds fun. Yeah, Minecraft would be fun, honestly. It supports X and 3DS, perfect, yeah. I forgot X was even a thing. Alright, so I've been rambling again, like I always do in these streams, so let's get down to the meat of this. So, okay, the big thing for tonight on the agenda is this. This is not commented code. It might appear that way at first, because I tend to comment out my code a lot, but it's not that. This is actually, literally just a bunch of comments I wrote the other day, brainstorming on how I was gonna do this. So I came up with something that I think is gonna work out okay, based on some research I did on DirectX and how a lot of big engines do things. I did not copy this from Unreal Engine 4, in case you're wondering, because I did mention earlier that I looked at the Unreal Engine 4 source, but I swear that was unrelated. I actually didn't do that until after I came up with this. And I didn't delve into the rendering code or anything like that. I'm not taking this. But yeah, I did actually find this Stack Overflow, Stack Exchange post, however, that explained an idea from a Wolfire post that he couldn't find, and I can't find either for the life of me. Is it this one? Yeah, it's this post. Sorry, it looks different because the page is formatted differently than it was last. Anyway, yeah, it explained a way that you can do depth sorting, basically, to see, it's tricky to explain, but basically when you render transparent objects in Direct3D or even or OpenGL or Vulkan, whatever you use, it doesn't matter. It's actually a nightmare. You might not think it would be a nightmare. It's like, why would it be so hard? You're just drawing a transparent thing on top of what's already there, but it's a lot more complicated than that. The main reason is, normally when you draw something to the screen, you have like a draw command where you just straight up say like, oh, add this thing to the current buffer, right? And you're basically just saying, put pixels onto the screen, on top of what's already there, right? So you don't usually really care about the order that you're drawing things in. It just adds things to the buffer and everything works fine. But every now and then you run into some issues. So first of all, what happens if you're drawing something on top of something else that's actually supposed to be behind that something, right? What do, right? The easy thing you could do, obviously, would be, well, just draw it in the right order. But it gets a lot more complicated than that. Generally speaking, what game developers do is they have this thing called a depth buffer, which is basically like, if I understand this correctly, I've never been that good at CG, my apologies. It's basically like a big buffer of bits. So it's just a bunch of ones or zeros, right? If it's a 0, it means there's nothing there, and if it's a 1, it means there is a pixel there, right? So if you were to draw the thing that's supposed to be in front first, and then you were to draw the thing that's supposed to be behind, what happens is it checks the depth buffer to see if there's already bits that are set to 1 in the spot that it's trying to draw at, and if it is, it doesn't draw there. So then it doesn't overlap, it looks as though it's still behind the object and it looks fine. And you don't actually have to sort anything, and it's fast, and it all works great. Everything's happy, yay, okay. Now you gotta draw transparent objects. That suddenly does not work at all. Because for transparent objects, you can't just have a 0 or a 1. You have to have values that are in between that. What if you have something that's there, but that's transparent, right? It gets really complicated. So what you generally have to do is you have to do sorting, where you basically have to figure out the correct order that the transparent objects have to be drawn in. Usually it's from back to front. So you have objects that are like farther away first, and then it goes up until the objects that are closest to you, because that way they stack correctly. You can get it? It's like if you were to layer them on top of each other, it looks correct. It sounds like it should be easy, like, oh, just sort it, Rad, just sort it. But how do you sort it? How do you determine where the object is in the space, and if it's closer or farther away than the other object, right? And then how do you do that for each object and do it all quickly? It gets tricky. So I was doing some research on how I could do it fast, and I found this post, and this post has been excellent. Basically, the explanation was to do a dot, get the dot product of the camera view vector and the object's world position minus the camera's world position. So basically what you're getting there is the distance as a single float value from the perspective the camera is looking at, basically, to the object. So you get how far away the object is from the camera. And then from there, you can easily sort it. But then the problem is, how do you do that? So anyway, what I came up with, I'm going to explain this, and then I'm going to try to go implement it, and I'll stop talking after that. So here we go. Is this. There's some Pseudo code that I never finished. Okay, it's actually more like, it's not really Pseudo code, it's like, kind of like, anyway. Oh, it's who's gonna rock the place. Epic. Okay, so you got a shader. The shaders have, well, I think I'm actually gonna call them attributes, but parameters, and then they're gonna have indices, and they're gonna have variance. So basically, this is like how I explained last stream with the forces shaders. You basically have a combination of, it's trying to explain. Basically, you have different types of shaders, and you have indices that explain how combinations of them all work. So I was looking into, that's how the Hedgehog Engine 2 does it, but I was wondering if Hedgehog Engine 1 did it that way. So I was actually looking into the Hedgehog Engine 1 shaders from Generations anyway. And I have a bunch of them open here because I was glancing at it. I haven't looked too in depth on it, but it looks like it actually pretty much does it like Hedgehog Engine 2 does. Just a little simpler. So yeah, I think this is gonna work. It's like, I get the feeling a lot of games probably actually do it in a similar way to this. Oh, Kobe. Oh yeah, I forgot. Oh man. Kobe needs to come back. Anyway, I was kidding. He's hopefully happy. Anyway, yeah, so there's vertex shader variance and there's pixel shader variance. So for the vertex shader variance, I'm gonna have an ID, not an index, but an ID that like a UUID basically. It's like gonna be a unique identifier that describes a type of input layout that the vertex shader needs. So then in the viewport, sorry, when the device actually, I'm gonna have an unordered map. It's like a dictionary where the key is a uint and the value is an input layout. And so you can actually just toss in this input ID and it'll spit out the layout that corresponds to it. So basically what you can do is you can have a function that generates this UID from the type of input layout that's required. Don't know how I'm going to do that, but basically it's like hashing, right? And you'll get the same result for any vertex shader variant that uses the same type of input layout, right? So you're only going to get a different value if it actually needs a different input layout. And then what will happen is you can check this to see if that ID is already being used, and if it is, then you can just get the input layout from there and you're done. If it isn't, you can create it, and then yeah, you only end up having one of each input layout. So then you have pixel shaders. They're just pixel shaders. Simple. There's nothing else to be had with them. Alright, so then you have geometry. I'm not going to concern myself with models and meshes and submeshes. In HedgeEdit, in HedgeLib I do, but in HedgeEdit everything's just going to be geometry and objects. Because it's simpler, and this is all you need anyway. Basically, geometry is going to be like a submesh. So it's going to have a vertex buffer, an index buffer, and then it's going to have a material index, and it's going to have a boolean that says if it's transparent or not. Note that it says for solid or boolean this is false. what this transparent flag means is, is it like glass where you can see through it, basically, right? Something like leaves on a tree, this would not be transparent, because even though it's basically a plane where only parts of it are visible, it's what you're drawing is either a pixel or no pixel. Do you get what I'm saying? You're not drawing something that's see-through. So I guess maybe I should call this see-through or translucent or something. But anyway, it means like whether or not you can actually see through the object, not just whether or not the pixels are there or not. Do you get what I'm saying? Okay, so then this is a material, and it's just gonna have a shader name, which is gonna be the name of one of these, right? It's gonna have texture indices and textures. I don't know how I'm gonna do textures yet, but we'll figure that out later. Then it should be pretty simple. Then we have objects. These are gonna be like models. So these have geometry indices. They're just gonna be U shorts. You notice that I'm using shorts for everything other than the texture indices, and I'll get to that in a moment too. Like I used it for here too. And then I'm gonna have a geometry count, and it's just an array of geometry. That's it. The only reason these exist, these actually aren't gonna be used when you go to draw. These are just gonna be used when so like if you click on a model in the scene view, it's gonna need to figure out what meshes correspond to that model, right? So the only reason the objects exist is so that you can do that in the scene view. So you can click on the model and it'll highlight all the meshes that correspond to it. In this case, the geometry. You get what I'm saying? Okay. So finally, we have the device. This is going to have a bunch of vectors, which contain unique pointers to shaders, objects, geometries, materials, and textures, and these are all going to be private. It's then also going to have unordered maps, which are like dictionaries, that are going to contain actually indices, which reference indices to values in this, basically, see? And it's going to have strings. So the purpose of this, the reason I have the two of them separated instead of having just one like this, is because this way you can access something very quickly based on an indice, or you can access something slightly slower, but not by much, by hashing a string and then getting the index and then grabbing it from there. So the idea is, for when I go to draw, I need it to be as fast as possible, so I'm just going to use indices. And when I need to do like specific things like with the scene view or whatever, or like when I'm loading models and I need to figure out if I already loaded a model of that name or not, I want to be able to check something based on the name. So this allows me to do both of them very fast. Okay, so then you're going to have instances. These are just going to have a short, which is the object index. It's going to be an index that points to one of these. It's going to have a matrix, which is going to contain position, scale, rotation values, and then it's also going to have those out separated. I did that just like I did in C# HedgeEdit. The reason for such being that even though you can just store all of these inside the matrix, or you could just store all of these and not have the matrix, this allows me to have both of them without having to convert between them all the time, only when it's necessary. So like I can have a function that says like set position, and then it can actually update the matrix if needed. And then you can later get the position and not have to actually decompose the matrix every single time. So it's an optimization thing, even though it uses up more memory. It actually saves CPU time drastically because we don't have to constantly decompose and recompose the matrix. We only need to do this when it's necessary. So yeah, that's the point of that. Sorry, I'm rambling so much. I just really need to explain all this, and then I'll get to it. Okay, finally, we have the viewport, which contains an instance of the device, which is all of this. It's gonna have a vector of instances, which are gonna be these, and then it's going to have another vector, which is private, strictly private, of ulongs, which are called sorted instances. And this is where things get interesting, and this is where I took the idea from here. So, notice how whenever I use an index for something, unless it's a shader or a texture, I use a ushort instead of a uint. A short, remember, is 2 bytes or 16 bits, not the whole 4 bytes like in it. So, the reason I did this was on purpose. The idea is, here we go. When I go to do sorting, what I'm going to do is, I'm going to have, these are going to both be private, and I'm going to have public functions in the viewport that are going to have things like add instance, get instance, remove instance, whatever. Whenever you and whenever these functions manipulate the instances vector, they're also going to manipulate the sorted instances vector to add or remove another element. So basically, they're going to just ensure that this vector is always the exact same size, well, has the same count of elements as this vector. So that way we shouldn't have to check for that every time, because the only way you could possibly make that not true is if you were to basically somehow access a private member from the viewport, and at that point you could do anything. You could do any kind of damage you want, right? So none of our checks are going to apply at that point. So anyway, this should be safe. The idea is, sorry, I know I'm rambling a lot here, but there's really a lot to explain. The idea with this is, every time the camera angle changes, we can call this sort function, which I wrote some pseudocode for out here. And what it's basically going to do, just focus on this part, because this part's a mess, and it's not really totally correct anyway, then I never finished it, but what it's basically going to do is, so it's going to go through each instance, it's going to check how far the instance is from the camera, and it's basically going to create, it's going to set these values in sorted instances. So what it's going to set them to is basically a bit, like a bit flag, a bit mask. I forget terms, I'm dumb. But it's basically going to be, ulong is, 64 bits. So it's going to have these 64 bits here to play with. And basically what it's going to do is, the first 16 bits it's going to use as the geometry index. Then the next 16 bits it's going to use as the instance index. The next 16 bits it's going to use as the material index. Then the next 15 bits it's actually going to use as the distance from the camera, which is going to be converted to a short and then like divided, I guess. And then finally the last bit's going to be a transparent flag, so it's gonna correspond to this, and it's going to say whether or not this is see-through or not, right? So the idea is what you end up with is a value that's basically a big number. And here's the cool part of it. Here's the whole point to this. This is why I think that post was brilliant. Basically, these numbers are actually guaranteed going to be basically in a certain order, right? From 0 to the max value you can store in a ulong, basically. It's not actually going to reach that, hopefully, but you get what I'm saying. It's going to go from least to greatest. So it's going to go based on this order here. So like, notice how I put them as like 1, 2, 3, 4, and so on. So basically 1 is least important, then 2 is more important, 3 is more important, 4 is more important, and then 5 is most important. So it's going to sort based on that importance. So yeah, basically what we can do is, once we have this vector, we can do what's called a radix sort, where we just go through and basically we get numbers that are like, we just sort them from least to greatest, and it's pretty fast, it's easy to do. And then we have a vector that contains all these numbers in order we can that's like, it's optimized for fast drawing, that we can easily get all the information we need from in order to draw. And it's not taxing to create this either, because all we need to do is just loop through all the objects and then just push these into this bit value, basically. You get what I'm saying? So you only need to do this whenever the camera angle changes, which is not every frame, but it's most frames. But still, it's actually not bad. It's basically what we'd be doing anyway for rendering. So it's pretty. I think it's going to be pretty good. The idea is, yeah, we're basically just sorting all of our instances in such a way that they line up like this, where this is the most important thing, and then it goes down from there. And then we can change things as we need. So like basically, every time we notice the geometry index changes, we can change our vertex binding. And then we can keep going until that needs to change again. Every time the instance index changes, we just change the instance. Every time, it's pretty simple. You just have to change the constant buffer on in the shader, and you need to set the new matrix. Every time the material index changes, we need to change the shader, which means changing constant buffers, it means changing parameters, it means changing textures, it means all that. So that's going to be more taxing, that's why it's 3. See, it's lower to highest priority. Every time we change the distance, this is just we don't actually need to like change anything on DirectX when we do this. It's just needed to ensure that we're drawing from back to front order. And then finally, transparent flag means that we're gonna actually end up drawing all of the opaque solid objects first, and then we're gonna end up drawing all of the transparent objects in the same order that we drew the solid ones in, basically, from back to front and all that. So it's really hard to explain. I'm sorry I did a really bad job wording all that. But the idea is that, yeah, you can actually just loop through everything and make this, like, these flags, and it's pretty fast, it's not hard to do, and then you're done. And then you can just draw everything, and it's easy. So I think it's going to be really good. I think this whole system is going to let HedgeLib draw anything we need to pretty fast from any game. Pretty much because it's pretty flexible. But yeah, this is why I use shorts, because I needed to stuff them into these values here. I needed them to fit, and I wanted to ensure that they wouldn't be a value that couldn't fit within this sorted instances ulong. So, whew, there we go. I think I spent like 20 minutes explaining that at least. So, holy frick, my apologies. There's some code I wrote out to try to like get the idea of how to do it. But we're gonna adapt this, and we're actually gonna make it happen tonight, hopefully. But we're probably not gonna actually end up doing all this, because you know me. And I'm the guy who spends 20 minutes explaining a concept I came up with. But yeah, so we're gonna start implementing this, but really fast. Just play the entire Sims 2 DS soundtrack. Yeah, it's gonna be epic. What in the heck is a template in C++? They're pretty neat. They're actually really cool, but they're interesting. So the idea is, how do I even explain what they are? Basically, you can have multiple variations of something that use different types. So like if you have, let's say you want to have a function like int add, int a, int b, and you want to say like this. Now, obviously, you wouldn't ever want a function like this. This is stupid. You would just write a plus b. You wouldn't call a function to do this, but just for the sake of example, just pretend that you need a function like this. It's super important. But then you also need a function that's like, sorry, I forgot this wasn't C#. You also need a function like this. And then you also need a function for floats. Like this. And so on and so forth. You need all these different types of add functions, right? To exist all at the same time, basically. It's really tedious to write all of these out one by one for every type of numerical type that you need, right? Because you're just copy pasting things over and over and over and over and over again. The other thing that's really annoying about it is, you probably know this already, but like one in general, like no matter what language you're writing in, usually something that you can, okay, like, what's the term for this? Basically a sign of like bad code is if you're copy pasting, right? If you have to copy paste something over and over again, you're probably writing bad code, because usually programming languages try to help prevent you from doing that, right? So the idea behind a template is to avoid exactly this. So basically, you can write something like this. Yeah, and then you can say t add t a t b, and then you can just do this. And so what's happening there is basically, this is like a macro almost in a way, where t is going to be replaced with the type name that is needed. So when you call add, it's going to replace this t with whatever type you need, whether it be float, unsigned long, int, or even something you haven't thought of yet, maybe double, whatever, and it's going to do this. And then it's gonna call that basically. And what's cool about templates is this actually happens at compile time, not at runtime. So basically, whenever you call add, whenever you call this template in your code, the compiler is actually going to, like at compile time, it's gonna figure out what type you need in order to make that call, and it's gonna check to see if there's already a template of that type that exists, and if there isn't, it's gonna create it. So like if you're saying int add, if you need an int, it's basically going to generate a function that looks like this. And then next time you'd call this with int, it's going to just call this one instead of making another copy. And same with floats, same with long, same whatever. It's just going to make as many copies as it needs and only as many as it needs. and then replace all the calls with the calls to the copies it made. So it's really nice, it's really efficient, it doesn't add any overhead or anything, it just makes cleaner code. There are a few downsides to it though. One of them is if you want to interface with, for example, like other languages, if you want to make like C# bindings, for example. Why would you want to do that? Sorry. Templates are a nightmare because basically what you're going to end up with is like only the copies like that were used in the code, right? From C#, let's say you were let's say in your C++ code you have this template and you actually use int and unsigned long, but you don't use float. You don't use it, right? That's never going to be generated in your C++ code because it wasn't used. So then from C#, what if you were to call this but say float? That's not going to work. What do you bind it to? There's nothing to bind it to. You see what I'm saying? So if you're trying to make a library that can be used from C and can be used from C# and other languages, probably avoid templates because, yeah. But if you just are writing C++ only for the sake of it working with C++, templates are really cool and they're a really nice feature. One other thing you might be concerned about is, wait, what if I pass in something that can't be added like this? So what if I try to add, like a class? That's not gonna work, right? This is gonna fail. Like, what if I try to add, I don't know, two arrays or something? It's gonna screw up. Well, actually at compile time, when you try to call the add function, it's gonna go check, and it's gonna try to make a function that uses those two types and adds them, and it's gonna realize that doesn't work, so it's actually gonna throw an error. So you actually don't have to worry about that. Basically, if it can happen, if it can work, C++ will let you make a copy of it, otherwise it won't. So they're very nice. I actually like templates a lot. I use them a lot in HedgeLib, but it can be a little messy. But that's what templates are. Hopefully that explained a little bit. What if you want to add an int and a double? Oh, so if you want to add an int and a double, you couldn't do it with this template, but you could make. So here's the cool part, right? Okay, so everything inside these brackets up here are actually like a special separate section of arguments, basically, for the template. So it's kind of weird to explain, but like basically when you call this add function, if you were to say, just pretend that this is some other code somewhere, right? Obviously it's not, so Visual Studio is going to yell at me, but pretend that there's 50 million errors, but pretend that there isn't. Let's pretend that you have two ints, A and B, and you call this. C++ is actually going to, and just pretend that all these don't exist, right? C++ is actually going to go, okay, let's see, so this is an int, and this is also an int. So it's going to go, okay, t int, t int, t int. Okay, everything's going to be good, and it's just going to basically make, it's basically going to make this. And then it's going to call that. It's all going to work out fine. In reality, though, what's happening behind this, one of the things that's happening behind the scenes is, basically, when you call a template function, you're actually supposed to pass in the type like this. But when the type is obvious, so like in the example I showed before, like this, you can actually drop that and it'll still compile fine. But yeah, you're supposed to specify it like this. So the reason I explained that is because if you have you can actually have multiple template arguments, and you can actually specify them manually like that. So you could actually say like, y, I don't know, just call it whatever you want, and you could put this there. And then you could actually say like int double, and that would work as long as b is a double, which it isn't, but pretend it is. And you could do that. But yeah, you can actually have several template arguments. It's just that they won't be automatically inferred if you do it like that, so you have to include them here like this. Unless, actually in this case, if you were to do this, I think you could actually just do that, and that would be obvious, and it would figure it out. Because it's gonna go, what's A? A is an int. Oh, so T means int. What's B? B is a double. Oh, Y is double, and it'll make a version for that. But yeah, this works, and you can actually have a template like this that'll generate as many combinations as you need, and only as many as you need, which is cool. And it doesn't have to just be ints. I know adding doesn't make a whole lot of sense why you need that as a template, but you can do this for a lot of fancy things. Which becomes really powerful. One thing I used it for, which is really neat, in HedgeLib, is I have an endian class where I have this, okay, so you can actually, I forgot to mention this too, but you can actually make template functions, like I was showing earlier, but you can actually have specializations is what they're called. And basically the idea is you can say, if the thing that's being passed into my template function is actually of this type, then do this thing specifically. Otherwise, call the generic one. So like this up here is a template function that takes a value and it swaps it as needed. But then basically if, when you go to call this, t is actually of one of these types down here, then instead of calling this template function, it's going to call one of these instead. So you can have like specifications. And the point of it is that I have a swap function that can take any struct or class, and then it can also take integral values and just swap them. So if it's an integral value, it'll just swap it. So like for a double, it swaps the initness of a double. For an int, it swaps the initness of an int, and so on. But for a struct, it's going to check to see if it has an init swap function, and if it does, it's going to call it. So then that's going to recurse through all of the values in the struct, and then go back to calling these or these if necessary, and it'll just keep going as long as it needs to. And so basically with just one call to swap, you end up swapping everything inside that struct or class. And that's how I did it. So that's a really cool thing you can do with them. Don't mind this, that's a nightmare to explain. You can also have template classes, which is really crazy to explain, but alright, let me show you an example really fast, and I need to get back to what I'm doing, but I'm just gonna call this foo because everyone calls their example classes foo. So let's say for some reason you need to actually have a class that's different based on different scenarios. So like in one case you might need a class that has 2 ints. In another case you might need the exact same class, but this time it needs to have 2 floats, and so on and so forth. I don't know why, but sometimes there's cases where you need this. So you can actually make a template class. You can say like this, and then you can do this. And that will actually compile. That will work just fine. When you go to make a copy of the class, what you do is you actually say like this. And now you have, that's your type name. And yeah, it's going to replace this t with int. And you're going to have that. Or you could do this. Or you could do this. Or you could do, you could do that. Oh, frick. Well, pretend that it didn't format that weirdly. But yeah, you could do that. Or you could frickin'... Why are you doing this to me, Visual Studio? That's ridiculous. Okay, just so that it won't do this anymore. Hang on. You could do this. Because this is an insane programming language. Why would you ever do this? You can! It's fine. It all compiles. So anyway, that's what template classes are for. They're really powerful too. This language is a mess. Sorry if I explained that poorly. It's a very powerful mess. I don't know any other programming language that's like this. It's usually like... I don't know. Like, usually languages do one thing and they do it well, but C++, it does a lot of things. Some of them it does very well, some of them, why? How is the return type determined? You mean in the function? It's determined based on, so, okay, basically, hang on. I need to undo until I get back to my example from before. Okay, so basically what it's doing is just going to do like a, just think of it like this, it's just doing like a text replacement based on context. So like in this case, we said we have 2 types, type T and type Y, and then we have 2 arguments, right? A and B. A is of type T and B is of type Y. So the compiler automatically figures out, oh, okay, wait, so if A is of type T and A in this case is of type int, then T must be type int, see? And if B is of type Y, and B is double, then Y must be double. So then what happens is now we know, okay, T is int, Y is double. So then when we, up here at the beginning of our function, we specify the return type, and in this case we say it's of type T. And remember, we just figured out T is int because of A. So in this case, you would get the return type would be int. So actually, yeah, this one's not going to compile because when you try to compile this code down here, it's going to go, you're trying to add an int and a double and then return it as an int. That's not right. You need to do some casting, right? But you could make it work if you are a madman. Maybe you could do something like this if you want. You could say y, and then you could say like this. And so you could actually say, oh, add a and b, and then cast it to type y and return that. And so then it'll return it as a double. I don't know why it's complaining. Oh, well, it's complaining because I'm writing this code out in the middle of a header in a weird way, but just, yeah. It's valid C++. Templates are hard to explain. I'm sorry, I threw a lot of information at your face very fast, but hopefully that clarified a few things. Yeah. Learning programming with Raddy Daddy Friendo Mido in live, yes. And yeah, you can cast them. ED templates in C#. Well, they are in C# actually, but they're a lot less powerful. They're called generics. In C#, what you would do is you would say, it's been a while, frick. I think it's like T, add T, and then you would say like this. It would look like this, I think. And then you could say this. I'm pretty sure that's the case, but let me make sure that. There's classes, yeah, but I want to get generic functions, generic methods. Yeah, you could do that. You should be able to return type T. I don't see an example where they're doing that, but why would you not be able to do that? Yeah, but in C# you just put this after the method name, and then it automatically deduces that what you want to do is a generic, and so then you can use T, and it works like that. You could also then do this, and that should work fine as well. If I understand correctly, it's been a long time. I don't remember if you can actually do that, but you should be able to do that. Anyway, it's like the same thing, but yeah. Alright, sorry to break your mind. Jeez, that actually hurt my head trying to explain that, because I was like, frick, I get how templates work, but I was like, how do I explain how templates work? Like, you know what I mean? It's weird. They're such a complicated idea, but they're also so simple, and it's like so weird. Just like play around with them a little bit and like look up some examples of them too, and I think you'll get it. It's basically just like a really fancy, powerful text replacement, and it's really handy. If it helps too, have you ever noticed how like when you make a vector, for example in C++, you actually type like vector and then you put these brackets here like this. Well, you put less than greater than signs, right? And then you would put like your type inside that, and it's like, why do I type this, right? I mean, obviously it's to say what you want the vector to hold, but it's like, what is this, right? Vector is actually a template class, and this is actually the type name for the vector. So yeah, this is T basically. So what you're passing in is you're saying make a vector that holds ints, and it does. It's all templates. If you see these less than greater than signs anywhere in C++, it's well, anywhere after a class name like this, it's a template. C++ is just wow, yeah, it's versus C, which is like you got data and you got functions and then you got these pointers and that's it. If you get that, you get C. And I'm not bashing C, right? That's good. Like, how do we go from that to like, alright, so templates, alright, so virtual function tables, alright, so STD optional, alright, so size T. Well, to be fair, size T was in C as well, but anyway. Oh. You understood everything I said perfectly? That's awesome. I'm glad. Alright, so with all that said, we're gonna code now. Sorry for blabbing for like a year. So the first part of this equation, I listed out this whole thing here. We just need to implement it all. The first part is the shader. So this is going to be changed a little bit, I think, actually, from how I wrote it. I copy-pasted that comment here, as you can see, for a quick reference. As I started typing out, though, I realized I could make it a little simpler than how I had it. So basically, what I think I'm going to do is, yeah, I have an eye shader variant class, which is an interface. Again, if it begins with the eye, it's like an interface. If you don't know what an interface is, you should know it from, like, if you've done C#. But if you don't know what an interface is, it's basically like a class that... It's like a blueprint for a class. So it's like, eye shader variant isn't actually like a class that you can create. It doesn't like exist yet. But you can create classes that are built from the eye shader variant blueprint. See? So if you use eye shader variant anywhere in your code, for example here, I'm returning an eye shader variant, a pointer to an eye shader variant. What I'm actually returning is a pointer to a class that is built from the eye shader variant blueprint, if that makes any sense. So that's the purpose of interfaces. In C++, they're actually called abstract classes, but it's like the same thing. And basically, all you need to do to make one is you just make a normal class, except you have at least one member in the class where you put equals 0 at the end. That isn't a data member. So like if you have like this in a class, that doesn't make it an abstract class. That just sets a to 0. But if you have like a function and you put equals 0 at the end, that makes it abstract. The idea is basically, what is this? Oh, it's the 7 Rings in Hand, Black Knight rings. So the idea is virtual functions are basically like function pointers, if that makes any sense. So they're basically like a pointer to a function. When you call a virtual function, what you're actually doing is you're like getting the pointer to the function, and then you're jumping there and you're calling that code, if that makes any sense. So because it's a pointer, you could technically set it to null. See? So if you set it to null, in this case 0, then what's happening is you have a function pointer that points to no code. So if you were to call that, you would get an error, because what's happening is you're trying to run nothing. See, you can't do that. So thankfully, this is actually part of the C++ standard, if I understand correctly. Anyway, this is the compilers understand this. This isn't just a trick. This isn't a fancy trick I'm doing. This is like a thing that normal C++ programmers do. The idea is the compiler is actually going to figure out if you try to call one of these functions that's set to 0 like this, it's going to go, hold up, buddy. No, you can't do that. You have to call some code, and it's not going to let you compile it. So this is actually a safeguard, believe it or not. It's not a security problem. This actually improves security, in a sense, because it forces people who are building classes based on this blueprint to implement these functions and make them not 0 anymore. See? So that's the purpose of setting it to 0 at the end, like that. So as a quick example, iArchive, for example, I have this extract virtual function, so it's like a function pointer, right? Which is set to 0, it's set to null. There is no extract function here. If you try to create an iArchive, you'll get an error because there's no extract function that needs to have one. Then I have lots road archive at the end here, which extends from iArchive, see? So it's going to be it's a function that follows the iArchive blueprint. And so it has that extract function in it, just like iArchive did, except this time it actually has overridden it. So when you put the override keyword here, what you're saying is replace that 0 with a pointer to the code that I'm about to specify. And then in roadarchive.cpp, I specify it. So it's going to replace the 0 with a pointer to this function instead. Wow, this is huge. I forgot how big this was. But yeah, there you go. So whenever you call... Basically, it's just a way of doing object orientation. So when you can have a vector of iArchives, and you don't care, well, like pointers to iArchives, and you don't actually care what types of archives they're really pointing to, as long as they're a class that extends from the archive blueprint. And so then you can just say archive.extract, or, well, you know, whatever, extract. You call extract, and it'll figure out the appropriate version of extract to call and then call it. That's why we're doing this. So anyway, yeah, so what we're going to do is we're going to make a blueprint for shader variants, A shader variant is going to contain a virtual destructor because you need to have different destructors per type, since otherwise basically you need to tell it how to clean up this class, and if the class is like a different size than the blueprint, then it would need to have a different destructor, see? Because it needs to know exactly how many bytes to free. So yeah, that's why it's virtual, if that makes any sense. Then you have these functions, and these are the point of this is gonna return the size of the bytecode of this shader variant. This is gonna return the bytecode itself via a pointer to the first byte. This is gonna return signature bytecode size, and then finally the signature bytecode. Yeah, and I also want to have setters and shader variables, but we'll do that later. So then we're gonna have the shader itself is going to contain a function that returns the variant count, and then a pointer to an array of variants. It's also then going to contain a function called variant index, which is going to basically take in a string that says the type of variant that you're trying to get, and it's going to return an std optional, which, okay, so an optional is, have you ever in C#, in C# you can have types like this, right? But you can also put a question mark at the end, and if you put a question mark at the end, you get what's called a nullable type. So basically this makes it so that you can actually do this, and that'll now compile in C#, that'll be fine. So the purpose of that in C# is that you can basically have functions that return either a value, or they can return null, basically based on if the function succeeded or not. So it's a way to basically not have exceptions be thrown, and still not have to I don't know, it's like a neat way of like checking to see if the function succeeded or not without having an exception that you have to catch or whatever. So an std optional is a value that either can contain a result or can contain null. So basically if this function succeeds, it's going to return the index in the form of a size t to the shader variant within this array that corresponds to the type that you just passed in. If it fails, as in if this type was actually not present in this array, instead of like returning -1 or whatever, we're going to return null as an optional. So basically you can just check to see if the result that was returned by this dot has value, and if it does, then it succeeded. And so it's just a cleaner way of checking instead of having to check for null. Okay, so yeah, the only problem is, so what if we want to have multiple variations? Right, so these shaders are hard to explain, but basically you can have combinations of different types. So like, for example, you can have a shader variant that's used for deferred rendering, and you can have a shader variant that's used for HLS correction. Just as an example, I just pulled 2 random attributes from that other plus dump that I did in the last stream. If you have these 2 attributes specified at the beginning of your shader, then this means that you now need a default shader. So that's going to be shader 0, right? You're then also going to need a deferred rendering shader. That's going to be shader 1. Then you're going to need one that contains... Okay, you're going to need HLS correction. That's going to be shader 2. And then you're going to need one that's both deferred rendering and HLS correction, and that's shader 3. So you're going to end up with 4 shaders in total. If this makes any sense. And this value grows exponentially based on how many parameters you have. This is the thing that Scythe figured out. So basically, if you take 2 to the power of n, that's what Scythe was saying, you get the count of parameters. So in this case, n is the amount of attributes, which is 2. See, enable deferred rendering and enable HLS correction, 2. So 2 to the power of n, which is 2. So you get 4, which is the count of attributes you need, see? And it does that for each. It just grows like that over and over again, based on how many you need. So, what's really clever about this, because I was like, why did Sonic Team do it like this? I couldn't figure it out. And I got it now. It's all clear to me now, and it actually is freaking brilliant. So here's why they did it like this. Basically, you can write out code like this. You can actually say shader dot variant variant index, pass in that string. Okay, see. And then shader.variant index, whatever. Now, hear me out on this. Let me show you what I'm doing here. Okay, so if you call this, the function, all that you have to do is basically, okay, so this is 0, right, in the attributes list, and this is 1 in the attributes list. Okay, so if you just take 1 and you left shift it by the index of this, so in this case, let's say enable deferred rendering, right? The index of that is 0. You get 1. Okay. Hey, look at that. That's the index of our shader. So you can just return, so you just return that and you get 1. So then let's say you call this with enable HLS correction. Okay, so 1, you left shift it left by 1. Hey, 2. Hey, look at that. You see what they're doing? Okay, so here's the brilliant part. So what if I want to have a shader that both has enable deferred rendering and enable HLS correction? Just get the two indices and then bitwise OR them. So you could literally just be like this. Long code, but you get what it's doing, right? And so then what you get is, you get 0 from this first one, you get 1 from the second one, and then you're gonna, no, I'm sorry, you get 1 from the first one and you get 2 from the second one. And then you bitwise OR them together, 2 and 1, you get 3. Hey, look at that! Do you see what they're doing? It's freaking brilliant! So this way, they can very quickly and very easily, with just some very simple bit arithmetic, get any combination of shaders that they need. I see why they did it now, and it's actually very clever. And I believe the Hedgehog Engine 1 does something very similar to this as well. So, yeah, HedgeEdit's gonna have code like this in it, except hopefully not that long of a line, because, geez. But, yeah, so then all you need to do is, once you get this index, in this case it's gonna be 3, right? Which is this far already. You would then literally just need to say, like, shader.variance, and then you would just put in the index. So you could say, like, you know, this, and there you go. Now you have the shader, right here. Like that, whatever, right? You get it. And this code is enough to, get a shader that has enable deferred rendering and enable HLS correction both at the same time. If you don't want to enable HLS correction, just get rid of that. Done. If you don't want to enable deferred shading, get rid of that. Done. If you want something else added in there as well, just add it like this. You know, whatever. It's easy. It's super fast. It's very good. So I like that. It's a good format actually. It's very clever. Yeah. So this is all we should actually need then. If I understand correctly, anyway. Now I wanted to also actually have this virtual function here, called variant, where you would pass in a variant type, and instead of returning the index to it, it would actually just return a pointer to it. Because in some cases, you might only have like one variant, and you just want to get the first one, and it's like, come on, dude, just like give me the first one, right? Well, in which case you could just say variant 0, but anyway, you go saying like, there might be some cases where this is more convenient. So I was like, oh cool, I'll just do this, and I'll just put in this default function right, you know, right here, and I'm just gonna have it so like it's just gonna call my variant index function, and it's gonna store that, and then it's gonna check if it has a value, and if it does, it's gonna call variant, and it's gonna get the one with that index. Otherwise, it's gonna return null. And it's gonna be great. Why is there an error? Oh. And yeah, basically what's happening is I'm trying to put something that isn't. I'm trying to return a pointer to a straight up blueprint class, not like something that's derived from a blueprint class, if that makes any sense. Not like something that's like built from the blueprint, which is, you can't do that. You have to ensure at compile time that there's no way you can end up in that scenario. So this is not gonna work. I could probably get it to work with some tricks or something, but I'm not going to do that. It was only for convenience anyway, and it really isn't that convenient, so I'm just going to do this. I think the implementation is actually good enough. For now anyway, that seems fine to me. Yeah, so we really just need to actually go and implement the shader itself then. You'll show me a clever shader format in a minute? Alright. Bazooka's so far smart. Oh gosh. Bazooka is so smart, and then I started to say shader format and I said that. Good job, Brad. Bazooka is so smart, his shader format is so clever. Yeah, he is. You still want the Windows 10 calculator? Everyone does. Until they saw, this. Roger's so funny, thank you. Thanks, Ichigo. I'm accidentally like this. Yeah, so Microsoft did a thing. They open sourced the Windows 10 calculator. Which kind of surprised people because it was like, you open sourced the frickin' calculator, but okay, not complaining, that's cool, right? However, it's quite fascinating. So it seems like the reason they open sourced the calculator was because they wanted people to be able to use the code for this as a simple example as to best coding practices for how to make universal Windows platform apps, which is a neat idea. That's a really clever idea, I think. It lines up with Microsoft's, like, you know, open source policy. They just bought GitHub, and you know they've been pushing for open source for several years now. They're really pushing hard to open source as many things as they can. Still not Windows, but anyway, you get what I'm saying. They're open sourcing a ton of stuff, like they open source like Roslyn and .NET Core and all this awesome stuff. So it's really cool to see them open sourcing a calculator. It's a good idea, even though it's kind of a, you know, it seems a little silly at first. It's a good idea. I think it's a genuinely good idea. However, there's some interesting things about this. I kind of had a field day the other day yesterday on Twitter when I saw this, because so all right, here we go. Ready? Just scroll down a little bit. Okay. Data telemetry and telemetry. Oh, this project collects usage data and sends it to Microsoft to help improve our products and services. Read our privacy statement to learn more. And then it's disabled in development builds, only in development builds, but by default. And it can be enabled with the send telemetry build flag. So when they release a version of the Windows Store, this flag is set. So. Frickin' calculator was collecting telemetry the whole time. What information could this possibly be sending to Microsoft? So I looked because I was curious. For the send telemetry flag, it actually seems pretty innocent. They only really seem to use it for this. Basically, it seems like if the program crashes, they send Microsoft information that explains what the error was and things like your build of OS and basically like information they could use to try to fix that bug, which is interesting. They also have it also sends critical data and measures. I mean, who knows what that is? I actually searched for this, and, you know, GitHub search is excellent. I say sarcastically, but it only picks up these two. I don't actually know if they included the code that sends data to Microsoft in the open sourcing on GitHub. It doesn't look like they did. So that's fascinating. They didn't want us to see that part, because they didn't want us to see what they collected. Interesting. But yeah, calculator collects some crap. Okay. But it doesn't stop there. So then you have report security issues. Guys, I found a bug in calculator. You're not gonna freaking believe it. This is earth-shattering. When you click C twice, your computer goes BOOM! It explodes into flames, and all of your bits are sent wirelessly to the US government. This is a huge security flaw. Please patch it. I'm sorry, I'm being really rude, but like, really? Like, security bugs and okay. But here's the best part about it to me. There's now an official Windows calculator roadmap that explains what Microsoft wants to do with the calculator. What could you possibly freaking add to the calculator? You might ask. Well, so I thought about it a little bit. I was like, what would I want in calculator? And I was like, well, let's see. Well, in the Windows 7 calculator, in the history, there was, with the history button, you could, it was really neat. You could actually say like 2 plus 4 and then, whoops! Oh no! I meant to type 2 plus 3, not 2 plus 4. Ah, so you could go to history and then you could double click here, and basically it would let you type, backspace that 4 and replace it with a 3, and then hit enter, and then it would recalculate it for you, and you wouldn't have to redo your whole equation, step by step, which was nice. In the Windows 10 one, you can't do that. So you actually just have to go clear and then just do the whole thing again, but type the new value this time, which is a little annoying. It's not a big deal, but it's a little annoying, so that would be a cool thing to add. Oh, in programmer mode, it doesn't have history. 4 plus 4 is 8, cool. It's not in the history. It's just not there. It just isn't there. 5 plus 7, that's 12. Where's 5 plus 7? Let's see. Oh yeah, it's not there. It for some reason, there's a history button in programmer mode, but it only pulls up the standard history. It doesn't... That's dumb. So that'd be cool to have a programmer mode history. What else? Oh, I'd like to be able to have floats. You can have keyword, D-word, word, byte. That's it. It'd be nice to be able to do like 1.5 and get like the, you know, IE float equivalent, and then you could like convert it. That'd be sick. Those are really the only things I can think of though, right? Okay, so here's what Microsoft thought of. Ready? Here's what they want to add to calculator. Drumroll, please. Alright. They want to refine the open source development process on GitHub. Well, of course. They want to iterate upon the existing app design based on the Fluent Design guidelines. They want to change the design to make it fit Fluent Design better. This doesn't already fit Fluent Design? Okay. They want to improve testing and diagnostics within the project. Okay. And here are the new features. Ready? They want to add some new features. Here we go. They want to make it so you can pin calculator on top of other windows. Like, so I guess I don't really know what that means, but I guess like you could click a button and then it would like stick to the top right of Chrome or something, and then you can just like use Chrome and calculators floating there like that. That's interesting. I won't say that isn't useful. It might be, but like that's interesting. They want to provide additional customization options. That one's funny to me. Like what? Like what are you gonna do with the... Oh man, I really want my calculator to be green. Now you can! Whoa! Like, who cares? I guess like maybe like rearrange button layout or something? That's kind of neat, I guess. And then your feature idea here, and they want to have people propose things on GitHub, which is neat. So one last thing about calculator. Then I'll go back to what I'm doing. People did propose some things, don't you worry. They proposed several things. Some of them are very good ideas. Someone actually mentioned the idea I came up with that I mentioned earlier, with supporting floats. And someone actually, I didn't even think of this, but someone mentioned the program mode doesn't support unsigned values, and they're right, I didn't notice that really, but it doesn't. If you were to say, like, just type all of the F's, right? You get -1, which is what would happen if you had a long, yes. But what if I want a U long? There's actually there's no way to do that in this calculator. So that would be neat to have a button to toggle signed or unsigned. So that's a good one. I agree with that issue. There's some other things. Here is the interesting part, and I'll stop after this because this is the part that was the most hilarious to me. You ready for this? All right. The source code. Now, it's a calculator. Alright, let's just be real. This is a calculator. This code is probably going to be pretty simple, to the point. You know, you're going to like look at the code, it's going to be like, oh, I get it, it's obvious. You know, that code adds 2 numbers. That code computes the, you know, the result of this. It's going to be easy. It's not easy. Let me, so they've got calculator, they have calculator unit test, they have calc view model, and they have calc manager. That's a lot of projects considering this is a calculator, but here's where it gets good. The GUI is the most important part of the, oh right, exactly, but the GUI is not what I'm talking about, because the GUI I'm sure is actually managed fine. It's the non-GUI stuff that shocked me. I can't even find it all of a sudden because it's organized so nicely. Alright, let's just go to a random one. Calculation result.cpp. Okay. Alright. Okay. Alright. So they're using WinRT managed values instead of standard C++. Okay. They have... I don't know how to explain this to you, but when you look at this, some of this code, some of it is a freaking mess. The other day someone was showing me some, yeah, Alex, he was showing me some examples of the calculator source that I could not freaking believe. Okay, here we go. Number.h. So this is the code in the calculator app in Windows 10 that represents a number. You ready? Alright, so they have 4 bytes, a whole int, to represent the sign, whether the number is positive or negative. You need 1 bit for that, guys. You need 1 bit. You had 4 bytes. They have 4 bytes to represent the exponent, and then they have a vector of uints to represent the meta. Like, what the frick are you doing? Then they have getters and setters for the sign, the exponent, the meta, and then they have private values for them. Well, no, they have getters but no setters. No, they have getters that return constant references. Okay. Why can't I just set the sign? It's a number. I should be able to say number.sign equals whatever. But you can't. Because they wanted to ensure code safety, I guess. Oh. And the whole code is like this. With padding, the 1 byte would just be 4 bytes anyway. No, it wouldn't. If you put it at... Okay, well... Yes. So if you have a struct or a class and you have a bool, and then you have an int, and then you have the vector, then yes, with the padding, that would become 4 bytes. But you know what else you could do? You could delete this entire thing and replace this with float. Or double, if you want it to be more accurate. This is the same thing as a float or a double. Except this allows you to be more accurate. So, okay, this allows you to be more accurate. That's cool. So if I were to say, like, oh, I don't know, let's think of something kind of insane. Just type random freaking numbers. Oh, look, it still cuts off around the same area a double would cut off at. That's interesting, isn't it? What if we go to scientific mode and we type, we hit pi, right? So there we go, okay. Let's see, pi as a double. I want to see, like, oh, here's some Apple documentation, that's fine. It cuts off at, actually I think it's more accurate, but let's see. It cuts off at 979, so actually this is a lot more accurate than the double is. But, like, okay, I see what they're thinking, but it's like, this seems a little silly, doesn't it? It seems like a little overcomplicated, and the whole code is like this. It's basically like, they overcomplicate a lot of things that really don't need to be that precise. They have a... Don't they already have a decimal type? They do in C#, I don't know about C++. Don't they have that? Well, there's like libraries that do it. Okay, so but like implement a 128-bit decimal if you really want it to be accurate. Don't like have a vector of uint. What are you doing? Like that's bizarre. Anyway, there's a lot of examples in the code like that. He was guiding me through some of them that were ridiculous to me, but I was laughing quite hard at some of them. Yes, because it's just beautiful. Like it's a calculator, and it's like, why don't we have a vector? Type mpi and press F12. What's the number? Aussie median to include that. Oh yeah. Is that the constant in? Okay. Is this... It's not the speed mended, everyone. Yeah, I don't know what library that's in. That's just math.h. Like that. No. The math library. Yeah, I don't actually... I'm still, like... I know this sounds crazy because I've been talking this whole time, but I'm actually still new to C++. Like, I'm still learning things. Where is MPy defined? It's part of the POSIX standard. Okay. That should be in... It's a mathematical constant, so what header is that in? Math.h. That's what I thought. That's what I included. Well, I don't know why that's not... Like, let's just say double. Just let me type, please. Alright. You gonna figure out where that is? No? Alright. Oh, there it is! It just took 9 years. Anyway, that's the double value for that. So it cuts off at actually 846. Versus Pine Calculator, which goes actually a little farther. It then includes 264, 338, 32795. So it's more accurate than what they are storing in a double. But still, it's like, I mean, do you need to be that accurate? Like, I don't know. The people had a field day with GitHub. Bug report can't divide by 0. Yeah, I'm sure it was hilarious. Okay, but one more thing, and then I'll stop blabbing a calculator. I just thought this was so funny. I'm sorry. There was just so many things about it. Right, so here we go. So they said they want to be compliant with the C++ standard. They're trying their hardest, apparently, to write all of their, not just with calculator, but with all of their code. They want to make it C++ standards compliant. Alright. What they're doing is, what they're doing though is not actually that. So let me show you an example. This is a header file, right? They have an N32T in it. And a UN32T. And a vector. I don't believe they're using... Yeah, they're not using namespace std in the header file. That would be a bad practice anyway. And they didn't include std before this. So that's not technically standard C++. That's breaking the standards because they didn't specify what namespace this was in or include the header. Like, that's only gonna compile on Windows, you fricks. And that's not me making that up, like, oh, they want to comply on the standards. Oh, totally. No, like, they said, yeah, they want to adopt standard types, and they want to make this, yeah, my understanding is the best way to work across multiple compilers is not only to include standard int, but also access the type through std. And then, yeah, they show the exact example I was referencing. They don't include std. What are you doing? So wait, where's ratpack at? Maybe that includes it? Ratpack.h. I typed a dot, but whatever you say, keyboard. GitHub search is bad. How do you search for a file again? Oh, you hit find file, that's it. There it is. Alright, does this include it maybe? No, what about centered int? No, it doesn't include any of them! That's the only file it includes, which I'm sure doesn't actually contain... There's a keyboard shortcut for find file, but I can't remember what it is. I'm sure this doesn't... What the frick is this? Yeah, this doesn't include anything. So they don't... Yeah, they're not including that at all. This would not... Like, this is purely Microsoft specific. Even though they stated in... I thought even in, not the README, but they stated somewhere else that they wanted to be standards compliant. Anyway, I can't find the exact issue now, but I saw it, I swear. Like, I saw a Microsoft employee who was like, yes, we've been working hard to make it standards compliant this whole time, and it's like, no you didn't! What is this? Sorry. It was like, what are you doing? Anyway. Radpack? Oh my gosh, it's actually called, frick, no, it was Ratpack, wasn't it? Anyway, where do they store the number from? Yeah, so they're not actually storing it in a double, they're storing it in the number class. So then they're like turning it into a string, I guess. But yeah, but So you know what this means too, right? So the plus side of it is that it lets them have numbers of, I guess, technically infinite, accuracy, right? There's like no limit to how accurate they can make it. But in practice, you can't do that, right? You need to, at the end of the day, have the CPU actually compute something with the numbers, right? And if you're going for infinite accuracy, you're going to have to go against all of the optimizations that the CPU has built in, right? And you're going to actually have to like roll your own type, which means rolling your own functions. And basically, what they're doing is, instead of actually calling upon the standard like opcode, right, for dividing floats or for adding floats or subtracting or whatever, they basically have their own like simulated versions of those opcodes, which of course is way slower because you have to like jump through all these hoops instead of just asking the CPU, hey, divide the two, please. For some numbers, yes, you want it to be more accurate. Like for pi, it's cool to have more numbers there than what you could hold in a double, for sure. But for like 4 divided by 2, oh, it's 2. Just use a float, you know what I mean? Like, it seems like they should have a system in place where they could switch between using a float or a double or this fancy number type, only based on if they need it. But they don't do that. They always use the complicated one. So anyway, people were having a field day yesterday because it was like Microsoft purposely published this to the internet as an example of good code practice. And then they didn't even write standards compliant code, even though they said that was one of their goals. And they didn't... I think someone found a security bug? No joke. Someone found a bug where for some reason it was resetting the result if you hit C twice or something. No, not resetting. It was like... I don't know how to even explain it. It was like... It was really hard to explain. He did his best. He had pictures and everything, but it was like... You would like type in a number and you would do some calculation and then you would clear it. And you would do another calculation and clear it, and basically for some reason it would spit out the result of the first calculation instead of 0 when you cleared it, or something like that. And it was... Oh my gosh. My point is, it's a mess, and it's just funny to me because it's like, this is a calculator! How hard can it be? Anyway. The accuracy is limited to your RAM. Well, yeah, it's true. That's true. There's no such thing as no limit, right? It's like... At some point you have a limit, but it's virtually limitless, you know what I mean? If you have a vector of ints that represent the, you know, exponent and everything, then you could pretty much have any number you can fathom. Sorry. Abandon HedgeLib and just fix calculator for Microsoft. I should just make a pull request called fixed it. And it just deletes all the files in it. No, I'm just kidding, sorry. Watch your premiere? Oh, heck. I can't watch on the stream because it's Thomas? Oh, okay. If anyone wants to see it, check it out. It's gonna be epic, I'm sure. You're pretty sure your video get blocked worldwide? That's gonna be epic, dude. Whatever you say, keyboard, said the Sonic 06 programmer. Yeah, they just went like... And that's how the game was produced. Alright, let's freaking... It's a programming stream. Jeez, rad. Holy frick. Alright. So... We got a shader, we got Forces shader, it's extending from that, that's all cool, that's all Gucci, that's all gang. Alright, now we need to do a thing. So basically, alright, so we're gonna grab these, and we need to actually extend. So what we're gonna do is we're gonna put them here, gonna get rid of the virtual parts, and then instead of having equals 0, we're gonna say override. Yeah, this is... C++ has a lot of this stuff you gotta do. Let's put that down there. Alright. Yeah, we're gonna copy all this. We're gonna go to our forcesshader.cpp. It's up here. Cool. This comes after read and write for forces shader, which should be at the bottom of the file. Yep. Alright. We're gonna paste all this here. Get rid of the override. Because, again, this is all stuff we gotta do for C++. Isn't this such an easy language to write? Like, it just, like, rolls right off the tongue. Alright, now we're good. You left something epic in the chat? I don't see it, but... Oh, in his chat. Sorry, I'm being dumb. Yeah, if you all want to see what Static epic post is, you all better check out the chat. Alright, so this is going to be our overridden versions of those functions from our blueprint, basically. So the variant count we're going to return as a size t. It's just going to be shaders.size. Alright. Then for variants, we're going to return a pointer to shaders. So shaders dot, I guess cbegin is a iterator, right? Yeah, and so is begin. They're both iterators. I just want the first value, so I guess front. That's a reference to the first one. What about data? Is that a pointer to it? Yes. All right. I'm still feeling my way around the C++ library, like the standard library. I'm sorry. I mostly get things, but there's a few things that I'm like, admittedly, I'm still like I'm still learning. All right. Yeah. Okay. So what I'm gonna do is, and I don't know why the music stopped again. Sorry about that, but I'm thinking about this a little bit here, and I'm actually not sure of one thing. Basically, how am I gonna... I want to do this with smart pointers, so I need to think that out a little bit. I certainly didn't do that here. When I made the Hedgehog Engine model class, I went down here and I returned, this is it, some mesh contains a vector which just contains face. Oh, so I see what I did. Okay. Oh, that makes sense though. Yeah, this is fine. Okay, so I'm being dumb. Sorry, I'm overthinking this. So, all right, I'm gonna rename a few things because I think this is more fitting. So instead of like shaders, I'm gonna say, well, no, I'll say shaders, and then no, okay, I'll say variants. Hear me out. Instead of indices, I think I'll keep that for now, and parameters as well. Okay, so instead of h and shader, I'm gonna say like h and shader variant. All right, and oh, whoops, I see why I did that. That's fine. It's a little confusing, but that's fine. You need a hedgecalc.exe? That would be epic! It's like calculator, but with the power of Binet. Alright, so instead of h and shader, I'm gonna have, this. Can I not contain that, though? That seems... that seems like that shouldn't work, but... whatever you say. Yeah, you know what, I would feel better, like... hang on. Just doing that. And then when I go to return a pointer to it, I'll cast it, so like, hear me out. So when I go up here, I'm gonna say... okay, this is a direct loaded type, actually. So I can't do that. Oh, frick. Oh, wait, no, it's not direct loaded. I'm being dumb. Okay, yeah, I'll just do this. Public, I shader variant. So we need to include the other file as well. Just to be safe. Okay, down here we're gonna say, yeah, I shader variant. We're gonna copy paste all this. Oh, we also need the destructor to be a thing. Okay, so I'm gonna put it all down here. Instead of this, I'm gonna say equals default. I don't remember what I did for that with HE model, so I'm gonna look at that again. It's all down here, but like, I said override, and I just, yeah, I said override equals default. Okay, so I was like, about the typo. There we go. And of course you have to call it what class name is. Alright. If it didn't get blocked yet, maybe it's still safe to show. I don't really want to take a chance, but maybe, hopefully. Every number is a decimal and it's stored in a Binet header. Oh, it'd be beautiful. Alright, so we'll go in here then. After it's before read for force the shaders, so before all this, but after this one. Yep, alright. We would have all this. I'm gonna copy paste that. Like such. Alright, and I like, again, how much code we have to write in C++. Every single time. It's like all this tedious crap. Alright. When we go to return the bytecode size, we're going to return... Let's see. We got shader, and then we got it's holding a bytecode size. Okay, so shader.bytecode size, and then we're going to cast it like that. Alright, we're going to do the same thing with this. Whoops, I didn't type that right, but Visual Studio fixed it for me. Alright, then for the bytecode, we're going to say return shader.bytecode, and this is going to be a unique pointer to this. So we're going to say get, and that should return the C pointer to it. Yep, that should be fine. We don't even have to cast anything for that. Same with the input shader. Alright. So now down here, we're going to say shaders.data, and this is still giving us an error even though HN shader now derives from iShader variant, which is just great. So we're going to have to reinterpret cast this. But can we actually cast pointer to... Wait, let me think about this for a second. Is this what's known as a downcast or an upcast? I always get confused. Base... Hang on. Yeah, to base type. I saw a psychophobe thing on this, but... Okay, so we've got base, we've got derived, we have a pointer to derived, and then we want to set it to base. It says it's implicit. Thus, the following is perfectly fine. So this is implicit. You should be able to just set a base pointer to a derived pointer. So this code should just work then. But of course it doesn't, because that's too easy. All right, so okay, let's see. Upcast are very safe. This is an upcast, I guess. Downcast are not. Downcast would be... Okay, wait, so D to B, that's an upcast. So, okay, so think of it like you have B first, and then you have D, which is built from... then you have D, which is built from B, yeah. So you're going... D is underneath B, see? Like this. So you're going up. Okay, and then down would be going the reverse. I get it, okay. So... A downcast is, yeah, that would be harder, of course, because you might have more elements in the derived one, so that you need a dynamic cast for that. But upwards is easy. Okay, so just frickin' upcast. No, I don't want downcast. Yeah, you don't have to static cast a base class. The static cast is to go the other direction, so this is fine. The time you'd have to do static cast is something like casting A to a derived class B. So wait. So if you want to... What? That's dumb. Nani? You don't have to static cast to the base class. Yes, I do. It's not compiling. Its intelligence is being dumb. No. Does not match the function type. It does though. Okay. Well, because it's being stupid, I'm just gonna straight up, like, I don't really care. Ooh, you can't do that. It's an invalid type conversion. No, it's not. Oh, it's because this is constant. It's because this is constant. I get it. I feel ya. Okay, so if we get rid of the constant at the beginning of all of this, then we should end up with yeah, now it'll work fine. I get it. That's dumb, but I get it. What? Use your own floating point of 4096 bits. Sorry if you can hear the dog in the background, by the way, it's our neighbors. I finally have the the hound part in my name. It's finally real. Just stretch the video and put it upside down and change the colors to disrupt the audio, and there you go, yeah. It's as easy as 1, 2, this video has been shut down by the FBI. It's simple. Alright, so variant index, so this is the interesting one. So what we gotta do is, we actually have to iterate through all of our parameters. I guess I'll call them attributes again. I can rename all this later, it doesn't really matter to me, but... Okay, so we have to say, like, parameters dot... You can't just find, right? Let's look up how to do this, too, because this is gonna be... Yeah, like, find... Let me think about this again, too. We've got... these parameters which contain a string, right? It's like a straight-up string. Yeah. So we actually have to go through all the parameters. And we have to check to see if they... I'll just see if, compare string to string view. There's actually a straight-up compare function. Okay. So for auto parameters, that's gonna be a... Oh gosh. An iterator. Cool. That eventually contains that, I guess. Okay, param dot name or type. So now we've got the name. Okay. Oh, it's back in time. It's a new song, yeah. And we're gonna compare that to the variant type. So variant type dot compare. Can we just pass in a string? I suppose not. What about param.name.compare? Can we pass in a string view? We can? I don't actually know about that, but let's just see what happens. There's no overloaded function that takes that type. Okay, so wait, because I'm being dumb. That worked fine. Oh, it took a string view. Okay. So that should return 0 if they match, right? Negative value if this value is less than the other character sequence. 0 if they're equal. And positive if... Yeah, okay. So if this is 0, then we want to return the index of it. So no, we want to return 1 left shifted by the index of it. Right, because I explained all that earlier. So, okay, we need the index then. So let's actually do that. And we're returning a size t. Okay, so it makes sense to use a size t then, so we don't really have to cast it as much. I is less than parameters dot size was I. We're gonna say parameters dot name dot compare, and then if they match, we're gonna say return 1 left shifted by I, which is apparently an int. Okay. So let's... Even though I went out of my way to ensure it wouldn't be an int. Need one. Alright, wait, can we do this? Yeah, I feel better about that for some reason. Even though it looks stupider. Okay. So that's gonna left shift 1 as a size T by I, and then it's gonna return the result. Okay, and there we go. So now, if we get to the bottom of this and it has not found a matching parameter, then we're just gonna return nothing basically. So what, like, actually forget. No. Sometimes I can't type. Null opt. That's it. Yeah, so this is in... It's just... Oh, it's std null opt. Okay. Like that? Why can't you return that? Type name is not allowed. What? I think you're being stupid. Oh, they exist to support both this and equals null opt. Oh, so you can just do this. Okay. Cool. Alright, that makes sense. So this is the object of that type. And this is std. Yeah, it's an std. Okay, so this is what we're gonna return if... So it's like returning null when... It's basically like we have this. This is the C# equivalent of this part. See? Isn't it so much easier to write too? Actually, the C# equivalent would be more like isn't a ulong actually sorry, isn't size T actually a ulong? Yeah. The C# equivalent would actually be more like this. Which might seem like you might be panicking like, why are you using a whole ulong for this? But actually it's just as fast. If you it's because this fits into a register in a 64-bit CPU really easily, so it's really quick to move it around, and it can hold anything you can fathom, basically. If you actually compile this as a 32-bit program instead, and you hover over this, it's actually going to be... If IntelliSense will freaking work. It never does. Well, okay. Yeah, if it's there, you can see here, if it's 64-bit, it's gonna... This size T is gonna be a ulong. If it's 32-bit, it's actually gonna be, like a uint. So it's actually gonna be the right size. It needs to be according to what CPU you're compiling for. So it's anyway, the point is it's gonna be as fast as it can be no matter what. Sometimes I ask myself, what am I doing here? Yeah, it's called depression. How do you initialize a vector in C++? You don't really need to initialize it, I don't think, actually. If you just write out like this, that's fine. Like, just that alone, you've actually created a vector that you can use. So all you need to do in the next line is just say, like, push back, and now you can start adding stuff to it. So this is the equivalent to the C# for this would be like that. So this is one scenario where C++ is actually more efficient than C# to write out, but that very rarely happens. Oh, that's a very serious question. That's gonna not work because I put a family-friendly tag on this stream. You're asking me to make tough decisions. But anyway, yeah, actually, Ichigo, you usually do need to initialize things in C++, so it's kind of confusing, but vectors are an exception, because they have like a default constructor that basically initializes them for you, from my understanding anyway. If you absolutely need to initialize them for some reason, you can also do this. And that works too. Remember, in C++, you gotta be careful. If you put new, remember, in C# that you use new to initialize any value, right? But in C++, new is gonna make a pointer, it's gonna allocate memory to it, and it's not automatically going to free it up later, right? So if you, for some reason, you wouldn't usually want this, but if you for some reason actually want a pointer to a vector, you can do this, and then this, and that'll work fine, but this will compile fine, but there'll be a memory leak, because at the end of this function, nothing's going to clean up W for you. So remember, if you use new, you have to then also later do this. And that way it'll be safe and there won't be a memory leak there. Because that'll automatically clean it up when it's done. So anyway, yeah, if you use new, you use delete. That's just a general rule of thumb. For every new, there should be a delete. If you don't use new, it's going to be created on the stack instead. It's not going to be a pointer. And when it's created on the stack, it'll automatically be cleaned up when it goes out of scope. So scope is basically the curly brackets that you're currently in. So in this case, you're inside of this function scope right here. So this is going to be cleaned up automatically when you get to the end of the function, whether it be here when you return or here when you return, it's going to clean it up. If you need to clean it up before then, and you don't want to do stuff with pointers, you can actually do this. No joke, you can actually make your own scopes like this. And when it gets down to this curly bracket down here, it'll actually clean up W for you. And then, yeah, W won't be a thing by the time you're here. Which can be very useful if you need it. Generally speaking, though, don't do this. Unless you have a really good reason to do it, because I know it seems like, oh, that's more efficient, but actually, it's actually faster a lot of times for the compiler to make a bunch of variables all at once, and then clean them up all at once. So if you're instead saying, make variable A, make variable B, make variable C, and then clean up variable C, clean up variable A, clean up variable B, you know, that kind of thing, it's actually a lot slower than just, because it can do multiple ones at once, basically. So usually trying to micro-optimize like this and trying to be like, oh, I want to clean up all my variables as soon as I don't use them anymore, that's actually a bad idea. Because the compiler, if you don't include these, the compiler will automatically figure out the most efficient time to clean it up, and realistically speaking, it'll clean it up when at the fastest way it can, basically. So only do that if you've determined for a fact that it would actually be better to delete something right then, in this case. In which case you can wrap something in a custom scope like this. But yeah, that's a trick you can do. Anyway, I should get Mule in the stream because it's National Women's Day? Oh, neat. Yeah, she's, I don't know what she's doing, actually. I think she was in a call with Taz earlier, I saw. I don't want to bug her. I know she doesn't usually like, she thinks it's cool that I do streams and everything, and she likes all of you guys. But she feels like when she's on these streams, in a way, that she's sort of, like, trapped, you know what I mean? Because it's like, you can't just be like, well, I'm gonna leave later, you know, like, I mean, you can, but she feels like she can't just leave. So she doesn't really like, I don't think she really likes being on the streams. Even though you know, we all enjoy her being here. So I don't want to force her to come on. But yeah, I will definitely give her respect. Just say it, she hates us all. No! She loves everyone. Except for the people she doesn't like. Which is very few, actually. It's none of you. I'm joking around, sorry. I'm just being stupid. Yeah, she loves all you guys. How do you delete the internet? Well, it's very simple. You just, and with that line right there, Cora, you've made a grave mistake. Where will you get your hentai? Sorry, frick. Alright, +1 respect for all women, yeah. Sorry, alright. Wow, Red! Is it me? No. She loves all of you. There's some people in real life that she knows that she thinks there is, how do I put this? In particular, she's like very mature for her age, and kids her age who act her age annoy her generally, because she doesn't like it when people act immature. I don't know, like, in particular, like, like boys, like in her class or whatever, who are like obnoxious, who are like you know, constantly making immature jokes and being rude to other people and not listening to the teacher and all that stuff. That ticks her off. She doesn't like that. But none of you do that. Sorry, I don't know how I got into this. You can relate so much with that. I can too, yeah. That stuff ticks me off. She really hates when someone's in like a class where all they have to do is like pay attention for like a few minutes and it'd be fine, right? But instead they can't even wait that long, so they're like looking at their phone. That drives her crazy. And me too. That's a huge pet peeve of mine too, when I see a kid like in a class who can't wait like 5 minutes for it to be over. Anyway. Like if they have, it's complicated, but like there's scenarios where the kid is like brought along to like pick up with the parent, right? Because the parent's gonna like pick up on, you know, someone else. And so the kid just has to wait a few minutes for the class to end, but it's like, no. It's too long to wait. Did you delete the internet? You did. How dare you? Where will I find my Ochako? What was the thing to initialize vectors? Oh, so just do that, and you've got a vector you can use. You can just say like push back now, and whoops, and it'll work fine. It's the equivalent to writing this in C#. Like that. So in this case, it's actually less code in C++ for once. That hardly ever happens. The reason for this, it's really weird. Usually you do have to actually define things. If you just do like, well, not always. It's really bizarre. Like, I think you can do this. Yeah, that's fine. But if you did this, like, that's gonna be a compiler error from what I understand. Oh, maybe not. It should be, anyway, if I understand correctly, because this is not defined yet. I think it's probably going to error if I try to compile this, but yeah, basically there's a difference between declaring something and defining it. So this is like declaring, whereas defining is like this, right? You can do both in the same line, but they are two separate things. Usually you want to define something, as well as declare it, right? In the case of vectors, though, they're kind of an odd exception. They have like a default constructor that basically defines them automatically for you. So just by writing this, you already have a vector that's kind of defined and you can use it. That's my understanding of it anyway. It's very weird. There are some weird cases where that doesn't happen though, so in that case you can do this. I can type correctly, oh my gosh. You can do this, and that'll create a vector you can use. Now, note, this is what I was saying earlier, Ichigo. I didn't realize you didn't see it, but note, it's important to realize this though, because okay, in C# whenever you create anything, you say new, right? And then that's all you have to do, and the garbage collector will automatically clean it up for you later when it needs to. But in C++, that's not the case. When you just write it out like this, what you're doing is you're creating a variable on the stack, which is tricky to explain if you don't already know what the stack is, but basically the idea is that you have like a stack of variables that grows whenever you need to add a new one and gets smaller when you need to get rid of them. And basically, yeah, this variable is on the stack, and anything that's on the stack is automatically going to be cleaned up for you when the stack when the variable goes out of scope. So basically, in this case, when basically it means when the curly brackets currently in are done with. So in this case, like you make W, so right here is when W is going to be added, and then right here or right here, it's going to return. So in that case, W is going to be cleaned up. See, so you don't even need to worry about it. W will clean itself up; it'll be fine. If you say new, however, what you're going to actually do is you're going to make a pointer to a vector. In this case, the pointer will be cleaned up automatically when it goes out of scope, but the value that it's pointing to will not be. So you need, this is going to create a memory leak if you try to compile this. So what you need to do in this case is when you're done with W, you need to say delete W, and then that's gonna actually take the pointer and it's gonna find the value it's being pointed to and it's gonna delete it. and then now you're good. Now everything's safe and there won't be a memory leak. So yeah, just keep this in mind if you're trying to learn C++. Basically, the rule of thumb is every time you type new, you should have a delete that follows it, right? And that's basically all there is to it. As long as you remember one delete per new, you should be safe. If you don't have a new, you don't need a delete. In fact, you can't have a delete, it'll cause an error. So just keep that in mind. Hopefully that helped. You want to initialize the vector to 69 longs in a single line. Oh, so you just want to set the capacity of it. Right, I think you can just do this. Yeah, you can just type that, and that'll make a vector that contains 69. Well, not longs. Okay, so this is kind of weird too. Long in C++ actually means basically the same thing as int. I know that's bizarre, but it's weird to explain. But basically, for a long time in programming, longs were actually just a fancy way to describe a value. It was 4 bytes. So if you want to have an 8-byte value, like in C#, you would actually put long, which is really stupid, I know, but that actually is going to be an 8-byte value. If you want to have... oh yeah, I already explained this, I forgot. Okay. If you want to do it in a C++ standardized way, you could go to the top of your file and put include C standard int, like this. And then here you can say this. And that'll create that's an 8-byte value. So this will create a vector of 8-byte longs, which are 69 of them. Sorry, and that'll work fine. And then yeah, this will automatically be cleaned up when it goes out of scope. You don't need to worry about it. It should all be fine. So yeah. How do you do a for each loop? So there's no for each in C++. There is, you can do a standard for loop like this where you have I and all that. But if you want to have the equivalent of for each loop, what you would do is, let me show you. You have these things called range-based fors. Here's how they work. Basically, you would say auto, and then you put the ampersand, which is the reference type. So you're saying, I want a reference to the value, like the current value that I'm looking at inside the vector. See, and then you would say, well, let me just do this. Let me show you real fast. Something. I'm just gonna type out C#, and then I'm gonna type out how you do the exact same thing as C++. So, yeah. I believe you can do that in C# too. And then you would say for each long L in W, and then do something with L, right? So in C++, the exact same thing would look like this. And then you could do something with L in there. So it's the same thing, it just looks kind of weird. If you hover over L, it should, yeah, it's an N64 reference. So it's pointing to this. Because this is actually a long, so it's like a number instead of a big complicated type, it's probably faster to just copy it. So if you just do that, yeah, you'll just get a long, and then that'll work fine. You can also actually do this, which will give you a, well, no, never mind. I thought you could, but I guess not. But yeah, this is gonna create a copy of, I don't know how to explain this, but basically, well, here's the difference. If you want to say like printf, you know, L, right? You wouldn't be able to compile that, but you get what I'm saying. Like if you want to print L to the console, that'll work fine. But if you want to do like this, you're gonna set the copy that was created here to 7, and not the value in the vector to 7. See? And then when you get out of scope, it's not, that line was pointless. It didn't do anything, right? Versus if you have a reference, in which case the same line of code is actually going to change the value in the vector to 7. So that's what the difference is, if that makes any sense. It's like typing ref in C#. But anyway, that's how you do it for each loop. Alright. Oh. I've been blabbing for like 2 hours straight. Oh, people are gonna tell me to do a break now. I shouldn't have said that. I'll do a break in a moment. but... Oh no. I hope people don't vote for that one. Okay, wait, let's see. SCD vector, SCD int64t, Izuka equals SCD vector, SCD long, 69. Well, you need to replace the SCD long part with SCD int64 under t. But yeah, but then let's see. For auto reference, Green Hill Izuka, Izuka.pushback 0. Oh, so wait a minute, you're gonna say for each number in Izuka, add another number, which is gonna be 0. So you're gonna end up with, you're gonna end up duplicating the entire vector, except you're just gonna have zeros at the end instead of actual duplicates. That's nice. Alright, I actually want to do a break. I just want to get something done first. Do a break, also known as dab. See, dabbing is a sin. You all shouldn't have said that. Alright, anyway, so we're looping through the variants. We're finding if we've got one that matches the type, and then we're gonna left shift 1 by I, which is the index of the type we just found, and then we're gonna return that. And that's not... Wait, let me think about this for a second. No. I want to return this. Where do I have indices at? This song is so good. Here it is. Alright, we're gonna actually, gonna do this with the result. Seems like it should be able to figure out automatically that what I want is actually the size T and not the freaking int. Oh, I guess it did. It didn't do that before, but okay. So cool, that's working fine then. Okay. And then this is gonna be just nothing because that's no. Alright. Now actually I should probably default to the default shader instead of... Yeah, I'll do that in HedgeEdit though, not in HedgeLib. You're gonna dab right now? Dab's there. How dare you. You hit the fattest dab. I can't even believe this. Alright, constant buffer variables, all that crap. I'm just saying. So actually we've already implemented the entire interface. That's epic. Sorry. So, okay. Cool. That's actually really sweet then. So, wait, no. Wait a second. Wait, no, it's more complicated than that. We don't actually want to return the index. We want to return... We don't want to return the index of the variant. We want to return the index of the, well, the index. Because we need to bitwise order these. Not the, oh jeez. I don't know how to even explain it, but yikes. Okay, so, okay, hang on. Oh, frack. The only problem is this makes our shader blueprint basically more complicated because other formats aren't probably going to need to, like, do that. But ours, we definitely need to. If we don't do it, it's actually a problem. So, okay, cool. Let's do this. Let's say, like, variant, maybe, like, let me think about this for a second. I don't want to say variant index because it's dumb. But I want to say, like, variant flags, I guess. Let's just say flag. And we could just have it be 0 if it's not gonna work out for us. Okay, yeah. So, should we do STD size T or should we do like a uint? It doesn't freaking matter. That'll be fine. Okay, we'll just say flag. And then what we'll do is we'll have another one that's like virtual STD size T. This one's gonna be the optional one. And this is basically gonna be what we did before. Variant index. This one's gonna say flags. And actually we don't even need an optional for this if we just return the default. Yeah, we'll just return the default if there's nothing else. So we can just straight up do this. And it's really easy. Okay. So that was easier than I thought it would be, actually. Thank goodness. Yeah, alright, we don't need that. Cool. So then down here we can just be like, yo, you fricking alright, yeah, we can do that. It's gonna be great. Everything will be good. I always lose my mind after an hour or two of programming. It's kind of amazing. Okay, so when we go to return the flag, what we want to do is, what? Type qualifier is not allowed. Oh, because I'm being dumb. Place your bets, ladies and gentlemen. It's Jet Set Radio Future. It goes on for 9 years. I'll skip it. If you add a new number to the vector you're looping through Azuka, it's going to have a capacity of 138 when it gets to the 69th element. Yes. And it's going to get to 70 as it's 139. Oh, I see what you're doing. That sounds beautiful. This is epic. Oh good, it's Mystic Ruins. Did you all see that Mystic Ruins Explorer Twitter account? I can't believe that someone made that. But I'm not complaining, it's beautiful. Alright, so left shifted by that. Return it, yeah. If it doesn't exist, you heck, return 0. So here's the cool part about freaking Azuka is genius. That account is amazing. Yeah, I know, right? I can't believe, well, was. Oh, I guess it's not a thing anymore, but it was beautiful. I guess it's just like not active anymore. Yeah, but I can't believe it was a thing. He would just every day, well, not every day at all actually, but every now and then he'd tweet like, I just found, you know, just tweet about things that he just found, and it was like nothing because the Mystic Ruins, you know, explorers did like freaking nothing. It was hilarious. Alright, so, see, here's the beauty of this, right? So there's always a default shader for forces. So there's always, like I mentioned before, there's always, no matter what, there's always a default, right? Then you have like one which might be like, I did this example earlier, but I said like this, and then I said 2 would be like enable HLS correction, and then 3 would be like a combination of this and enable HLS correction, like that, right? So basically, yeah. Okay, so like what you have down here, these are like the indices, and then for the attributes or parameters, as I call them up here, just the same thing. You have this one, and then you have this one. So basically, for flag, what we're going to be returning is we're going to take in a string, so like this, right? And what we're going to do is we're going to check each one of these parameters, one after another, to see if the string that we passed in here matches the string that they have. And if it does, we're going to get the index of it. We're going to take 1, and we're going to left shift it by that index, and then we're going to return the result. So for example, let's say you pass in enable deferred rendering. Okay, we're going to look through them all, so we're going to find this one right here. It does match, okay? So we're going to say 1 left shifted by 0, see? Which of course is going to be just 1. So our result is going to be 1. If we do the same thing with this one instead, it's going to find it when it gets here, 1 left shifted Left by 1, you're gonna get 2, right? So the result's gonna be like this. Okay, so basically, from there what we can do is, it just matches up to one of these indices. So then if we want to have both of these, we just have to bitwise OR them. So we would just say 1 ORed with 2, you're going to get 3. And that's going to be a combination of 2 of them, see? So it's really simple, it's really fast. I explained this earlier, but the reason I'm... Why do you hear "awi"? Did it sound like "awi"? Oh gosh. Yes, Ichigo, I remember the Jello. I was so traumatized. No one is allowed to explain. I'm making a decree right now. We shall forever keep this the most inside of jokes. People will be like, what the frick are you talking about? The Jello. And we're like, no. Papa doesn't tell. Papa doesn't snitch. It's like Dreamwood. Yeah, dude. We gotta do like another... We gotta find like another trash visual novel sometime. It'd be hilarious. I was actually thinking about asking you and Derek and Chloe and everyone if y'all wanted to like play one on, I don't know, like sometime, like, because I said I was going to do a call like Mega Hit and everyone on Sunday, but Monday might work fine, because Mule found one. It's epic. But anyway, I probably shouldn't have said that yet, because I'm kind of springing on you all. It wasn't actually bad. Oh, frick. We gotta top it then. Oh, Mil did already? Oh, cool, okay. I didn't know she said that already. It was monkey. Yeah, yeah, and it looks beautiful. Did you see the screenshots? Holy frick. Anyway, I'd like to play it sometime. I think it'd be fun. Oh, yeah, anyway, so variant index. So these are the indices. So what's interesting about it is that these are actually indices of themselves. So these aren't the shaders, these are indices to those shaders. So like, this is probably going to actually hold, these are all going to hold a number. See? And then that number is the shader that corresponds to that type. So in this case we need to say return, well, it's really simple, just say indices flags, like that. And yeah, that should get us, indices is a vector of uint32s, so we're going to get uint32, so we need to actually cast it to this. There we go. Okay, so now if we want to get, for example, this shader right here, we can literally just basically say shader.flag enable deferred rendering ORed with shader.flag enable HLS correction, and that's going to be flags, so like that. And then we'll just say shader dot variant index flags. So like this. And then finally shader dot variants which is going to return a pointer to, yeah, like this. And then we can just say variance index. And now we have our variant. So this is the code that HedgeLib is going to have to run. But this blob of code should work with any shader type, not just forces, if I can implement this interface cleanly for the other types, which I should be able to do. So this is really powerful because it allows us to mix and match as many flags and all that as we need whenever we need it. It's gonna be amazing. You just saw the thumbnail, but it was amazing though. The text, I clicked on it, and the actual screenshots of the some of the lines they say are even funnier to me. Like, oh my gosh. Because actually, being honest, I saw the screenshot and I was like, that's gonna be amazing, but it's probably just gonna be like, you know, it's gonna be funny, but it's gonna be like, you know, I don't know if I thought it was gonna be like revolutionary, but then I saw the screenshots and I was like, oh boy. There was like broken grammar on the first one, if I remember correctly, and the second one was like something about like I think Mudkip was depressed or something. I don't know. It looked hilarious. So I want to like do a call with it sometime. I think it'd be fun. Anyway, yeah, but I want to get something done this week too. So like, one day would probably be a good time because then I could have the rest of the week to like do something else, right? But yeah, those are amazing. I know, right? It's hilarious. You guys from my neighbor? Oh, cool. Sorry, I didn't mean to like spring it on you and set an exact time right now. I should have. We can talk about it more later if you want. It's cool. I'm just like distracted. I need to actually freaking do a thing and not like. My mind is like trying to escape what I'm doing so badly that I'm like making arrangements with friends. I'm like, yeah, dude. Why don't we escape from this nightmare sometime? Yeah. Oh, they're all on a call right now? I didn't know that. Me Edis. It didn't work. You still can't send the link. It just takes you to the app. Wait, what? What link? What are y'all talking about? Oh. Shills quoted the that Explorer account I mentioned earlier. I forgot that was the thing. Yeah, it was so funny. Just so it was triggered. Me too, constantly. Alright, so now that we've got this, everything should be going good. So. Oh, the link to Bayoneted dabbing? Oh my gosh. They're in a different group chat. I'm not in, and you're dead on I'm dead in Discord. Why would I know? Oh, I don't know why I would know. Oh, you know what I mean? You're joking. You're just screwing with me. Yeah, Rod. They hate you. That's why you're not in it. Yeah. No, I'm kidding. I'm fine. Legit. Anyway, alright, so this part's done. We got this. All this is actually basically. Oh no, it's not. We gotta do this. Okay, so what do we have in HedgeLib? It's up here. Sorry. We got shader group. We don't need shader group. That was stupid. That was like, you know, Watch Mojo made a compilation of top 10 stupidest ideas, and that was on the list. I don't know why how I did that. All right, and then we got shader. And all that crap. We got vertex shader variant and pixel shader variant. Alright, so shaders are let's see, we need to have a shader and a shader variant class. So let's rename this one to shader variant. Same with the CPP file. And then let's make a actual shader.h. I don't know what that song was, but okay. Annotated to CPP, and let's regenerate the pre-make project. Rad gets passively depressed on stream. Oof. This has happened before, though. You know, like, that's happened. I'm silly sometimes. Thank you. I take that as a compliment. Yeah, Rob, we all hate you even after not talking to us during the Jamie after not talking to us during the Jamie drama, even though you were entirely in your right to be quiet and they didn't come to you goodbye. You know, I came to you, I'm also joking. Also, speaking of Jamie, oh boy. You're doing the crafts. Yeah, ooh, alright. It's a celebration, apparently. Yeah, yeah, Jamie was. I don't want to say bad things about people, but Jamie had some issues. By your definition, silly is a good thing. That's awesome. Yeah, me too, actually. All right, so I'm gonna call this shader variant, actually, and oh, this is like an abstract class, isn't it? How do I frickin' do that? Let me think about that, actually. Is this absolutely necessary? Okay, maybe we could, I don't want it to be a purely abstract class, I want it to have a member. So I think I can just call it shader variant and not be an interface, because an interface would be purely abstract. Yeah, so what I want it to do is shaders, shader variant, and actually, in this case, we're gonna put it inside the brackets because HedgeLib is actually this. Okay, so you usually put it. Quotes means that you prefer files that are relative, whereas the brackets basically mean that you prefer files that are not part of this project, if that makes any sense. So in this case, we're using HedgeEdit, so we prefer, HedgeLib is not part of the HedgeEdit project, it's a separate project, you get what I'm saying? So we're actually going to put it in brackets. Anyway, alright, so we're going to say HedgeLib shaders iShader variant, and have a pointer to it. Actually, can we have a smart pointer to an interface like that? I don't think we can. Maybe we can. That seems to be compiling so far. Well, not compiling, but it's not complaining yet. But I get the feeling it will. Well, okay. So let's see how this works out for us. So shader variant. What did I call this? I did call it vertex and pixel shader variant. Okay, so maybe I should actually just call it the full thing, vertex shader variant. Let's put this here every time. What are they? How long is that line? Yeah, it's fine. It fits. Put that there. Put that there. All right. Pixel shader variant. And that's going to cause like 200 errors. So then let's put that there. Put that there. Put that there. Put that there. And finally put that there. Okay. Shader variant. Okay, should all work fine. So this one, that's interesting. Let's think about this actually for a bit. Do I want it to be like, oh wait, you're sorry you joined into the Radfordhound anime during the Shadow of the Hedgehog arc, and you didn't have time to read the manga for all the drama side plots. It's cool. I understand there were a lot of side plots. Let's see. Oh wait, Derek said yes and Ghost said maybe Chloe isn't responding yet. Okay. Thanks, Taz. I don't know what time I didn't mean to spring it all on you, I'm sorry. Maybe like 3 or 4 or something. Work fine. But anytime you want it. It just sounds like it'd be fun, I don't know. Because it was, the stream moment was fun before. It's fine? Alright, cool. Sorry, I don't want to, like, intrude. Alright, so... Cool then. So I think I can have, yeah, alright, so I'll have like an init function. Oh, I already had these up here, but hear me out. I'll have, I'll make this a class. And I'll make this private. No, I'll make this all protected. So I'm gonna say that, and then I'm gonna say, virtual void init, and I'm gonna say frick. Let me think about this for a second, actually. Oh man, this actually gets a little tricky. Well, you know what? Screw the DirectX shader compiler. It's beautiful, but we don't need it in this case, actually. So let's rearrange a lot of this class. So oh boy, everyone's favorite part, refactoring. I love refactoring. Sorry. It's so painful. Mac and cheese. Yeah, I agree. Derek and Clay get home from school at 4, so like I guess 4:30 would be good? Or just any time between 4:30 and 10? Yeah, that sounds great. That sounds great. Maybe like 4:30 or 5. That usually works for me. 5's easier, but... Because 3 is hard, because like, I'm not usually home. But yeah. Gucci gang! Mac and cheese. Your favorite part? My favorite part too. I get super hyped about refactoring. You all have no freaking idea. Oh, the physical pain. Okay, I'm just thinking about how to do this. 'Cause like... Alright, I think I'll have a unique pointer to a variant that's protected. I'm gonna have an init and load, just like what I did here. Except it's gonna be far simpler. We are gonna take a device, actually. We are gonna take... Yeah, okay, we'll take either bytecode or... Let's be even simpler than this, actually. Let's take, we need to take ownership of the variant. Basically. Well, no, not take ownership. We want to, like, become the variant. Like, I am become variant. Well, no, because then we have to make a custom hedge edit shader variant class for every... Okay, frick. Let me think about this. Losing my mind. We don't actually have to do that but like, it's easier to just... Yeah, okay, so we definitely want to take ownership of it. Sorry, I'm just like thinking out loud so much. We need to be able to take a pointer to an object, basically. And like grab it and say like, that's mine now, you frick! And then just use it, basically. So that's iffy. Instead of taking bytecode, let's take a pointer to a variant. Refactor Chan. Oh, who doesn't love Refactor Chan? It's Blue Coast Zone, everyone. Blue Core Chan window. Shills Chan. I would love to see all of these. Yes, each of you are about scroll. So, okay, wait. If we take a pointer to the variant, then we could basically stuff that into our unique pointer, yeah? And then we own it, yeah. Okay, so then that would work, but we need to make sure that that's not, like, that's apparent that's what it's going to be doing. So, like, take ownership, yeah, okay. Well, not of unique pointer, but of, what are they? No, I didn't, whoa.
Hello there, Graham.
Hi, Siri. It just randomly thinks I'm talking to it. Oh, they said yes too? Oh, sick. It's awesome. Cool, so everyone's gonna be, that's gonna be great. Hello there, yeah, it just is randomly, like, exposing. I feel like, Almo is becoming real. Like, he's already terrorizing me in the digital world, but now he's like branching out to the real world slowly. One does not self-proclaim best girl Ichigo, but one is voted best girl on a democratic societal vote. I'll vote for Ichigo. Okay, wait, so the calling... Okay, wait, so house takes a unique pointer to pet, create pet, returns unique pointer to animal, I see, and then you would move it, so it's like this. So after constructing the house, the pet variable will be null pointer because we have transferred ownership of the pet to the house. Okay, so you want to just take a unique pointer then, and then like move it. Okay. There is some debate about how best to pass it. So there's some debate, okay. So here's one thing you could do. Oh gosh. Unless I'm overlooking something, passing string parameters of type unique pointer is inconsistent. Yeah, what do you think? And there's 73 comments. Oh my gosh. All these people have different opinions on how to do it. So really, there's no good way to do it. You just do it. You just freaking do it. Don't even think about it, okay? Don't look back. Don't let the haters... Sorry, I don't know what's getting to me. Don't let the haters get you down. Just focus on your dreams. Focus on your mindset. Your beliefs. Your mentality. You gotta do what you think is right. Because if you don't, you frick! You screwed it up. Alright. And we don't actually need the input layout stuff at all for the pixel shaders, so really that's quite silly. So we're gonna get rid of this. Freaking garbage. Alright, and then we're gonna do that, and yeah, it's epic. Look everyone. It's epic. I did it. You proud of me? Okay, so we don't even need a variant. Why am I even making this function? What am I freaking doing? We're gonna need to make custom ones anyway. So like, okay, hear me out. Put it here. Okay. And we're gonna declare this in shader variant.cpp. Like this. Gonna get rid of this. And actually all the D3D compiler stuff, because we decided against it. Yeah, we're gonna take all this, put it down here. I like how I take all this time to explain things and then I just do things. I'm just like, we're gonna take all this, put it down here, move it all like that, and I don't it's terrible. Alright, create input layout, elements, element count, sick, and then we have this, and that's where we get into trouble. So okay, hang on. Take ownership of variant. Okay, so can't we literally just be like, oh, hang on. Oh, yeah, okay. So we've passed it there and we've moved it to the memory variable, then calling code would look like this. So we're basically going to move it twice. Someone says then you wouldn't need the move in the initializer list, and R value references itself and L value, so you still need the move. Good point. Although it seems like a new idiom. I wonder if it's been given a name by anyone yet. The transfer ownership idiom? Note that you can do move assignment like this. So this guy came up with a new thing. Epic. Oh, the song finally ended. It's a utility? Alright. This freaking programming language. It's so special. No, we don't even need, just do this. And then in the constructors, you would do the rest. So like, alright, this song's good. We'll let that play. Oh jeez. Do that, and then yeah. All right, so here's what's going down. Like that. And then you could say, we need to actually also have public, yeah. It is not a non-static data member of base class. Are you sure about that? Should be. Is it because you didn't have protected inheritance? Is that the case? It's not a non-static member. Okay. What, do you need private inheritance? What, I don't even get how this works. Can you do it? Can you do the thing? Okay, IntelliSense is still trying to figure that one out, so suppose that's not what we need to do then. What did he do in the example? Well, they were all public. Except for this. Is it because... Okay, it's not a non-static data member of class photo shader. But it is, though. Oh. Hang on. Shader variant. We're gonna say this. Variant. And then we're gonna say... like that. Okay. Oh my gosh. What beautiful looking code. Holy frick, it looks bad. Alright. No exceptions. Oh no, we can't do that. Because I put it before the thing. Like that. Okay. So epic. This is so epic. Sorry, I'm losing my mind. Okay, cool. So, now we should be moving, we should be taking ownership of the smart pointer. That should hopefully all work out for us. And we can call it like that. Neat. So then this one is gonna, yeah, it's gonna do that. It'll be great. And we're actually gonna, so we have to move it twice, basically. But that's fine. Okay, so here, we're gonna call init, and we're gonna say device, and then we're just gonna say elements and element count. And at this point, variant should already be moved, so we shouldn't have to worry about that. So then this is another way to pass in the bytecode, but we ain't doing that anymore. This is... what is this, even? Oh, this is the way to compile, we're not doing that. Another way to compile it, we're not doing that. And this is just the default. But we're not really doing that either, are we? Well, maybe we can do this one. This one's okay. We just need to be like, this, I guess. Oh, geez. And then, like that. Okay. Does that work? Cool, it works. Okay, now for the pixel shader. Device, bytecode, and length. We don't actually need that anymore, so literally just device. And we can get rid of this too. Sick. And then we can do the same for this. We need to paste this every time now. Shader variant. Alright. And when we go to init, we're just gonna say device. Okay. Don't want that one. Don't want that one. And then this one, we're gonna do the same thing that we did earlier. Alright. So that should work. Even though it looks bad, it should work fine. It's 2019, technology can help you get there? What we're talking about? Being a lowly is hard work. The 24/7 FBI bodyguards are a nice perk though. Oh. Oh, okay. Rod's gonna do the thing! Yeah, everyone. Wait, someone wants to be a lowly, I guess? Oh, Shills wants to be a lowly. That is epic. You pursue your dreams. Alright, so create input layout, elements input count. Now here we go. So now we've got the variant. Variant dot being dumb. Variant dot bytecode, that's gonna return that. This expects a constant void. This should be fine then. Bytecode length, that's gonna be a size T. Not to be confused with size T. Oh gosh. So we're gonna have to static cast it just to be safe. Even though it shouldn't matter ever, but bytecode size, and then, yeah. Alright. And that should all be fine. That should compile just fine. I'm actually gonna do this, because I think that maybe that's cleaner. I don't freaking know. Okay. And then here we're gonna create the vertex shader from, again, the bytecode. We can probably, I mean, this isn't an optimization, really, because, the compiler will do this for us anyway. Like, any reasonable compiler would do this for us anyway. But this is just easier for us to write. Oh, I love the hero special stage music. Like, it's so good. Isn't it? I mean, seriously. Does it say size, or what does it say? Bytecode length. Well, who cares? Also, I guess I did this. Even though bytecode is kind of one word. I can't even decide if bytecode is a word or not. I'll do this to be consistent. Alright. What does Microsoft think? Microsoft thinks it's one word too. Okay. Okay. Good, that should all work now. Thank goodness. Thank freaking goodness. Okay, so then this part, we don't want this function anymore. Same with this one down here. Alright, so lots of obviously code that's been commented out, but that's fine. That makes things way less complicated, my goodness. Alright, we can copy paste this too. Alright. Should actually probably put this up here, and then we can say like get shader bytecode. Yeah, and I can do that in this one too. It's just a little cleaner. It's not a big deal really at all. You could even put this there. And do that here too. Alright, bytecode size. Cool. This would probably be better, like, I overthink a lot of this stuff. Alright. Now we got shaders. Rod's about to do the thing? No way, no way! Blue spheres on loop. This is epic. Your mom made another jello, but this time, oh gosh. The jello extravaganza continues. Wow. Alright then. I guess we don't need this anymore. Or this, because this was used for compiling the shaders. So this makes things way easier. We can also, oh, this song's so friggin' good. We can also, get rid of this. But I'll keep that open for now, because I don't know if that's final or not. We might actually end up deciding later we do need the compiler for some reason. Probably not, though. Alright, yeah, probably not actually, so let's get rid of that. No, let's keep it. And then if we need it, whatever. We can easily add it back. Okay, so now we got shader variant, it's all working. Oh, should be all be working fine. I haven't tested it yet, but we'll need to do that obviously. Okay, the first question, can we compile? Fred Flintstone has a very private password. He doesn't really, but yeah, anyway. Oh, frick. Why is that a problem? Use of deleted function shader variant. HN shader extends from shader variant, and so you're saying it tried to use the copy constructor? No, it tried to use... What are you whining about? Oh my gosh. Use of deleted function HN shader right here where we static. I did not type that. Let's use an STL construct. Okay, forces shader .cpp. What'd you say? 183. Alright. No, stop. Shaders.resize shader count. You can't do that because it's required that HN shader has an HN shader copy constructor when you go to resize, and it doesn't. It's been implicitly deleted because the default definition would be ill-formed. What's the default definition? Oh, it extends from... I don't get why, but... Okay, hang on. What even is an HN shader? It's something that extends from either shader variant, and it has two HN shader variants, which it's holding. So the problem is that it tried to use a shader variant's copy constructor, and that's not a thing that exists. Because it has a unique pointer, and that automatically gets rid of the copy constructor. Okay. Well, that's a freaking nightmare. Okay, is there a way we can do this without copying? Of course not, that'd be too easy. Oh, let me think about this one. Papa Rad's gotta think. New size, and then there's a value, but that doesn't... Oh, let's think about this one. So we need to be able to resize our shaders vector, which is down here. Our shaders vector is a vector of HN shaders. HN shader doesn't have a copy constructor, which apparently is needed to resize the vector. And the reason it doesn't have a copy constructor is because it happens to contain a shader variant, which happens to contain a unique pointer, which then deletes the copy constructor for the shader variant, so in turn it deletes the copy constructor for the HN shader. Okay, so we can make a copy constructor, I guess, but, well, I guess we could do that. Let me think about this again for a moment here, sorry. This is quite a predicament. Why does C++ make this such a nightmare sometimes? I swear, like... Why can't it just have a copy constructor, like, legit? Oh, but Red, it can't copy. It doesn't... Why? There's no way it could possibly do that. Why not? You know that you're a unique pointer. Okay, you know that you're a pointer and that you point to something of a certain size. Just copy the data. It's just too hard. Hey Sonic Fan 9000, how you doing? HedgeLib Newtlang. Imagine this, but running a Newtlang. All right. This is why C++ is a nightmare. Like, I'm just gonna be honest. This is why this language is like not fun to write in, because it's like it's super powerful, right? But it's like stuff like this. So you're recommended to use smart pointers at all times, because smart pointers are supposed to be like the way of the future, and it's like, oh, it makes it so that there's no chance of memory leaks and everything is golden. But then smart pointers don't have a copy constructor. So just by using a smart pointer in your struct will no longer have a copy constructor. This is important because you need a copy constructor to do things like use your class in a vector. So you want a copy constructor. So like, how can I possibly get around this? Let's see. There's several ways, but I don't know what the best way is. So one of them would be to go out of my way to make a copy constructor for the shader variant that actually copies all the bytecode to the new object. Yeah, okay. I think we'll do that. So here's the shaders. Shaders up until this point hasn't actually... See, this is the dumbest part about this. Like, shaders hasn't even been initialized, realistically speaking, the way we're going to be using this. So we shouldn't even have to do this, but whatever. Maybe don't make it a smart pointer. Right, if I just make it like a normal pointer, like this, then that'll work and I'll have a copy constructor, but then the problem is I now have to clean up my memory when I'm done automatically. Sorry, I have to clean up my memory manually is what I meant to say. Because otherwise C++ is not going to do that for me. So I need to make a destructor for the shader variant that deletes the bytecode. And I need to be cautious about all of that. I can do that, and in fact, that might be easier, but you're recommended to use these. So I'm gonna try to do it the way they want me to do it, even though I don't want to do it this way. That's C++ in a nutshell. So let's look up how to do the copy constructor again, because I always forget. So here's an example of a copy constructor. Alright, cool. That's all we need. This should probably be up here. It's easier to read. Okay, so what does this do? It takes a constant reference to a copy of itself, and it just makes a copy. I get it. Okay. So, in our case, it's going to be a little more complicated, I guess. So what we need to do is, I guess I'll just call it V. What is this, by the way? Oh, Space Junk Galaxy, neat. Okay, we're gonna say, so wait, this is setting, okay, so what this is doing is this is gonna actually take the copy, yeah, it's gonna create like a copy using this object by copying the old values to this one, so, okay, well wait, couldn't we just, Can we just release it? And then, just do this. Can you just do that? No, because it's constant. And this is not a constant thing. It's not a thing you can do with a constant object. Okay, so I know what I can do, but let me just see if there's a better way to do it first. Copy constructor unique pointer. Yeah, here's what I need to do. Since the unique pointer cannot be shared, you either need to deep copy its content, that's what I want to do, or convert the unique pointer to shared. I do not. I sure as heck don't want to use a shared pointer. These are just bad. Sorry. These are like slow and garbage. Alright, so here's a copy constructor. So what they're doing is they're actually they're dereferencing this so that they're getting the pointer to it and they're creating I see. So you need to actually deep copy it. You can use a move constructor instead, but that would result in different semantics for your class. A move constructor would need to make them removable explicitly via an std move. So you could do this as well. Okay, well let's see if, I don't think that'll be enough for our vector. But let's try that first, because that would be better. Just move it. Let's just say A, because I don't know, who cares what it's even called. And bytecode, and we're gonna say std move a.bytecode. Why not? Oh gosh. Function std unique pointer type, and then the deleter unique pointer copy constructor declared at line 2519 of this memory class from the C++ standard Microsoft's implementation of the C++ standard library cannot be referenced because it's a deleted function. It is? I thought it had a move. I'm pretty sure the smart pointer has a move. It thinks I'm trying to copy, I guess, for some dumb reason. Okay, that's great. Let's do it the old-fashioned way. So, okay, v.bytecode. Let's think about this. We can just get it. That'll work fine with a constant one. Okay. So this is not going to be good enough, even though this is going to compile. This is what this is going to do. This is going to get a pointer to. This is going to get the raw pointer that the smart pointer and the other object holds, and then it's going to create. It's going to take ownership of it, but the other one already owns this. So when the other one then is deleted, we're going to have a dangling pointer, and it's going to be bad. So what we need to do is we need to actually copy this. Hence the name copy constructor. So we need to just literally copy the bytes in memory. Okay, so hang on a second. Copy bytes. I mean, just, oops. I don't know how I even did that. Alright, mem copy. Yeah, that's all I want. It's in C string, of course. It's always something from C that saves the day. C is such a nice language. Like, I'm not even being sarcastic, I like C. Alright. Because, like, C is, like, sensible. It's not freaking insane. But you need to use C++ and if you want to make, like, a modern library, especially if you want it to be on Windows, because it's, like, Windows has bad... It doesn't really, like, have a proper C compiler, it just has a C++ compiler that can also kind of, sort of do C. Brad needs a girlfriend, boyfriend. The first one, please. Okay, destination and source. So we're gonna say, okay. Okay, hang on. So let's do this. So first, let's say bytecode size equals v dot bytecode size. So we're gonna copy that value to this one. Okay. Then we're going to say, how do you do it? Make unique. Alright, and we're gonna make a unique pointer to, I can't type for the life of me all of a sudden, like this, of bytecode size, like that, okay. Then, well, I should probably have cast that. It should be fine though, I guess. Should be implicit. Then, now that we've got our unique pointer, we're going to get the pointer for the other bytecode and the pointer for this one. We're going to copy from one to the other, and the size is going to be bytecode size. Okay. Oh, let me make sure I understand that correctly. Yeah, source destination number copies the value of num bytes from the location provided to by source to the memory block pointed to by destination. Yes, of size. Yeah, it's simple and to the point. C is beautiful. The underlying type of the objects pointed to by both the source and destination pointers are irrelevant for this function. Yeah, because it's just void. The function does not check returning null characters in source. It always could be exact. Okay, yeah, that's what we want. To avoid overflows, the size of the arrays pointing to both destination and source parameters shall be at least num bytes and shall not overlap. Yeah, that should be good. For overlapping, blocks may move as a safer approach, but ours are not overlapping. This is all good. Yeah. Alright, good. And, oh, destination is returned, but we don't need the return value. We already have it. Alright, good. Holy frick. Why? Okay. Jeez, man. So then, online HN shader variant. It's like, why couldn't it just figure out that that's what I wanted to do? Like, I know it's like, oh, but Rad, come on. Of course it can't figure it out. Look at all the stuff it has to do. How could it guess all that? But it's like, all that this code says is, hey, copy all the data in here to the new version. Like, what? That should be obvious. I guess because it needs to know the size, and the size isn't part of the array. Right. So if it was like a single uint, it should be able to do it. But because it's an array, how could it possibly know how big the array is, since arrays in C++ don't have a size attached to them? So you need to have the size passed in as it. Yeah, okay. That's why you have to do all this. I get it. It's just annoying. Alright, V. Can we just, for this one, please be nice to me? Can we just std move v.bytecode? Eh? Can we just do that? No, because of that error. Okay, so what did this guy do then? Up is the unique pointer. A is the thing we're referencing. Std move a.up. That's it. Did exactly what I... No! This is constant. I'm dumb. Alright. That's why we couldn't... You can't move it, because it's constant. Yeah. You need to be able to manipulate it. You can't manipulate a constant value. Okay! So... Now we have a move constructor and a copy constructor. We're freaking unstoppable. Let's compile this again. And... get a new batch of errors right out of the oven. Ah, yes. Alright, use of deleted function. We've got a unique pointer which contains... What even is... It's so hard to read. It's a HN variable. And it's being used where? Line 2 of this? I don't know about that. Line 1 of forces shader.cpp. Okay. Well, because that included this. Yeah. So it eventually boils down to, like, file system. Okay. Declared here. That's not actually where it's at, though. Required from here. Oh, forces. Here it is. Forces shader.cpp 183. The same problematic line. Okay, so we can't resize our vectors still. Because... The candidate expects one argument, 0 were provided. Let's see. Hang on. Oh, it's the opening to Unleashed. Use of deleted function, which creates a new HN shader. It's just the default constructor. It's been implicitly deleted because the default definition would be ill-formed. Why? Why would the default constructor be ill-formed again? That doesn't make sense. Let's see if we get an error here. Explaining to us why. No, nothing. No error. It's all fine, guys. Is it because I need to have default values for everything like that? Alright, are you happy now? Of course not. Oh gosh, everyone. Python Chan and Lua Chan hate each other. C++ Chan is indifferent to Java Chan. It like starts a war. That'd be hilarious. I don't know why I said everyone, by the way. I'm not mad at anyone. I'm just stressed. This is HedgeLib and we got skills to blow YouTube away. Heck yeah. Don't you know Rad's unstoppable? Yeah. That's the kind of motivation I need. 3 hour and 30 minute mark. Heck yeah. I'm hyped. Alright, so there's only one problem now. It's just an extremely long problem apparently. Because of this vector code. You can't do a thing. It says use of deleted function, all this crap. H and variable, yeah, what's deleted about it? New static cast void P. What? Why aren't you just telling me what it is? Like, just, jeez. Does it say at the top maybe? In a cleaner method? No, of course it doesn't. Oh, this is a hard one to figure out. This is why we need brain frick. You know, at this point it would be easier than this crap. Like, come on now. What is this? What is this error? Goodness gracious. You try to use a deleted function. std unique pointer, std, well, unique pointer. So the constructor of the unique pointer has been deleted. Why? And you try to call this where you said new from a static cast void P, which is, I guess, the HN variable pointer, and then you said like, I can't deduce all this. Declared here, unique pointer, delete. Okay, wait, let's just, you know what? Let's just compile it in Visual Studio and see if it gives us a nicer error. And then maybe from there we can figure out the GCC error as well. Come on. You can error? You can do it. You can. Oh, we got a warning. Try to convert from a size T to an int? Say it isn't fricking so. That's a nightmare. Warning. Oh, here's all the errors. Okay. Sick. Warning. The result of 32-bit shift implicitly converted to 64 bits. Was a 64-bit shift intended? Alright, these are actually nice warnings, though. That's nice that they're warning us about this. Okay, so evidently it'd be better to use an int here. Oh, jeez. 36 errors. Okay. Result of 32-bit shift was implicitly converted to 64 bits. Okay, so you're shifting this to the left by... Well, yeah, what... Well, the problem is that this is not a size T, so it's becoming 30 times. Alright, and we should probably actually make this more readable by, like, doing this. Alright. Error, here we go. Oh my gosh. It's an X memory. So then it's we're gonna follow this down until we find where it's happening at. Here we go. We're getting closer, we're getting closer. We're still getting closer. It boils down into all these millions of things. Here we go. That's just at the end of this, guys. That doesn't... See reference to function template initialization. Oh, so just having a vector which contains a unique pointer which contains an HN variable, which is what's used right here, is enough to cause this error, because I guess HN variable doesn't have a default constructor or some crap like that. Okay, so if we say, so if we just do this, I mean, we shouldn't have to do this. I'll change all these, don't worry. Just do all this, it should work fine. Right? Ugh. Look at all those errors. Oh, well, that's understandable though. It's these up here that are killing me. Stop. Just stop. Just let me scroll up. Okay. There are too many errors for the intelligence engine to goodness. And I bet it's gonna be something stupid. When I figure out what it is, it's gonna be like something easy. Hang on. When you went to compile h invariable over and over again. See reference to template instance. Okay, yeah, it's all because of this. A jewel containing the ultimate power. You can't make an h invariable because it's. It's inline, and that's fine. It's got a constructor, but it doesn't believe me, I guess. Well, this is a serious problem. What? How did that happen? Well, friggin' maybe that's why it wasn't compiling. No. Certainly was. There's so many errors. Okay. Okay, I get it. I understand. Can I just see that? Wait, how many errors was that though? 35. Seems like a practical number though. It seems solvable. So this problem, this line right here is an issue apparently. Apparently. Because we're trying to get one of these and that just can't exist for some reason. Type traits here from I just want just tell me why, like what's the actual problem here? Because all these problems are being caused because of a root problem, but what the heck is the root problem? Give me what it says up here. Unique pointer to an HN variable. The copy constructor for it is a deleted function. That's all that is. So all those errors meant, hey Rad, you should make a copy constructor. You freaking, screw you. Could have just said that. Gosh. All right. Everything's good. So all we need to do, the plot twist, the joke is that it was actually easy. Yeah, see, we just... Also, why was it deleted? Why? Wait, can't you just do this? Like... Alright, let's figure it out why this is a problem. That line was the best one. Ah, look at that! Invalid type for defaulted constructor. Why? Okay. What if we delete that? Now it's fine. What? Oh, no, stop. No, that's fine. Well... Gosh, my head. Alright, it's fine though. We'll be fine, we'll survive. Alright, just put that there, put that there. No, I'll do a break in a bit. I just want to figure out this problem. Alright, let's build this. Oh, good. Okay, wait, but we got actual errors at the beginning. Can you stop building, please, so I can read the errors? Alright. No appropriate something, but I can't read what it is, because Visual Studio's still scrolling down. Alright, stop. Let me read the output. Thanks. Alright, no appropriate default constructor available. Again, why can't you just figure this out? Why do I have to be the one to tell you to do this? Like, this isn't... I would get it if it was like, oh, but, you know... how could the compiler possibly figure this out? But this is like obvious crap. Like, it's so obvious. Alright, build. We'll get the new errors. Yeah. Yep. Okay, do this. And stay put for a second. Nope. Appropriate default constructor available for a constant buffer variable. There is one right here. No, that's a constructor. Sorry. That was actually me being stupid. Okay. I'm just gonna let See Sweet, You're So Sweet play, because, like, that's, you know, yeah, it's fine. Amy, wait! Put down that hammer! Yeah. Amy's giving Sonic a death threat. Y'all saw the tweet the Sonic page made today? I actually thought it was pretty good. It was really fast. You just go, wow. Alright, there's no copy constructor for HN variable, even though there is. Oh, wait. Do you want it to be not constant? Is that what's going on? No, no, no. Constant. Alright. Well, this is a whole other set of problems right here. So this should be easier to fix. And somewhere up here there should be like a sub-mesh base, but I guess not. Syntax error. Well, these are all just because of that one issue that I had there. Okay, so then in geometry.h I made the same. I haven't updated any of this. Alright, change all that. That's fine. Yeah, okay. And maybe a lot of it isn't compiling just because of this. Well, because, like, obviously a lot of it isn't compiling because of this, but what I mean is, like, maybe those other crazy errors are stemming from that now. Yeah, because those errors are easy. I get those, because it just straight up told me what the problem was. Oh, and I missed a few here, too. I didn't really want to do this because I'm gonna replace all this code. Oh, gonna replace all this code later anyway. What do you mean save as? I guess you can't edit the file while it's compiling it. I guess that's why it was doing that. Okay, just get rid of this for now. Like, that's fine. I'm not even using these for now is the ironic part. Hello, Almo's Underworld. How you doing? I forgot a semicolon? Probably. That's probably what it was, actually. I wouldn't even be surprised. You love this song? Yeah, it's cool. Oh, I didn't finish this part either. That's a problem, obviously. But, like, I'm not trying to compile all this. I'm just trying to compile the one, oh my gosh. Unresolved external symbol I file. Oh, well, that's an actual error. Like, that one actually makes sense. Types. When we go to return the, okay, oh man, I really screwed up a lot apparently, didn't I? And I actually use this. Alright, hang on. So the big one is, hang on, there's a few errors that are kind of big. So one of them is in types, I should be able to just return, yeah, lost word archive extends from iArchive, so it should just let me return that. For some reason, it's not happening. So let's just try to compile a simpler one. Let's try to compile just HedgeLib. We're gonna get like 9 million errors, but oh, yeah, it's 7. Okay, that's more manageable. So these down here are the ones that are perplexing me, actually. I didn't even notice these until just now. What do you mean unresolved external symbol? Like, I understand that obviously iFile format doesn't have all these things in it. It's abstract. But Lost Word Archive does. And I'm only ever returning an instance of Lost Word Archive. So, what's the issue? That should be fine. I think these errors are just somehow magically showing up because of all of these errors. So, if we solve these, the rest might go away. This is the part that's confusing me though. It's saying that here we're attempting to reference a deleted function, and the deleted function, I believe, it looks like it's the copy constructor for HN variable, but when I look in shader variant, well, no. Versus shader.h. There's a copy constructor right there. I went out of my way to add one to make it shut up, and it's still will not shut up. So here it's saying it seems like it's actually having trouble creating a variable at all. But you know what the funny part is? We don't even need these variables. Like, we're not using them yet. So like, oh, is that what the issue is maybe? Hang on, like, let me see something. Yeah, maybe it's, let's just do this for now. I mean, it's really stupid that I would have to do this, but just temporarily, hear me out. So we're gonna comment out all that, and then enforces shader.cpp. You can do anything. Yes, you can. Unless it's like flying or something. That's probably not. We're gonna comment out all this as well, this part that reads the shader variables, because we're not gonna use that yet. And then all of this we're gonna comment out as well, because those aren't gonna commented. Alright. So, compile, please. Here come the errors. No, it worked! Yeah, and those link errors about archive, yeah, that was just because of the other errors, because HedgeLib didn't finish compiling, so it didn't link in correctly. Okay. GCC. Please compile. You're more picky than MSVC. So I'm worried about this. Far so good. I shouldn't have said that. No, it worked! Oh, thank goodness. Holy frick. Okay, so for some reason the variables are cursed. The variables are just... They have an evil... freaking... They have the curse of Sonic 06 upon them. And if you touch these variables, you die immediately. So that's why we couldn't use them. See, it's very simple. I don't... Okay. I actually don't understand why that was happening, but we'll figure that out later. We will figure that one out later, ladies and gentlemen. I don't freaking care right now. That's fine. Okay, so really quickly before we do a break, because I know you all want me to do one. I think I'm gonna. I hope you all aren't upset by this. It's like currently according to my view of OBS anyway, it says it's at the 3-hour 38-minute mark. So about 20 minutes until the 4-hour mark. I think that would be a good time to do a break, if that's alright with all of you. So that's what I'm planning on doing, a break. But yeah, and I don't know why the music died again. But yeah, understandable, awesome. So, alright, really fast then. So now that we have, compiling, I have no earthly idea why, let me pause this by the way, why just having this made the compiler lose its mind. Because these are not doing anything fancy, they're literally just structs. I mean, it's extremely simple stuff. Whereas the more complicated stuff down here somehow compiles with no problems. Okay. But in any case, it's compiled. I'll figure out the variables and fix them all later. So in the meantime, now that we've got this part done, okay, this part's checked off. So I want to like delete it when I'm done, but I also don't because like no. So we're just gonna go on from here. So we've got all of this set up and working now. Wait, do we? No, we didn't make a shader yet, but that's extremely easy now that we have the variance figured out. Okay, so we have the variance. There's so much commented code, it's a mess. I'll clean it up later, I'm sorry, but okay, this is all working good though. We've got a pixel shader. Currently, instead of having an input layout ID like I described in this thing I came up with, I have just a straight up input layout, one per variant. I actually don't think it's going to be that inefficient, but it would be better to pool them. Of course, that's what I want to do in the end. So for now, I'm just going to do this to keep things simple, and later on I'm going to try to pool them. Anyway, alright, so we've got that taken care of. So now we need a shader, which is actually going to hold, it's going to represent the shader object from before. So yeah, we're going to say include shader variant. We're also going to say include from HedgeLib. We want iShader. Yep. Alright, so when we go to do this, I'm gonna copy paste this for now because I'm lazy. I should have copy pasted that too, but alright. We're gonna make a shader. And in this we're gonna have, let's think about this. What do we need this shader to have? Oh, we'll just basically call back the iShader stuff from HedgeLib. Basically have callbacks for all this. Yeah, okay. So, alright then. Oh, also we didn't even need that actually. Even that part I don't believe we need. Cool. Anyway, okay, so let's see. Do we want to do this? Yes, absolutely. Okay. We're gonna have an iShader. Gonna call it shader and then with that in mind, this seems rather stupid. Oh, is this the Chaotix post stage? It's Speed Slider, sorry. This song's good. Who's my anime waifu of the week? Of the week. Oh, it's like a weekly occurrence. Frick. This is a tough decision, dude. It's generally Ochako or Zero 2. It alternates. It might be Asuna some days. I just want the chat to freak out. No, I'm kidding. HedgeLib-chan the Hedgehog? Yes. When Ain't Dad's like, oh my gosh, Rad's being serious. Yeah, just every now and then. Must be an error in the Matrix. Yeah. Yeah, this whole stream is an error in the Matrix. Good choice, thank you. I like the chat's like sitting and listening intently like I gotta know, Rad. Pick wisely. Alright, oh jeez. See, this is the thing with C++, right? And I know I keep ranting about it, but it's like, it's such a powerful language. It really is. But I know I say this every time, but like, it's such a mess. the vast majority of the time that you're programming C++, you're not like writing out code. You're just sitting there thinking like, how do I do this? And the reason is because there's like so many dimensions to everything that it becomes so complicated. It's like, you have to think about, like, you know, how bits of memory are referencing other bits of memory, and then you have to think about like how you're gonna copy things and move things around. You have to think about the destructors and RAI, and well, but what if they use it from a unique pointer and all that stuff? And it's like, okay, so I'm just gonna do the simplest thing I can think of for this. So here we go. The shader variant, we're gonna have a pointer to a shader variant here. Because we actually have iShader here, we're returning this. So we're already holding these inside of the iShader. So because of that, we don't actually need to delete the memory. It's automatically going to delete itself when we delete the shader. So we can just do this. And all that stuff that I did earlier with this constructor here was just worthless, I guess. That is so epic. Hopefully that's smart enough to figure that out. Okay. And, yeah, we can get rid of all this stuff I had to type earlier. And utility, we don't need that anymore either, because we're not moving anything anymore, we're just making a pointer. It usually does seem like it's way easier to just screw the smart pointer stuff. Which is really infuriating, because it's like they're there, and they can be super nice, and you're recommended to use them, so like you want to use them, you really want to make them work, but it's, you gotta jump through so many hoops to make smart pointers work. It's unbelievable how much of a pain they can be. In C, there's no such thing as smart pointers, so you don't even have to think about it. It's not a matter of whether or not it's a best practice, you just write code and it works. Alright, these streams are really like red rants for about C++ for 5 hours. Realistically, it's more like 8 hours. Oh, jeez. Alright, anyway. So, now that we've got this working correctly, we need to actually do a thing here. So, let's see. We want to start off with, let's do what I did before with the shader variant, except let's actually pull it off correctly this time. So, let's make a shader. A unique pointer to a shader, because we'll do it the standard way. In this case, we can get away with it. Alright, we're gonna call this shader. We're gonna say shader and then shader. Wow, and that all works. Okay, thank goodness. So then, I mean, we don't even need to actually make this complicated, do we? Wait. Yeah, no. It should be fine to just do this, basically. So, like, okay. Wait, no. I'm sorry. No, it's not, because these need to have pointers to, yeah, okay, so we're gonna have a shader, and then we're also going to have a vertex shader and a pixel shader, which is gonna do a fancy thing. Okay, so hang on. Do that. We're not quite at the photo market. You've been studying D3D for 5 seconds and you have the perfect solution for fixing my shader classes. You want to know? Yes. I'm quite interested, actually. Alright. Please work. What do you... Come on. There it is. Alright. And does this... Yeah, it derives from file format, so we're good. Okay, no, wait, no. No, we're not. Because, still have to implement them. And what about load and save and all that? Yeah, what if we have it forces one? Yeah, this is bad. Okay, we're gonna do this. Yes, we're mirroring that exactly. And literally all we're gonna do is we're gonna say just return the version from our smart pointer here, basically. So we're just gonna do that every single time. For all of these, it's just gonna be like as simple as that. So okay, you can just make them all inline because it's like really easy. And we'll also include that. Okay, so here's how we make it work. Variance, yeah. Let's actually make this like readable. That'd be nice. Okay. Space this out. Actually, that, funnily enough, that worked, but obviously it's not what we want. Alright, and this is gonna call variant index. Oh, whoops. Variant type flags. So it's just, these are just callbacks, basically, for the other functions. Okay, so, beyond that, we need to have a virtual shader destructor. We're gonna set to that. So we're doing the same thing here. And then in iShader, no, not iShader, sorry. In shader.cpp, which is a thing, we need to say namespace hedge edit gfx, and then we need to like copy paste what I did here. Again, let's see, shader this time. You can actually have sorry, abstract destructors, even though that makes no sense. Well, it does make sense, but it also doesn't. Anyway, you can have abstract destructors, but you need to declare an implementation for them, even though they're abstract, which really makes no sense. But you can do that, and you need to, or else the compiler complains. And I was like, this feels like a hack, and I looked it up, and people were like, no, it's just what you have to do. It's just normal. This is just what you do. I'm like, oh, okay. Whatever you say. The perfect solution for fixing my shader classes is to press Alt F4. That is epic. That's gonna solve all my issues. Guess we got 8 minutes till the 4-hour mark. Alright, alright, so this is our default shader class. Then we want to have a vertex and a pixel shader class, and all it's gonna do is it's actually gonna like extend from this, except it's gonna contain what, like a vector of, well, let's find out. I'll figure it out as I go to do it. Alright, we don't need to re-implement all these, that makes no sense. We do need to implement this. That should work fine. This we also want to re-implement. So we're gonna say shader, and then we're gonna actually call this. There we go. Okay, and we don't need to do this because that's already fine. Okay, so we need to have a vector of something. Of these vertex shader variants. Yeah, which are going to reference the shader variants inside this. Oh, good. Okay, so we need to include vector. Find the computer room! Alright. And then we need to say, did I already include shader variant? I did. Sick. So now we say vertex shader variant. And I guess these will be smart pointers because I really hope this doesn't cause any issues, but okay. Well, no, we don't need them to be smart pointers because when we The vector will automatically delete it for us. Okay, so vertex shader variant, we'll say... Let's call this variance. That's fine. Invalid. Oh, alright, it was just reloading. So, what do we need to do then? We need to have, yeah, a class like this that lets you get the variance. Oh wait, no. Okay, this is where it gets... Okay. Okay. I see how it is. Cool. So this is, frick. Here we got the bytecode and everything, but we're not actually gonna need to access that. We just need to access this. So what we need to do is we need to actually have this. Yeah, alright. And, I'll just do this. Hang on. Just have, okay, just have a vector of unique pointers. I hope this doesn't kill me for doing that. Of shader variance, called variance, and return a constant reference to it when you call this. Yeah, just return variance. And also do this. But we don't even need a variant count because we'll have, you can get it from the constant reference. Okay, so then this is the flag and this is an index. Do we need all this right now? Yeah, we do. Okay, so hang on. So the ideal syntax is that you would have like shader. Just ignore all this. Just pretend this we're outside. We've got an instance of our. Okay, so we've got like this, like of our shader class. I was gonna say. So just pretend we got that, and it's already been initialized, even though we didn't initialize it here. Shader dot. You would say like flag, and then you know whatever, and then or with shader dot flag whatever 2, and then now you've got your flags. Okay, and then it'd be like shader.variant index. So this is still pretty much the same as what I proposed earlier, but the difference is this. This time, yeah, if you say shader.variance, I keep misspelling that. Yeah, what you're gonna get is not an iShader variant from HedgeLib. You're gonna get a shader variant from HedgeEdit, which is going to contain a pointer to the iShader variant as well as the DirectX stuff that's required, and a use function which you can use to bind the shader. So you can then actually on it you could call use, and then you could use it. Okay. So that's what we're going for here. So then with that in mind, the only reason we actually need vertex and pixel shader things to extend from this is so that we can, you know what? Yeah, the only reason we need it is so that we can, what? I need to think, I'm sorry. Oh, so we can create it when we, yeah, okay, so, so hear me out. We're actually just gonna move all this because it'd be more convenient to actually have it be like this. We don't even need to do smart pointers. It's easier to just do all this. Okay. Should be fine. We'll override that to be the default. That's fine. Okay, here we go. Variance. This is just striking it. Why can't you do? Oh, because you're being silly. Alright. Almost the 4-hour mark. Hate to say it. I guess I'm gonna have to find that key first. This level, this level actually wasn't that bad. Like, a lot of people didn't like 8 quarters. I thought it was, compared to Mad Space anyway, it's I thought it was alright. Alright, so I guess to be fair, anything is compared to Mad Space. And we're gonna return all this up here. That should all work fine. Yeah. Alright. All we need to do, it's almost, oh frick, it's almost 4 hour mark. All I need to do is create these. Let me do that really fast and then I'll do the brain. So, okay, the vertex shader, what are we doing? Yeah, up here, up, actually we need to do this. So maybe this would actually be better to do in, to not be inline and instead, like, have it down here. Yeah, okay. So get rid of the inline part. No, I hit Control C, but I guess I didn't. Alright, dun, 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 dun. And we'll just do that. Same with this. We're gonna define it all in the CVV file, and then down here is where we're gonna define. Okay, so down here's where we're gonna define it, and this is the part that I need to do. So let's just figure this out, one thing out, and then I'll do the break. I swear. Okay, so we just need to go through each variant in the shader. So just be like what did I call it? I did call it shader, but there's some confusion, so I'm just gonna do this. Okay, this dot shader dot no, let's say variant count. All right. Why did you get rid of that part? Variant count equals this. Shader variant, yeah, just do that, and that's gonna be an iShader variant. Okay, so this is the part where we need to do a thing. Okay, so yeah, let's say HedgeLib. Oh, geez. Shaders iShader variant pointer variance equals this. Okay, and then that means we also want to include that. Okay, and then finally, hang on, size t I equals this. I is less than variant count plus I. We're just gonna say variance I, and we're gonna create one from this. So like, here we go. Hang on. Oh gosh, this gets even more confusing. This is not good code, so I want to like rewrite some of this later, but just pretend. Resize, make it exactly that big, and then all you need to do then is be like, hey, oh this. All right. Variance I equals, here we go. Okay, sorry, vertex shader variant, and then, so yeah, so then we need to create it from the vertex shader and the input layer. Yeah, so we're gonna do that in a second. And that's all we need to do. Let me make sure of this. Yeah, why did I even need to, oh, I see, okay. Yeah, this is gonna create the input layout for us, so we need to actually create it. Okay, so frick, create input elements, and then, yeah, that's all you need to do, just create input elements and pass them in. So we'll do that in a bit. And then for the pixel shader, it's the same thing. And we'll do this after the break. Let's just make sure I got this going right. For pixel shaders, you shouldn't even need to do that. You should be able to just say, yo, why don't you accept my variant? And it'll be like, aight. And then you're done. Yeah, alright, so, pass in the device and, hang on. I don't remember how I even did that. Inst. Yeah, and I got that from here. And then let's, frick, where's it at? Here it is. So we're gonna get this, and then we're gonna say device. Okay. There's no nightmares, only sweet dreams. And, what are you doing? No, you're fine, you're fine. Device and variant. Yeah, what's the issue? It's an eye shader variant thing. You got the, oh. It's just being silly. Okay, good. That one's done. We just need to do this one. So we'll do that after the break. Okay. Sorry everyone for how long that took. We're gonna do a break now. We're gonna look at your spicy memes. I don't know why AMP is dying, but it does this all the time. So it'll come back soon. There it is. It's sadness. Sadness and loneliness. That summarizes this. Look at your recent memes? Alright, sure thing. So let me try to find him. Hang on. Give me 1 second. Alright. The most recent one. Okay, from Ichigo. Cora wanted me to post this. I love it. Alright. And it's, again, from Ichigo. It says, it's a video by Creative Handle. It says, how do you do, fellow kids? Headphones warning. Oh, frick. There's a headphones warning. Alright. Alright, everyone. You've been warned. I will try to keep the volume good, but you've been warned. It's a dab. It took me so long to register that because it was such a sin. The Office. Jim pranks Dwight. And you got the workspace safety video. Yeah, we gotta watch it again. This is a sin. I want you all to know what sin looks like so that you can avoid it. You see, I want this to be burned into our retinas. Thank you, Chico. That's beautiful. I can't believe someone made that. Oh. Oh, jeez. Alright. Oh. Taz, what the frick? Wait. No way. Okay, so Taz has this account called Snivy says, where it's pretty self-explanatory. Snivy says things. Getting blocked would actually be a good thing because then they wouldn't kill us like the other thousands of animals they killed. And oh frick! And Snivy says, what if Ashawad and I aren't blocked by PETA yet because we're both technically animals in the Pokemon world? Block us, cowards. And Taz just said this strictly as a joke. Then you have the following tweet. Hang on, it actually didn't know. Oh, here it is. I can't freaking believe it. He didn't even tag them. Wait a minute. Wait a second. It wasn't like in the first tweet he tagged PETA and he was like, block us, you cowards. No. In the first tweet, you mention PETA in the speech bubble, right? In the text. And that's it. Not even in the text of the tweet. If you searched Peter, this tweet would not even come up. How did they even come across this tweet in order to block you? Are they obsessed with just blocking people? Like they're just constantly searching. They use advanced algorithms to scan every image uploaded to Twitter immediately, and if it contains the text PETA, immediately block that person. Oh, you did tag him in a previous tweet. Oh, okay. Oh, I see it. Oh, so he tagged him once. Block me or else I'll take your Pepsi. And they were like, frick, dude, I don't want you to take my Pepsi. So they blocked you. Oh my gosh, they're so sensitive. Like, wow. That's hilarious. Unbelievable. Snappy has an obsession with Pepsi? I had no idea. Wow. Alright, we're off to a good start with these memes. Holy frick. Alright, from Shills. I found Rad girlfriend. It's Miss Quackles. Holy frick. All of my dreams have come true. Look, she's glasses. She's got a flower in her hair. What's not to like? And the same color hair as me. I respect this woman. We have from Ichigo. This DMs with Sonic 2001. Is Kawayashi hot? Yes. How much? Like a lot. This is the part where you type, you go to the FBI Twitter page. I'm kidding, of course. Oh my goodness. Sick. Then we have from, someone. Hang on. Frick. From Taz. She slip. Video 4. Alright, here we are, everyone. Oh, okay, that's actually cute. Like, not even gonna lie. No furry, but like... That's just sweet. She's asleep. Enjoy your rest. I'm gonna call her Snow, even though I don't know what this one specifically Shan's name is, but anyway. From Mega Kid. We got this video. I don't know if I can show it or not because I don't know what's in it, but let's see. It's something I got shown you as a YouTube ad the same day. You don't have any clue where you got this ad or why they made this ad in the first place. It's like in German? What? You don't even speak that language. Yeah, what the frick? Wait, let me just hear it a little bit real fast. He's probably like cursing in German. I'm assuming it's German, I don't actually know. It looked like German. What the frick is this? It's this guy in black and white, like looking at the camera and like rapping, basically? Okay. That's an ad? Weird. Wow, Mega Kid. YouTube has some strange ads they show people. Goodness. They showed me some really weird ads before too. Alright, from Static Minic. Anti-tier is horrible. And then, and then this. Wait. Don't cancel my boy Taz like that, Sanic. What the frick? Let's see. If you can't sit on your friends, what's the point? That's so beautifully random. It's. What's even the point of having friends if you can't use them as chairs? I don't see it. There's no other purpose, clearly. Oh, it was German hit or miss? Is that what that was? Oh. Oh, yes. That's epic. I hope I get banned from TikTok. Alright, from Taz, the letter H, followed by this. Oh my gosh, how much time did you spend on this? Okay, you've got the character ratings going from bad to eh to good, great, awesome, outstanding, amazing. Good, great, awesome, outstanding, amazing. Okay, neat. That's funny. Amazing includes Knuckles and Espio and Blaze and Big. You can see them all. Honey, Meadow, Shadow, Silver, Sonic Man, of course, he is amazing, I agree. Sonic and Tails. Yeah, I agree with this. Actually. Outstanding. It's Amy, Mighty, Ray, Scourge, and Eggman. Alright. Awesome. You've got Chaos, Mephiles, Metal Knuckles, Omega, Yossi, Vector. I forget what her name is. Frick, I'm sorry. She's a character from the comics. I haven't read the comics in a while. Then you have Great. Oh, wait, no. I think she might have actually been from Sonic Chronicles. I don't know, this is like Emerald, right? Isn't he from Chronicles? I always forget like some of the more obscure characters' names. My apologies. Got Marine from Rush Adventure. Got Orbot. And you have Tikal. Alright. Well, understandable. Good, you have, what is his name? Sir Excalibur from Sonic and Black Knight. You've got Chip. You've got Gamma. One of the hard-boiled heavies, it looks like. Jet. The ghost from Night of the Werehog, I don't remember her name. Did she have a name? Anyway, Mecha Sonic, I guess. What is his name? Sorry, I've turned this into a challenge where I feel like I need to read all the names because I'm like, do I know all the characters' names? Am I a real Sonic fan? I used to Yarkaz is at least he used to, I don't know if he still is, but like was a fan of this character, and so I used to see him a lot. But I think it's like Zero or something. It begins with a Z, I think. I'm sorry. Cosmo, Nicole, Sally, Styx, Zaz, Xena, Zamam, Zor, and an egg pawn. Just a generic egg pawn. Yes, I agree. Well, I feel like the Deadly Six I'd actually maybe put a little lower, but I agree with a lot of this. Is Eggman Nega. Why is he called that, by the way? Like, that makes no... That's so weird. Oh, wait, no. Frickin', there's the character down there that I thought it was up... Oh, gosh. I guess there's like a classic and modern design of the same guy? I'm sorry. I'm spacing out. I guess I don't actually know a lot of the characters' names like I thought I did. I feel kind of dumb. All of a sudden. That's, a robot from, Sky Sanctuary Zone. I guess like a Death Egg robot, but not quite a Death Egg robot. He's like smaller. Don't at me! Knack and Bean, Dynamite, and Epsilon or whatever. They were like different. Zeta, I don't really know. Egg Robo, you doof. Oh, his name is just Egg Robo? I didn't know that. Wow, okay. I know a lot less than I thought I did. Shade is from Chronicle. Okay, thank you everyone. I didn't know Shade and Egg Robo. That's Fang? Oh, did I say Dynamite? Whoops. Wow, I'm dumb. Look at how little of a Sonic fan I am apparently. I thought the whole time that I knew. Obviously we got Black Doom, Charmy, Cheese, Cream, the Dark Chow, Normal Chow, and the Hero Chow. Got a Flicky. You've got Heck. Another character from Sonic Battle, I think. I'm sorry, I never played Sonic Battle, so I have no idea. Then you have Gerald Robotnik, Infinite. That looks like a boss from Rush. Rush Adventure, maybe? Wow, frick. Maria, obviously, Motobug, Bunny, he looks like a fan character. I think he is, or a character from the comics. I don't know who that is. Omo Chow, the guy from Adventure 1. He's the dad of Tikal, but I don't remember his name. Professor Pickle. Oh, come on, how could I forget his name? He's the guy from the comics. He was there all the time. Holy frick! How could I forget his name? No, I gotta look it up. The chat's gonna have a heart attack. Because this is an obvious one. Rotor. Thank you. You beat me to it. Yeah, his name was Rotor. How could I forget his name? Rouge. Yeah, this character again. This was the one that Yerkaz actually liked. I don't remember what I don't know what the top one is then, but no freaking idea. I'm sorry. And then oh no, wait. Well, I know the Storm. Yeah, from Riders. I don't remember. I don't know who. He looks like a bootleg Jet. Is it like a Jet classic design or something? I don't know who that is. Anyway, Tails doll. Oh, she is that like Fiona or from the comics, but like a 3D render or something? Then you have Vanilla, Wave, Yacker, Zavik, and then you have Heavy. Yes, Heavy is terrible. And Bomb. You've got the Gun Soldier. You've got Cubot. You've got Elise. Merlina, I think. Antoine or Antoni. I don't remember. It's been forever. Shara! Wow! Shara! I wish for a mountain of handkerchiefs. And Master Zik. How can I remember all the Deadly Six names but not like some of the comic characters? That's really concerning. Okay, sorry. I know you didn't mean it to be an hour-long thing, Taz. You just wanted me to like show this for a minute or so and then go and like. But I was like, no, I can't identify all the characters. Ugh. Oh my gosh. My apologies. Oh, you forgot who it was too. Okay, that makes me feel a little better. It's General from Advance 3, the better Emerald. Oh right, okay. See, to my credit, I guess. Not credit, but like in my defense, is what I meant to say. I never played the Advance trilogy, and I never played like Sonic Chronicles or Sonic and the Black Knight, and I read only some of the comics a while ago. I loved the comics that I read, but I didn't read a lot of them, so I'm going off of memory with a lot of them. It's mostly like the characters from those games that I didn't play are the ones I don't know, right? Because I'm like, ah, frick. The rest of them, I'm like, yeah, I know who they are. Mostly. I never played Advance 2. No, I never did. I hear it's excellent, but I never played it. So I want to do it sometime. But yeah. I've seen footage of it, obviously, but I've never played it. It looks very fun. Anyway, we gotta fix that sometime. Same with Black Knight. We're gonna do that in the marathon. Alright, what's this? For Mega Kid, Rise of the Kings Mafia City related Add 2 Electric Boogaloo. This is how feudalism works. This is an actual ad you got? What the frick? Add 2 Electric Boogaloo? They actually named it that. We should all download the app just because of that. Holy frick. Alright, from Taz. Taz is now premiering Engine Rune, the Steelworks Revolving. Oh. It's happening. I gotta check that out after the stream. Like, holy frick. Oh my goodness. Okay, from Settingmatic. A bunch of videos. What is this? Sounds good so far. Oh. What the frick? Is it like a different sound font or what is it? Hang on. Why does every classic Sonic song have the instrument sounds like voices? I never even noticed. Sorry, there was a video, but I didn't notice it was actually a video. Like, hang on. It's a video, but like I didn't notice the background actually changed. Up until this point, it just had like a generic Sonic 4 background, and then all of a sudden it became like a church. What an odd. Well, that's so odd that it they have this instrument they use for I've never noticed that before. Apparently, hang on, let's see. He has a few more he did from I guess Adventure. That sounds the same so far. That sounds normal. Oh, I'm supposed to be showing the video. I'm sorry. Hang on. I think the point is that it like fits up with what they're saying. kind of does. So I think the point. Wait, I think the point is that it sounds like voices. So it's like the music sounds like they're talking. Huh. That's interesting. I never noticed that. And there's one more. Hang on. Oh. That was strange. That was very fitting, but I was gonna say strangely fitting, but then I'm like, no, actually it made sense. But the other one, I don't know, but that's funny. I love the one with the church background at the end because that's hilarious. Yeah, I never noticed it does sound like voices. That's odd. Show the video you sent. Which one? You sent several videos. The Electric Boogaloo one or the one in German? All right. Wow. Because the chat has a delay. So in the meantime, okay. Well, Shills posted this, and then Ichigo enjoyed it, and then okay, from Ichigo started streaming 69 minutes ago. Nice. Can we get a big nice in the chat? That is nice. Sorry, I should be playing music. The Electric Boogaloo one. All right. Now I do get worried, admittedly, about copyright with these things because I don't want YouTube to like claim my video, right? So I'm cautious about what I show. But this is an ad, so I'm hoping as long as there's no copyrighted like music in this, it should be all right. So here we go. Oh, jeez. Oh, jeez. Oh, and then and it recommends me a Giga video. Sweet. What the frick? Wait, that's the whole ad too. It's 15 seconds and it cuts off right then. That might be the greatest advertisement I've ever seen. Like, I'm sold. I don't even need like to know what the app is about or anything about it. I'm sold. That's amazing. Thank you for sharing that. I can't believe they put Electric Boogaloo 2 in the name, like, as well. Sorry. Wow, that's amazing. Is this the new This Is Mafia? Apparently. What the frick? Who knew? That's beautiful. I really like bad ads like that, actually. I never realized how funny they are. Well, no, I did, but like I never thought about showing them on stream. Maybe I should do that, actually. It's technically an advertisement. Alright, from Ichigo getting approved. Yes. So wait, did Neil actually draw this? Cause like, holy frick. I love it. Whoever drew it, it's really good. You can like stamp it anywhere too. It's perfect. It fits on anything. Oh, and I love this meme from Static Manic. I've seen this, but it's so good every time. It's like it's so rude, you know? It's like, come on, man. I know you're not getting paid much, but like you can be a little nicer than that. You know, like, come on, just hand me the food. You don't have to drop it. Mill drew it. That's awesome. She draws a lot of things I don't even know about until later. That's kind of amazing. Hey brother, here's your food. Yes. This is epic. This is so epic. I can't even believe it. Okay, I'm gonna show a few more from Ichigo, because these are all amazing, and then I'm gonna stop for now and I'm gonna show the rest of them in the next break. So, first off, I don't know what the context is to this, but I guess that's the point. It looks as though there was a container of milk which has spilled onto this green. It's something something green. Wait, is this Percy? Is this from Taz's video? Oh, yes. Alright, now I'm interested. And then we have a bunch of pins from Ichigo, from Pinterest, of My Hero Academia characters. Why do I have the wisp sounds in this? Let's get that. That's female Deku, it looks like. Excellent. And then we have, oh, they're all female Deku. I see. The third one was just really stylized. I don't even know. This is epic. Okay, one more from Ichigo, and then I'm gonna stop for tonight. Well, for this break. Sorry, I'll do another one later. Oh no. Oh no. Rad is scared. He should be. It's the Joe. I am scared. I'm petrified. I'm getting a heart attack. I need to take some, I don't know what the name of a heart attack medicine, but I need to find it, and then I need to acquire it. I need to take it. Oh, it's Henry. What? Wait, then you said why did I say edit? You meant idiot, I guess? You talking to me or what? And then you're joking. Oh, it's cool, but it's Henry. Wait, it's really Henry? Hang on. I remember a character named Henry. I gotta find it because I believe you. Of course, but oh yeah, Henry. Holy frick. It looked like Percy though. Wait, no, it was Percy, wasn't it? Cause like, hear me out. Hang on. Obviously, you know your tank engine's way better than I do, but look, here's the thing. So Henry, to my understanding anyway, looks like this, right? So he doesn't have the little yellow like bells anywhere on top of him, right? It's just a bunch of green. So then you have Percy, and Percy, he's got these little bells on the top there, see? Like towards the back, towards the part where the person sits. So then if you actually look at the screenshot, there's like 2 little yellow bells back there, see? You see him in the corner? Henry isn't a tank engine, he's a tender engine. Oh, my apologies. I didn't mean to offend. But I think I've myth busted the scenario. I think I've gotten to the bottom of it. Wait, before the general. Okay, one more from Ichigo, and then I'm gonna go back to the stream because apparently it's one more he wanted me to see. Before the jello one. Okay, I'm looking for it. I think it's this one. What? Silva Gunner got their channel back. I knew that. But here's the crazy part. This is what they uploaded. Message from the Queen. Shadow and the Snow Queen. Oh, they are taking advantage of the fact that they have the channel back now. Oh, yes. Okay. I'm so hyped. It wasn't a bell, it's a whistle. I'm dumb. I'm sorry. Okay. My bad. But yeah, so there you go, everyone. Thank you all so much for sending me your dank memes. I really appreciate it. This is epic. But yeah, so I'm gonna go back to the stream for now, and we're gonna see the rest of the memes later on. Thank you all for sending them. It's before that one? What? Oh, frick. Okay, hang on. Oh yeah, you sent me, I think you sent me this in DMs, but I didn't know if you wanted me to show it on the stream or not. Okay, I'll show this real fast. The day has finally come, the day justice may be served, justice is I know you can't see it yet, but hang on. Justice is beautiful in many ways, and today, the Ichigo gang won't allow the police to leave justice in the refrigerator. The Ichigo gang will take justice from the refrigerator, and then to the microwave, and serve it on a golden plate. Ken Penders has done many horrible things to humanity, but today, he pays. We will make him pay. Mac and cheese. Oh, it's beautiful. And attached to it is this image. You have Ichigo and I forget, is this Chloe or is this Hiroshi? I forget which one. But then you have Ken Penders. Then you have Ichigo gang. Ken Penders. And then Ken Penders is like, hold up! And then the E2 gang has been summoned. Oh, the entire gang, including that random Amy from before. Oh, and all the female Sonic variations. And holy frick. The whole E2 gang. Oh, okay, one more, apparently. Let's find Ted's. Yeah, hang on. Oh, okay, yeah, I'll show this. You made this Sylveon sprite that you're fairly proud of. You're fairly proud about. You made her too big. Sylveon are like around 2 feet, but in this case, she's taller than Mighty, but you don't care. You haven't shaded it yet, but yeah. It looks really good. GG, like, it looks really nice. Like, it actually looks really professional, holy frick. Good job, man. Alright, so, oh, this song's good. Well, corny, but I like it. It's normally to going for age to go, oh, that's it. Okay, that's what I thought, actually, but I didn't want to say that because I didn't want to be, like... You know, if I was wrong about that, then I would have... That would have sounded, dumber. You know what I mean? I think these things out like I'm strange. I'm like, if I'm not certain about something, and what I want to say sounds dumb, I'm like, I just won't say it. Anyway, Chloe's not part of the meme though, twice actually, epic. Yeah, Chloe was the one with the blue hair, right? Or did I get that wrong? What? Wait, this was a vocal theme? Yeah, there's a vocal version of it. Well, in Sonic Riders, in the first one, there was a song called Catch Me If You Can, which had the same lyrics as this, but sounded like garbage. I'm sorry. And, not complete garbage, but it was just like, it was like a really, you know, cheesy rap, and that was it. And there wasn't really any instruments to it or anything. It's just not my preference, I don't know, sorry. And then in Zero Gravity, they had like another composer who was like, we want to have Catch Me If You Can again, because that's like the theme song of like Jet and everyone, and but they were like, we need it to sound good, and he was like, frick. And so anyway, they put this instrumental part in the back of it that I think makes it sound a lot better. If you listen to the Riders one and then this one back to back, it's like, this one sounds really good. That's my opinion anyway, I don't know, but some people might actually prefer the Riders one. If so, that's cool. Anyway, so we got a okay. So this is gonna be the part. This is the part where we have to actually create the input elements. So this is gonna be interesting. This actually, for this we need the variables. We're actually going to need to go in and get them. So, okay, before we do that, the part. Yeah, what part? Rod's gonna do the thing? Oh yeah, I'm gonna do the thing! Oh frick! Wait, I need to actually do the thing. People would find that hilarious. I mean, no they wouldn't. Not that I've said, now that I've said that, they won't. They'll expect too much. He's gonna do the thing! Holy frick. Alright, I'm gonna have to do the thing. This is their last ditch effort. Alright. Alright everyone. Whew. I think we can do it. We gotta summon the powers. Here we go. Here we go, everyone. Let's do the thing. Let's do the thing. Yes. Wait, let's make it better than this. Yes. Yes. This is clearly what you all intended. Yes. Yes. Now the only problem is, how do I get these penguins off my screen? Because I can't program when you've got water over my... That's bad for computers, actually. We need to get rid of that, I think. That's gonna cause damage to my Penguin Baywatch? No, I did not ask for this. Okay, wait, what's the spell? Wait, let's see, Azuka Baluka. Okay, there it is. Oh my gosh. Alright. I'm sorry. Anyway. So, let's let's create some input elements. So I actually gotta do the variables. I gotta figure out that crap that was causing it to not compile earlier. I gotta figure that out to properly do this. So maybe when I'm just gonna be lazy. You know what? I'm just gonna be freaking lazy for now, and just hard code it just as a test, and then later on I'll do it the proper way, I suppose. Oh no, wait, no. Let's see. Can I even do it like that though? Cause like it might actually be easier to just do it the proper way. I have to think ahead a few steps here. Sorry, hang on, let me check something out. So we've got all this done, but we still need to finish this, which actually isn't as bad as it seems necessarily, but because a lot of this is actually kind of easy. At this point, the only thing that's really difficult is this step that we're on here that I forgot was even a thing. Heck. Normally Ichigo and Furichigo are walking on the street. They find Ken. The three of them look at each other, then Ken shows them one of his comics. Then the whole Ichigo gang, which includes the Queen, Normal Ichigo, the Queen's wife, Normal Chloe, and the Queen's executor, Ichigo Undertale, all attack Ken. Oh, that's what's happening. Oh, I see. The only part I didn't get was why it happened after Ken lifted up the comic. I see. Oh, because he was showing it to them, of course. That makes sense. That's the only natural reaction to Ken Pender showing you one of his comics. Like, legit, like, any other reaction, you know, we've got issues in that case. Oh, your 3DS is going dead because you've just been letting it sit there for too long to, like, lay down sleep. That's understandable. You might want to find your charger. I don't know why I'm, like, giving you... It's like, yeah, Rad, of course. Giving life advice. Alright, so... Gotta create and put on some passment. Frick. Let's see. So... Oh, that's from Riders of Gravity, yeah. The Riders of Gravity soundtrack as a whole is really good. Yeah, I like it a lot. It's got this nice style to it. If you're still asleep, you're happy? This is epic. She's getting a rest. Alright, so... let's see, we gotta make these input element descriptions. The only way we can do that is if we know exactly what the input is going to be for this. So, in forces.shader.h, we have these variables up here which explain exactly that, actually. There's variables which are just normal variables, there's registers, and then there's constant buffers. So register variables actually have a register index, whereas normal variables do not. It's the only difference. These actually can be, yeah, the normal HN variables are actually gonna be, oh, this part's cool, sir. These are gonna be the ones that, oh, then there's also constant, right. Okay, so this one's gonna be like part of the, like, how do I even explain it? It's like a texture or a sampler or something would fall into this. Where this is a constant buffer and this is gonna be a constant buffer variable. Okay, so, when we go to read all these, yeah, we have to like figure out what type it is. So textures and samplers are always going to be registered. This is going to be constant buffer, and these are going to be constant variables. Oh, so there's actually no. Oh, okay. Fascinating. Wait, I'm actually confused about something now. Hang on. I thought I knew this, but actually there's... What the frick, Windows? Well, guess I have no hard drive space. I guess calculator was collecting too much telemetry. Can you imagine if calculator was like, I'm sorry, we just dumped a 2 GB crash log? Probably would. I wouldn't even be, I would actually not even be surprised. I'd be shocked if it was 20 gigabytes, but 2 I'd be like, yeah, that sounds about right. Needle shader. Alright, just grab a shader. Who freaking cares? So this is the size, 1770. It's gonna be most of the file. So this is the part I don't get. I need to figure this out real fast. Alright, 7C. Alright, and then 94, which includes this. So, this last part here is that. Okay, you've got depth, you've got this. Oh, what am I... I'm looking at a pixel shader like an idiot. Okay, let's look at a vertex shader, shall we? Sorry. Let's do a tiny one. I want the smallest vertex shader that exists, if that's possible. Yeah, there it is. Oh. Thanks, Mario. Don't sue me, Nintendo. Oh, I like this song a lot. Even though it's simple. Okay. CB Surf Ride VP. And that's all that's here. So we got, this whole thing is 48. We got 5, which I think is a constant buffer. It's sad that I've memorized these. Okay, then we have 20, which is the size of that section. And then we have 8, and oh no, there's 2, sorry. GMTX 8 is a float. So if we were to decompile Surfride halftone, where did I... Let me put this over here for a second. For the shader thing, shaders out. Yeah, here we go. Surfride, halftone VSO. Here it is. So I already decompiled this one apparently. Okay. So if you pull this up, so here is the layout. Okay. There's no, there's absolutely zero indication of that. Yes, Surfride VP is the constant buffer, GMTX is the matrix inside that buffer. And actually, interestingly, it doesn't even make sense. Wait, like, hang on. Oh, this is 40. This is the size, I presume. So this right here is like, yeah, 64 bytes. So, okay, I'm fine with a bunch of Mario music, actually. This is cool. This is so epic. Well, epic gamer moment. This is epic. Wow. So that's annoying, but I like doing that voice. So you got the constant bar of index, the data offset, and data size, and there's another one at the beginning. So the data size is 64 because it's a matrix, yeah. So alright. That all makes sense. So the only part that I don't get that I thought I got was... Actually, I forgot the variables are not, actually contained within this, well, like the input, like this part. I need to get this part, right? It's not actually in here. So that is, fascinating. If you have a Ken Pender's comic, yeah, you have issues. Many. Also, whoa. There might be a stream delay of like 15 minutes or something. What the heck? Because the position color text chord. That all lines up with this. And this is part of the input signature. So I understand. I think I get it now. That like why they need to have this. So the input signature part that I didn't get, I was like, why is this here? They somehow use this data to generate an input layout, I think. How in the name of frick do they do that, though? It doesn't really make sense. So this has just an input signature and then nothing else. Huh. And they somehow, from that, derive... Because, like, it isn't just based on, like, there's only one shader in here and it's the default one. So it's not like they just, they don't just have, like, a preset thing for all of them, though. It, like, changes. If I, like, grab shader FA, it's gonna have a different... Yeah, it has position, normal, tangent, binormal color, 4 texture coordinates, 2 blend weight and blend indices, and then an instance ID, versus this, which just has a position, 2 colors, and 2 text chords. Oh. Hi, Cave Story, I think. Yeah, being loud as heck. Out of nowhere, jeez. I like the Cave Story with a lot, but like, wow, that was loud. Okay, to the internet! Direct 3D, like, what? DXBCI signature? I've seen this before. This is a nice page, but this describes the input signature of a shader. For a vertex shader like this one, the input signature describes the shape of the data coming from the application. So this indicates that it is a resource definition chunk. Then that is the length of the chunk in bytes, the element count, and I don't know what it's used for, epic. So this is the chunk size, I guess, in bytes. In their case, how big is that then? Like, I guess it's 4C. I'm too dumb to like do mental things like that. Okay, the element data immediately follows that we have 2 elements of these values, the byte offset to the element name. So this is, wait, he said he didn't know what these 2 values were. No, it's the element count, which is 2 in this case. For our case, it's 5, and then 8, and he doesn't know what that's used for. Okay, so then immediately after, each element is like this. So the byte offset, the semantic index, the system value type, component type, 3 means floating point, the register, and the mask, and then the read-write mask. And then repeat for each one. So 1C, and then you do that again, and then you would do that again, I guess. 3, there's 5 of them, so 4, that doesn't seem right though, does it? So I must have miscounted something there. To the internet mobile, yeah. Exactly, we're getting in. We've lost some information such as the name of the struct and the names of the struct fields, but those names aren't needed by the GPU. Yeah, it's just a sign. Well, right. All we care about is like this. So I understand that. What I don't understand is how does the game... I understand that they can pass this to DirectX, and DirectX can use this information, well, Direct3D I should say, can use this information to actually verify the signature of the data and make sure that our input layout matches up with the signature. What I don't understand is, okay, so how do you make the input layout then? They must have to somehow create it from this, which I didn't know was possible. This song is really good, by the way. So are they actually parsing this they actually have their own custom code that they wrote to jump into this part and read all the data and then construct an input layout from this? Delete Radfordhound. No! Don't do it! Alright, wait, like, compiled input layout? Is that a thing? This is the only way I'm aware of to create an input layout. Let's see. The size of it. Okay, so hang on a second. This is an array of input assembler stage input data types. Each type is described by an element description. So it's it's an array of element descriptions. And then you have the count of how many there are. After that you have the, a pointer to the compiled shader. The compiled shader code contains an input signature which is validated against the array of elements. See remarks. After creating an input layout object, it must be bound to the input assembler stage before calling a draw API. I get that. Once an input layout object is is created from a shader signature, the input layout object can be reused with any other shader that is an identical input signature. Yeah, I know this. If the data type of the input layout declaration does not match the data type in the shader input signature, oh jeez, it would make a warning. Yeah, alright, well that's, I get all that. I probably don't get this, like, okay, I'll figure that out in a second. Would you like to permanently delete shills? Smash this yes. Oh my goodness. You're funny. Thank you. I was talking shills rad. Oh frack! That's fine. Okay, so you call this to create it. To bind it, you call this. And that's it. That's all there is to it. It's as simple as that. So this is the only way you can create an input layout. Okay. You were indeed talking to shills. Yeah, I know. I'm just screwing around. Sorry. I should have made that more obvious that I was joking. Automatic input layout? What's this? Oh, jeez. So they're actually... Yeah, this is reflection that's generating an input layout from the elements. Okay, so here... Wait, you're actually compiling the shader. And then you very easily create it with the following function where you just... Oh, what's this? Your shader reflection actually... How does that work? So you actually go through it and you create an input layout from the shader that you passed in. So this is probably what Sonic Team did. What is this? Sorry. You have more fun with the others, game developer, taking you away from story mode and then multiplayer. Oh, that's true. What this function does is peek inside the compiled shader using a shader reflection. I understand that. How do you do that? You need to do compiler. Cool, but did it say? Where do you? Where was there D3D reflect function? It's not anywhere. The function is simple and not meant to be robust. I can slap it together. Wait, is D3D reflection a built-in thing? Oh, it is. Oh. Oh. Okay. That page is showing you a great meme. Yeah, it is, apparently. Holy frick. I should let them have ads. Have your advertisements. Load in. There it is, WordPress. Holy frick, it's inverted Woody! Ah! Sorry, that was loud as heck. Oh, jeez. Oh, I don't know if it's magic. Looks like a nightmare. Yeah, don't show that. Okay, too. That's fine. I've probably showed like general location 400 times, at least on these streams. The music stopped just for that. Yeah, it had to. It had to. It was like a special moment. Oh jeez, hunted freaking Woody. I'm still shooken up about it. It started back after. Oh, you mean when the neighbors showed up? Yeah, every freaking time. The music stops right when they leave. It's kind of funny. You know if I just actually screamed. Oh, thanks. I'm sorry if I broke your ears. I didn't mean it. Okay, just petrified. It's no problem. Everything's fine. So, Sonic Team. You didn't. You've seen those Oh look, Windows freed up some space randomly. Okay. Deleted the calculator dump. Wait, it was exactly 2 gigabytes. I joked about. Oh my gosh. I was joking that it would be 2 gigabytes. You know those Ellen memes people have been sharing lately? Like, oh my gosh, Ellen, you didn't. Sonic Team, you didn't. Oh, you actually didn't. Good. Because that would have been really stupid if you did that. Yeah, I don't see any reference to compiler. Alright, good. Because freaking... if you did that, you have no idea how disappointed I would be. Okay. So... if they don't use this... oh, wait a minute, what's this? Is this still in D3 compiler? You know, come to think of it though, maybe they do and it just doesn't show. Hang on. D3 11. Oh, frick. Yeah, well, there's the DLL. Let's actually search for .dll and see how many of these they use. I searched for D3D compiler because I wanted to see if they included the shader compiler with the final build, because that would have been bad, but not super bad, but just kind of, you're not supposed to really do that. Doesn't look like I did though, actually, so interesting. Steam API. There's actually a lot of DLLs. Oh, there's D3D, there's X input, there's kernel 32, user 32, GGI 32, all this Windows stuff. Pappy. There's my Pappy. There's DXGI. Direct input. Why are you using direct input? Okay. They're using X input and direct input for some reason. NTDLL. Steam API. OLE. I see that again. DXGI again. Is it looping? Oh, it's looping. I'm stupid. I'm pretty sure it's looping. No, wait, I'm not at the bottom yet. Oh, this song's good. Pappy again. I must be looping, because like it showed this already. Oh no, here's it's just repeating the same block over and over again, but it's not looping. So it would tell me if it reached the bottom. There it is. So they just repeat that several times in the exe for some reason. Okay, well that's not up to them though, that was the compiler that did that, but weird. Isn't kernel 32 for managing other process memory? It's for interacting with Windows. Yeah, that's like one of the things you can do with it, but it's used for a lot of things. So yeah, probably for... if they were actually using it for that purpose, it might have been something related to Denuvo actually. Because Denuvo would probably have to do some weird trickery with other processes where it has to ensure that you're not using like cheat engine or whatever. I don't know, it could be a lot of things. But I was just looking for the compiler and it wasn't there. So they have the DirectX, they for sure have Direct3D 11 DLL, which makes sense, of course, they should have them. They don't have any of this reflection stuff. So that's fascinating to me then. Oh wait, it's available as a library. They might have just static linked it. Okay, so wait. So here's something we need to check out. Keep closing the 4.exe and then reopening again. Here's something we need to check out. That's gonna not find anything. Okay. So what about this? They don't always leave strings in the exe, obviously, but sometimes they do. Genova does not work. It really does not. Well, actually, to be fair, I think Sonic Team purposely didn't turn on the part of Genova that makes it disable cheat engine, because I've heard that it does work for other games that actually use that. So either Sonic Team did it on purpose because they wanted to be nice and they didn't want to prevent modders from using cheat engine, or they actually wanted to prevent modders from using cheat engine and they just had no freaking idea what they were doing and didn't notice it didn't work. Like they didn't implement it right. I would not be surprised by either of them. But yeah. Okay, so they don't use this, but this is interesting. You can use the D3D compiler to actually get reflection data about the shader. So you can actually get the input signature there, and from that you can actually build an input layout. So that's very fascinating. So okay, hang on, direct. How does the game do it then if it doesn't use that? Direct 3D11. Oh wait, instead of just setting a struct. Hello, I was looking around articles where people discuss working with shader reflections and I wonder why it is even needed. Can't you use the direct... Oh yeah, I'll make the concept over class to be a template. Put an update where it maps the resource. Okay. Biggest limit of that approach is that you require knowledge of the exact shader files at design time, so that you can create a struct of the appropriate type. If you're trying to wrap a prototype, yeah. I get that, but... Okay. Alright, let's see, direct 3D. Create input layout from Instagram. What? Sorry, that caught me by surprise. Google is very accurate. Create input layout from compiled shader. If I can type, okay. Digital Snow is still asleep. Oh, hi, Bit Defender. That's epic. She's getting her rest. Indie for new Sonic Forces update breaks Codename Gamma's sheet table. Yes. That would definitely happen. So, how does the game do it if it doesn't... This is very perplexing. Well, this is the only part of the plan I didn't have figured out, because I didn't, like, realize this was even a thing. They probably just freaking just jump into this bytecode and, like, parse it, don't they? They probably manually parse that bytecode. Even though that's... They could have just made, like, their own struct. No, that's too hard. But, like, why do it that way? There's got to be some built-in DirectX thing that they're using to do this, because there's no way Sonic Team would do that. I mean, that's not just like stupid. Like, that doesn't make any sense. To, like, go out of their way to write their own code to do it, and then not come up with their own format. I like all these shader lists, by the way, which have nothing in them. You just have the bin A header, you have the signature of the version number, then you have this array, I guess. Yeah, this array, which you got an offset right here, which points to the right here. You got the offset and the count is 0. So the offset is irrelevant, it points to here, because this is where the data would be at if there was something in the file, but there isn't. And then, yeah, there's nothing, so it just writes the offset table, and then there's just one offset, and that's it. So it's an empty shader list. There's a lot of these. There's really a lot of them. There's only a few that are actually not empty. Well, that's not true. There's several. Oh, Sunset Forest. When I think of a peaceful sunset in a faraway forest, I think of a guy with he's on steroids and crack at the same time, and he is jamming. His fingers are bleeding. But he's not even stopping. It doesn't even matter. There's blood freaking everywhere. Let's skip that. Oh, that part actually sounded cool though. I should have not skipped it. Oh well. I ignored my request to skip it anyway. Nah, actually, yeah, let's skip it again. It's not doing it. I clicked the button, it's not even, okay. Guess we're listening to Sunset Forest. So, this is the only place that could possibly... Oh, there it is. It's Pumpkin Moon. Epic. So this is the only place that... Yeah, that's why they included this. This is the only place that has the input layout. So what I want to see is... So I got the Switch version of Forces Extracted recently. And I've been looking at how the Switch does a few things. What I'm very curious about... Wait, did I extract it here? No, I extracted it in, You ain't gonna let it get to you. I ain't gonna let it get to me. I'm just gonna creep. Down in Pumpkin Hill, I got to find my lost piece. I know that it's here. I can sense it in my feet. Great Emerald's power allows me to feel. Can't see a thing, but it's around somewhere. Gotta hold my head. I have no fear. Alright, so... Here it is. Surfride halftone.vso. Okay, and here's the shader list. Again, on the Switch, it's empty, as expected. This is exactly the same as the PC one, at least. It seems that way to me. This is the vertex shader on the Switch, though, and this one's actually different. Obviously, because the Switch doesn't use DirectX. Obviously, it uses its own, like, the Switch shader format. I don't know what you call it. There's a name for it, I'm sure, but... Anyway, so the HHNino format is the same, but the bytecode it contains is different. Interestingly enough, the developers who made the Switch version of the game were also different from the developers who made the PC version, because remember, the PC version of the game it's a port that was created by Hardlight, the same people who made Sonic Dash. Whereas the console versions were all done by Sonic Team. So you can see actually in the build path at the top here, yeah, the shaders contain their build path, even though there's no reason for that to be in there. I don't know. There probably was for their tools, but they didn't need it in the final game. Anyway, you can see whoever compiled this shader was, he had all the Sonic Forces stuff in this folder on the D drive under HL, which I believe stands for Hardlight. Sonic Forces Beta Wars app shader source, and then vertex shader surf ride halftone.vs, and so that was the path to the vertex shader file that then got compiled and turned into this file that you're seeing here. So then when they made the Switch version, instead the file was located at on the E drive. See, because the Sonic Team uses the someone say folder, no tabs, no stop. Sure. Why not? People are gonna be screaming. It's gonna be hilarious. There's an E drive that Sonic Team uses the E drive, whereas Half-Life uses the D drive. Kind of funny, but anyway, yeah, they have a folder on the E drive called Project, and then Wars app shader, and then from there it's pretty much the same. SRC VS, Surfride halftone.vs. And I guess they just had like a consistent vertex shader format that Because this is the same path, basically, once it gets into the wars folder, right? So they must have actually had a custom like vertex shader format that they could compile into any type of vertex shader, which is interesting to me. But anyway, then from here on out it's the same thing, but the big difference is so here you've got the DXBC header, and it's really obvious where the shader begins at because of the DXBC part. You just look for that and then you back up a little and then you find the size and it's easy. There's no header in the switch shader stuff, so it's a lot harder to figure out where it begins at. You gotta go through it piece by piece, basically. So let's see. They've got the signature, you've got the size, you've got... I already forget. I think there's just two values. One of them is an unknown one. The other one I think is the parameter count. Yeah. And then you have, for each parameter, their type, followed by, yeah, you've got the type followed by the name of it, basically. But there, in this case, the count is 0, so we just go onto the indices, which begin right there. Epic gamer moment. And then right after that, you have the shader count. Is that correct? I don't actually remember if that's correct. Should be. Let's double check that. Header, size on the one parameter count. Yep, that's correct. And then after you read all that, you got the shader end, parameters, index count. Okay, cool. And after all that, you have the shader count. Yeah, for some reason they put the shader count at the end. Kind of weird, but anyway. So there's the index, and then there's the shader count. Sure enough. Here's the index, here's the shader count. Okay, so then the first shader begins right after that. So yeah, there's the node, and then there's the shader size, and then after that it's the shader bytecode. Okay, so this part here is going to be, this is the shader bytecode, it's CO, like that. So that is the switch's version of the Surfride halftone shader. Okay. And then right after that, we've got the input shader section, or at least we would. This is the part I wanted to look at. This is the part I was interested in, but hear me out. At least we would, but we don't actually have it. Because on the Switch version, they don't have an input segment. Interesting. So how then does the Switch version know what to pass into the shader? What the frick? There's gotta be a way. That makes sense. Maybe they hard code some of it? But that wouldn't make sense. There's 321 files in Needle Shader. A lot of them have different input layouts. That would be really stupid to try to hard code that. Okay, let's see, cling rip. Where did I, was it boot? No, not that. Oh, fun fact about the Switch, this is just a GIF. You know when you start up a Switch game and on the top left it says Nintendo and on the bottom right it says Nintendo Switch and it has this little animation? Yeah, it's just a GIF. I find that really cool. You can send this to like friends on Discord and it works. That's kind of amazing to me. Don't mind all this. Okay, those are the icons. That's the application. Yeah, what I'm looking for is the exe. I think it's in secure. I found it before, but it's not an exe obviously, but the executable. There it is, main. So okay, this is the place. Obviously, we're not gonna have any direct 3D stuff here. We are gonna have like needle shader stuff though, probably. Yep, there's the needle shader. Okay, so this is definitely the executable. So what I'm looking for is I want to see if this stuff is here, so hang on. Surf Ride Halftone. Let's see if this has anything like that in the EXE. No, it does not. There is no data that is hard-coded for this shader. At least, if there is, they don't bind the hard-coded data to the shader via the shader's name. So I don't know how else they would bind it, but so with that said, how in the frigging universe do they know what to pass into the shader? Like, what? Well, maybe on the Switch version... Oh. Alright, let's let this play. It's actually, unironically, a beautiful song. It's just that it's in a Sonic game. That makes it, you know, ridiculous. But it's legit. It's actually good if you pretend that it's not from Sonic. Alright, so look at all these nulls, by the way. That's not Sega's fault though, that's just the Switch's shader format, but like what? Why? I wonder if how much of this has been cracked, because they needed to crack this to make what's it even called? Yuzu and Ryojinx, right? The Switch emulators? No, I'm ridiculous? Epic. It fits perfectly with Sonic. Oh. You're right. Yeah, when I looked at Green Hill, I was like, yeah, dude. I thought of this. It's like the entire Sonic R OST, good but unfitting. Yeah, okay, I agree with that. Yeah, the ROST is actually good. It's just very... When you remind yourself what it's from, you're like, oh yeah. Huh. It's interesting. Sega had a way of doing that. So, okay, I wonder if for the Switch version they just have, like, maybe Nintendo actually embeds the data that they need in here and they parse it from that. So then they don't need the input section because it's just right in here. But if that's the case, why did they do it for the PC? Because look at this. DXPC, RDF, input signature. It's right there. Look at this. Position, color, text coordinate. Oh, look at this. They have the signature right there. And then they have output signature. There it is. It's all right there in the shader. But then they were like, no, let's have another shader after that that has only the input signature part from up here. Exactly the same. Just only that part. Why? If you're gonna, like, either make your own format that contains basically this data without the stuff you don't need, or delete this part and just parse it from this. If you're not gonna make your own format and you're just gonna use the shader, you're just gonna parse it from here. Like, pick one. So that's really odd that they didn't do that. Does anyone... No, this is stupid. I'm not even gonna ask, because... Well, I'll ask because people are gonna be curious what I was gonna say, but I know the answer because, of course, like, how... Of course not. If anyone has, like, Forces on the PS4 or the Xbox One, and also happens to have a modded console so that they could extract the game, oh man, it'd be really useful to look at the shaders from one of the PS4 or the Xbox One. I don't even care, just any copy of them to see how they do it, to get a better idea of like how Sega did this cross-platform. But no one does. Of course not. What are the odds of that? So, yeah. Unless if someone happens to have like a pirated copy of Sonic Forces for the PS4 or the Xbox One. No, that's more, actually that's sadly more feasible because people are a lot more willing to download a file from the internet even if it's illegal than to mod their console and rip it like that. So anyway, if you happen to have that, let me know, because actually, I'm very curious to see how the shaders work. I just need like 1 or 2 sample files from it to see. I don't imagine anyone does, though. You have no Xbox One or PS4 at all? Same. That's gonna be interesting. I have a couple of random files from the PS4 version, I think, of Forces, because I think Michael sent them to me. I don't know what he wants me to call him anymore. I'm sorry. I think Eminem is what he goes by now. Yeah, I've got some G edits from the PS4, but that's it. So he has a copy of the PS4 data then. Because he sent me this, so I should ask him. Okay. For now, we're not going to do that, though. Because I don't want to bother him. I just wanted to... All I wanted it for was to see how... if they have an input section in their shaders. Because if they do, it would make sense. But if they don't, I don't understand why. It seems like it's only a thing on Windows so far. I don't understand why. Oh. So let's see this. This is gonna be the obvious stuff that I already know, but I just want to make sure that that's all it is. This is used to define all the vertex data attached to the input assembler stages laid out in memory, and assist an instance of the DirectX 3D11 input layout. Okay, yeah. Number of elements, shader bytecoded, bit signature, yeah, I get all that. This is the element, I get all that. And they're just showing how they create it. They hard code it, yeah. So most people hard code this. Sonic Team obviously didn't hard code it. That's the part that's perplexing me. I haven't said the word perplexed in like a century. He changed his Twitter username to Slashy again? Oh. So I guess Slashy? Because I always used to call him Slash. That was just the word that I was just like, yeah, he's Slash. That's like how I don't know. That's what I knew him by. You know what I mean? But I think he doesn't want people to call him Slash. So I don't. I'm trying to avoid it because I don't want to like use a name he doesn't like. Because I get that. Of course, you know, sometimes people change their usernames or whatever, and they don't. They want to get rid of. They want to ditch the old one. So it's not very nice of me to continue it. But I'm not trying to. I just don't I genuinely forget what I'm supposed to say every time. Yeah, so I'm just gonna call him Michael. Hey, Vsauce, Michael here. I love those memes. Like, oh my gosh, they're some of my favorites. Okay, so how about this? Create input layout. Yeah, like real time. Without. That's not what I want. I don't think. Ah, boy. RTX shoes on. I love those memes as well. Hey, Vsauce, Michael here. I'm hungry. I don't know if that was part of the Vsauce or if you're actually hungry, but... Oh, you're actually hungry. Oh, yeah. Go get some food. Best girls deserve food. Keeping the blobs around. Yeah, but hang on. Oh, it doesn't matter if you keep the blob around, buddy. It's not my problem. Ugh. Oh, is this song? Okay, all I want to do is create an input layout from the shader data. So I think it's pretty obvious at this point we're not gonna get something to draw on screen tonight, but I was hoping we would. But we're getting so much closer every time, but like we keep inching, you know. All right, well, but the thing is, we just need to figure out how to get this information. So what I think Sonic Team is doing, genuinely, as dumb as it is I think they're taking this part and they're actually parsing it in a similar manner to what DirectX would actually do. And they're using that information to then create an input layout. Which is shocking, but okay. That's a way to do it. That would work. So I can do that too. I just need to I can write custom code to do it, or ideally what I'm hoping is there's actually a built-in DirectX thing to do that. Like to create an input layout from a blob like this, because that would make sense. That would make it like, oh, I see why Sonic Team did it like that, because there's a function, you just call it with this blob and it works, and you're done. Easy. That would make sense, but I don't think there is. So, did they have to write code then to go through this whole thing and like extract just the part they needed, and then generate a new DirectX bytecode like compilation with just the signature in it, only to then have to manually go through and parse it at runtime and like figure out how to make the input layout from here? Because like at that point, why not just replace this part with a custom format that you could use to quickly and easily load and then just use it? So you wouldn't have to like parse anything you didn't make at all? It seems silly, but oh, this compile shader with just a signature. I capitalized it. See, now you know it's important. No! Specifying root. What is this? A root signature can be specified in HL as well as a string. The string contains a collection of comma-separated clauses that describe the root signature constituent components. The root signature should be identical across shaders for any one pipeline state object. Here's an example. This is DirectX 12. They're using DirectX 11, so this isn't even a thing in that Forces could have used. Okay, partial signatures. No, I just want... Ah, jeez. Only signature. How about this? Compile signature. Can we just say that? No, just compile this signature, nothing else. Oh my gosh. Alright, so parse DXPC. This really seems to be the... Oh wait, no, what's this? But this is a get everyone's... Okay. I thought it was a Microsoft thing for a second. What's this? Yeah, this is the blog post I mentioned earlier. This guy linked... It's his blog, I guess, so that's... Okay, cool. Gosh. Okay. So, I get the feeling, I still get the feeling there is a, there's a built-in DirectX function that you can use to just say, "Hey, Jim, grab that blob bytecode right there, you freaking moron," and just use it, and it just works. And I'm sure it's right there, and it's like obvious, and I'm just not finding it. And I'm gonna spend like 20 hours writing this, and then I'm gonna find it and be like, screw me, I could have just used that the whole time instead of all of this. But I can't find anything like that, so it kind of seems like I just need to write it myself. So with that in mind, it really doesn't look like it's that hard to parse. It actually looks quite easy. Let me just do a little more delving to make sure I'm not wasting my time. Airtime by extension. It should be around here somewhere. Here we go. So I've got a Sonic Forces decompilation from Supersonic 16, which is very handy for checking how the game does certain things, but of course it's quite hard to read. Okay. Let's first check for this. Yeah, that's not in there. Okay. What would they have put in? Oh wait, let's say input layout. Maybe there's a name of it. No. Okay. So the DirectX stuff, a lot of it was like taken out. Oh, that's gonna make this an absolute nightmare. What about lowercase or anything? Okay. Can we just say element and see what comes up? Everything, of course. Anything related to an element. I figured, but I was like, maybe... Okay. So what about, no, go back. Here's an input element description. What about this? Nope. Yeah, of course all these strings have been removed from the compound executable, even though the game for sure uses these. So that makes things tricky. I was hoping some of it would have been present, but no. Okay, what about... Let's look at a few more things, though. DXPC. Yeah, that's not a thing. Okay, what about... They probably are checking using the integral value, then, instead of, the rest. So basically, okay, maybe, like... If you tried to parse this as little endian, even though it's not little endian, you would get this. So perhaps there's no freaking way that's gonna turn off anything, of course. Yeah. Alright, so okay. I'm pretty sure they're just parsing it manually, but that's kind of a pain. So we need to basically take the information in this blog post and actually utilize it to go through the shader and generate an input layout from it. So I mentioned at the beginning of the stream I had this whole plan for all these things I wanted to do to get it to render stuff and hedge it. Today we essentially accomplished this part of the plan, but there was, and so we still have a lot more to go, I guess. Though actually the rest of it is a lot easier. But so it should go a lot faster. I thought we could do it today, but there was a road bump that I didn't expect. This part of the plan, basically. This part, I guess, when you're generating this. I forgot, actually. Well, I didn't realize. I knew that the shaders had variables in them which explain things like how the constant buffer worked and all that. And I just kind of stupidly assumed that that information was what the game also used for its input layouts. But no, it's not. The game doesn't have any information like that at all in that section. So they have to get the input layout data from something else. I believe they get it from here. I believe that's why that section is there in the first place. But that's very peculiar. It definitely makes me question, like, I don't know why that's a thing. But, oh well, okay, so we need to parse that. We're gonna do that next time, I think, because, it's already almost 1 AM here. I've been streaming for about, almost 6 hours. So I think that's a decent place to leave off for now. Next week, I don't plan on streaming HedgeLib, though. I plan on streaming something non-related to HedgeLib. I have a Twitter poll here again, as I mentioned at the beginning of the stream, for what that something's going to be. There's still 6 days left, so if you haven't casted your vote yet for this, and you want to cast a vote, please do. You know, you're more than welcome to, of course. And yeah, These are some options I put here that I thought people might want to see, and then I said I have an other option as well. Actually, that surprisingly is more, got more votes than I thought it did. But anyway, yeah. So, with that said, I'm gonna do a break really fast, though. Before I do that, I want to look up a few more things, because hang on, I have thought just then. Maybe I need to search for something like DirectX, create input layout from bytecode. Can we do that? This is not anything related to what I'm doing. Oh, this song's cool too. I'll let that play. Oh boy, let's see. Oh, maybe they used, you think they used the DirectX toolkit? Because I want to use it, I think it's going to be really handy, but do you think Sega used it? Was it a thing when they made the game? I don't even know how long it's been a thing. They definitely used the DirectX toolkit. It's right there, okay. Interesting. So maybe the DirectX toolkit has something. That would be a built-in thing. Okay, hang on. Let's see, common states, effects. Okay, built-in shaders for rendering task, helpers for D3D programming, texture loading, common states, gamepad, geometric primitives, model, mouse, post-process, set up built-in shaders. Okay, interesting, but still not finding what I'm... Maybe effects, even though it says built-in shaders, I think it might actually also have code for stuff. Or maybe miscellaneous? Let's see. I should have said include. Effects. What's all this? Get vertex shader bytecode. This is an interface representing any effect which can be applied onto a D3D device context. Okay. Oh, apply. Oh, this is like what I did today with HedgeLib. Reinventing the wheel, as always. There's the bytecode and there's the length. Yeah. Okay. You have effect matrices. Oh, that's cool. Okay, you've got lights. Oh, neat. These are all abstract interfaces, so... Oh, this one's cool too. Basic effect. This just like implements all that stuff. Okay, so this is all pretty standard though. It's not like what I'm looking for. Okay, what about the helpers? This is gonna be interesting. It's actually not that big. I thought it'd be a lot bigger than this. Map guard. This is like a lock guard, but for D3D maps. Okay, that's handy. Debug object names. Align down. That's that's handy too, and align up. Okay, so those are all like handy, but that's not. Okay, apparently they have a wiki that's fairly extensive. I didn't realize that. Ah, it's actually quite a lot of things here. There's all these pages. Right now I realize it was formerly hosted in Codeplex. Oh, so this is what they used in Sonic Forces then. Okay. Still, a lot of this stuff is probably still gonna apply. Maybe I can go to the Codeplex archive though and see the old documentation, because maybe that'll be more accurate to what they were doing. Effects, gamepad, geometric vertex, graphics, memory. Okay, maybe it's stuff related to shaders. Built-in shader stuff, but like I want. DirectX toolkit. Git. Now create input layout. Okay, what's this? Vertex types defines commonly used data structures. Okay, it's got all these. Each type also provides an array which can be used to create a matching input layout. Okay. I get that. And what's this? It contains the vertex elements needed for using Visual Studio Shader Designer shaders via DGSL effect, which requires position, normal, tangent, color, and texture coordinates. It's used by loading this. Okay. The SDK mesh format describes input layouts as direct 3D 9. Oh, jeez. There's no specific vertex structure for this, and as such, the input layouts are built on the fly. What can you do with the 3D 11 one? Oh my gosh. The model loader attempts to create input layouts that match the need of the standard effects. So we can end up ignoring some of the layout content. Okay, effects, hang on. Create an input layout matching the effect vertex shader. Oh! Wait, what? Oh, no. They're just hard coding. For built-in, doggone it. Yeah, matching the effect vertex shader input signature, and then they're just gonna say vertex position normal texture. They're just gonna use the default one. Oh my gosh. Oh my gosh, I'm sure there's like a thing in the DirectX toolkit that can do this. Okay, hear me out, guys. I'm sorry, hang on. I'm gonna do a break soon, I swear, but I want to solve this before I stop, so that just for my sake, you know, it's like it helps me to like think like I got it, so I've just got to do it easy, rather than thinking like, frick, how am I gonna do it all night? You know what I mean? So these are all the layouts. I get that. They didn't show them creating the input layouts. They just exist, I guess. Okay, hang on. Yeah, okay, I get that. There's a set input layout, and then there's this. Yeah, this is the built-in one that they're saying. Okay. Wait, the trigger for needing to create a new layout would be enabling or disabling lighting, which requires a normal... okay, so these would need to make a new... Yeah, okay. But it doesn't do it automatically or whatever. Let's see this again. This array contains one or more input elements. Yeah, I understand that. An input element description describes each element. Yeah, I see. Okay, in this example, yeah. I do get all that. I just wanted to see if there was a way to auto-generate one of these from... Okay, so apparently not. Let me see one more thing. Do like signature. Wait, can influence the choice of shader and input layout signature. Hang on. Yeah, but why? This interface is limited by... Okay, wait. Effects that implement this interface require normal semantic data in the vertex input layout. Yeah, but... There's really no way to just make that happen, you know what I mean? Okay. Yeah, they don't, so yeah, Sonic Team actually parses, they actually parse that, I guess, manually, and construct the input layout from that. So that's interesting. That's definitely possible to do. It's just very surprising to me that that's the way they did it instead of making their own thing. Huh. Interesting. Well, anyway, we're gonna do that next time, because I said I would end soon anyway, and so I need to sleep. And yeah, oh, 69, perfect. What better way to end? Now that we have 69 on the screen, now I can sleep well. Okay. But yeah, we gotta parse this. I'm assuming that that's how Sonic Team did it, because I don't know any other way they could have possibly done this. Maybe the DirectX header file actually has something about this in it somewhere, so we don't actually have to write our own code. We can just we do, but we can use the structs at least from the official one, because I feel kind of weird just rolling my own stuff all the way. I feel like that's prone to error. Even though I'm totally happy rolling my own stuff all the way. I like actually doing that sometimes. It's just I feel like that might not work, but like I'm just kind of surprised that that's what the game does, but I guess it is. Anyway, gonna take a break, then we're gonna stop for tonight. Okay, so hi. Vote Sims 2DS, you cowards. That would be amazing. I would certainly buy that. Oh, hi, Sonic Classica. My apologies for ending it right as you're joining. I'm gonna look at a few memes and such that people sent me real fast, and then I'm gonna stop for tonight. But yeah, my apologies. I've been going for like 6 hours. All right, I don't worry, Taz. I won't forget to watch it. All right, from Taz, we have this. Yeah, block me or else I'll take all your Pepsi, like I showed her. And then, oh, the other account, Oshawott, says PETA is just like Classic Sonic Enforces. It's a joke. Wow. Burn. This is hardcore. From Shills. I found a stream playlist. The Sims 2DS / Game Boy Advance full OST remastered. Whoa, boy. This has got to be a spicy meme of some kind. I'm really hoping that EA doesn't... I feel like this is not going to be good if I... Well, do you think they'll care about the freaking DS version of Sims 2? I hope not. But we're going to find out, ladies and gentlemen. Let's play a little bit of this, because I need to hear what you're talking about. Like, how bad can this possibly be? Oh. Oh. Oh, yes. It's not terrible, though. It's just not good. That is probably the most forgettable song I've ever heard. Like, okay. Let's skip ahead a little because I want to hear a few more of these. Dusty Hog Blues? Oh. Don't do it easy, eh? Oh, it's too late. Oh. Good. They just had someone jam. This sounds beautiful. Let's see. Is there one for, like... I've never played The Sims 2 on the DS or Game Boy Advance, obviously. I don't know anything about it. Is there one for, like, the town, even? Oh, like Strange Town. Yeah, yeah. Oh, Create a Sim. Here we go. Now we're talking. Mm-hmm. Okay. That sounds, that sounds alright. Kind of. Just... That sounds like Sims... Yeah, that sounds like Sims 2. Just, very... interesting. It's not bad, it's great. Oh, I'm sorry. Yeah, it's actually not bad. I just assume that that's what you meant when you send it. It's not very memorable, but it's alright. You know, I've heard I've heard you know, I've heard worse. Here we go! I'm the new kid moving in, getting it done. Sorry. I've certainly heard worse. Have you heard the, I'm sorry, the Corey in the House DSOST is the greatest thing. I don't know what you're talking about. My favorite song is The Mall. Just listen to this one. Why did you do this? Why did you do this? Why couldn't you stay in the dead? He knows what he did. He was just as responsible for this as Corey was. In fact, he was more intelligent. He framed Corey. Corey would never do anything wrong. This man, go to your room. And you too, Missy. What the frick? How could you have done this to Corey? You tarnished his brand. There's a song just called Government. Anyway, it's very good. Yeah, actually, the Sims 2 DSOST isn't bad. As far as the DS songs go, it's actually quite. It sounds alright. You gotta understand though. I was thinking when I clicked on that, I was thinking like Sims 2, and when I think Sims 2, you know, I have high standards. I think of like this. Oh, it's so good. Like, I'm not even being sarcastic, it's so freaking good. I'll definitely get a Copper King from EA. They're gonna destroy me. There's a version of this from The Sims 2 Nightlife, which has a bunch of guys going and it sounds really. I always love that one. It makes me so happy. I didn't even like really grow up with The Sims 2. I actually played the first one as a kid. No joke. I don't know why. Oh, we got it like a thrift store or something, and it was I loved it. Like legit, I loved it. So I actually have more nostalgia for The Sims 1, but I love The Sims games. They're great. They're all good. Anyway, sorry. Went on a freaking 40-minute tangent. From Taz. Oh, it looks as though Glaceon is still sleeping.
She is still asleep. Wait, focus.
Yes.
Focus.
You sleep well. That's very important. It's very healthy. For Michigo. Oh. I love it. It's great. Holy frick. Oh my gosh, I just want to keep staring at this. This is so beautiful. Anyway, sorry. What the frick is this? Okay, we got a cow loaded with guns. Friendly. Then we have Kermit-chan. I couldn't even. I choked up. Like I couldn't even say it. That is certainly beautiful. Yes, but we gotta zoom in. We gotta analyze this. We gotta further analyze the image. Kermit Asui. Oh, it's Asui from My Hero Academia. How could I be so stupid? Okay. Yeah, you know I want to go full weeb right now, but I don't know a lot of the kanji. I know some of it, but not all of it. Asami? I guess that's the artist or something, because there's a heart after it. So that's gotta be something. What's the katakana on the top right say? It's something no, and then... Endangu. Endangu? I don't know. Anyway, I'm too. My brain isn't working. It's probably obvious what that's supposed to sound like. But anyway, this is beautiful, and I wanted it all to resonate in your being. Like, take it to heart. Like, you know, when you go to bed tonight, like, think about Kermit-chan. Alright. Again from Ichigo. Why, hello, it is I, Jimbles. Oh. Cool Jimble is a reminder to not do drug, do science. Science make drug though. Shut. I like this. This is great. From Faxverse. 16 photos taken seconds before disaster. I really need to play Breath of the Wild on a It looks so fun. My gosh, I want to play it so badly. But I don't own it yet. I gotta buy it. It looks excellent. Also, can I just say, that image was like this. Sorry, I love it. There's like an extra meme in there that I don't think was intentional. Is that Thanos Robotnik? Oh my gosh, wait, like... Behold my floating masterpiece, the egg carrier! And then you gotta have it like, I possess... Yeah. Can you make it here? You will never stop me, Sonic, for I possess all the Infinity Stones! Waha! Yeah, whatever, you get the idea. Holy frick. It must be some kind of an endangered species. That one's name is Tim. It's official. Its name is Tim. Alright? So, everyone's gotta call it that now. Alright, from Taz, we got this epic MP3. The Discord revolving. Oh. 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 Oh, it's epic. This is so epic. Oh. I love it, Taz. It's amazing, actually. I don't get all the jokes, but I still love it. I also did the thing. Yeah, I also did the thing. This is from Ichigo. Freaking nice. Freaking nice. Wait, do I have other memes? Or did I get rid of all of them? What is this one? Oh! It's a disco ball, apparently. I forgot about that. That was from the anniversary stream. I just want to leave it like this. I want someone to join right now. They'd be like, what? What? Oh my gosh. Alright, from Ichigo again. Yes! Thank you, Taz. That was... Holy frick. That was enlightening. I loved it. Alright, from, Ichigo. I can't do a Shaggy. Like, I've tried so hard, I just can't do Shaggy's voice. Like, Yara does, man! I can't do it, like, for the life of me. That's the closest I'll ever get to it. But I love it. We got a Thomas gun. Teach your kids, to defend their property with, with the Thomas the Tank Engine collectible, gun. It even has, like, a strap, apparently, that has all of your favorite Thomas characters painted on it. So, you know, so you can put the strap over your head, and, you know, you can be reminded of your childhood joy as you're, murdering hundreds of people. Does it say Nerf, I hope? On the top left there? Does it say Nerf? I can't read that. I think it might. Even so, that Nerf, if that's a Nerf gun, that doesn't really look like a Nerf gun. It looks like I mean, it obviously it's bright and colorful, and a real gun wouldn't look like Thomas, but like, there's some realistic looking elements to it. That's bizarre. I don't know where you found that, but holy frick. Alright, I like this. That's good. That's actually edited on very well. Like, not, like, unironically, like, that's edited on beautifully. I admire the Photoshop skills. Same with this. This is just excellent. Wait, what anime have they been edited into? Is that, Wait, no, I know this. Hang on, it's like the... Do you like my car? What the frick? Like gas, but like, what was that from? Yeah, it's that anime. Hang on. Initial D. That was it. Manual. Gas. Yes, it's Initial D. How could I be so stupid? I love it. I don't know the context of this, but this actually looks quite cool. I'm not even gonna lie. Oh, now I get it. Now I get it. Thank you, Ichigo. What is this? Woman assaulted on bike path. That's terrible. Deputies release sketch of suspect. This is the person who they think did it. What is this? It's like Shrek, but his face has been put onto Mike Wazowski from Monsters Incorporated. This is a lot funnier than it should be. Just picturing that thing wandering the streets. Oh no. Oh my gosh. Okay, a few more memes. Venom 2018. Whoa. What did you look up? What did you look to find this image? Like, did you Google like SpongeBob Vor? Because I don't think I want to see. If that was like that was like a normal entry in your search history. I don't know if I want to see the other ones. How doctors listen to music. Yeah, this is good. It's pretty good. We'll show me this one last night actually because she thought it was funny. I like this. And then what's this? One more from Ichigo. When you invite her, oh yeah, she showed me this one too. What I like about it is Tom's face. Cause he's genuinely like, what are you doing? That's not how you play Smash. What are you doing? Get the Pro Controller out. Like, come on. It's pretty good. Alright, I'm gonna show a few moves and then I'm gonna stop for tonight. There's a lot of them from Taz, so I'm gonna show a bunch of them from him. Yeah, you know I already heard this, but you want the stream too as well. The original remixes from Teenage Remix. Okay, I'll play this, I swear, but this song is jamming. Eggman's minions or whatever, they're like going out. Listen to that. I gotta let this one finish first, and then I'll play this. So I'll come back to it, don't worry. From Taz again. You're like 75% sure I won't get blocked because it hasn't for you yet? Alright, I don't really want to take a chance because I already took a chance from the from the EA thing earlier. Well, I guess that makes it like did not matter then, but I have the video. I have the tab pulled up. I'll play that right after the stream. Alright, so here's a Snivy says, these are always good. Are you keeping track of your daily dairy intake? Thank you, Snivy. I don't think I was keeping track of my daily dairy intake, but now I will. Alright, let's play that song. Actually, Final Leg Trio Boss Phase 1? Alright. And let's download this because if I play it on Discord, it's gonna stop if I scroll down too far. Yes.
But that's not going to help you since I know everything you're going to do. Strange.
I love the delivery of that line, by the way. Sorry if that was loud. Alright, so let this play. It's beautiful. Alright, while that's happening, it's all we. Good night. It's Snivy with a big bottle of Pepsi. Oh, that's beautiful. What better way to hit the hay? And then you have... Wait, what's this? I guess this was posted the next... Yeah, March 7th. Good morning. I love how Snavy's like, back to this crap again. These are all so good. Thank you, Tez. I'm Sense. Ah, Fred, this is what you were making the other day on that call, isn't it? That's beautiful, Tez. Oh my gosh. Help, how do I make my eye go back to normal? He can't undo it. She? Sorry. I don't know what gender Snivy is in this case. Wait, before I take the jacket off, I gotta do the thing. Oh. Yes. Oh my gosh, you cut that voice out of the song so perfectly. I mentioned that before, but when you played it just for me, but like we're like off to a minute. Whoa! But my gosh, it's so good. There isn't a Windows 9 because 789. Yes, you know, Taz, I'm sure I mentioned this before, but did you know that that was actually the official reason that Microsoft provided? Someone asked them at like a con, I think, why they skipped Windows 9, and someone was wearing a. The answer was 789. They had a Microsoft employee actually wearing a T-shirt that that had turn it up. Okay, he was wearing a T-shirt that had binary on it to look like the Windows logo, which was cool. But if you actually typed out the binary and you translated it in one of those ASCII to binary, you know, kind of converters, it said, "Why Windows 10? Because 789." I'm not even joking. That's a thing. So that's hilarious. This one's really good too. Snivy is gone. It's just freaking disappeared. It's freaking. Oh. And then wait, I guess Knuckles took over. That's funny. I like that. Then we got this one as well. Being in a white void is boring. Oh my gosh, Knuckles just took over. The frick? Taz, that song was beautiful, by the way. Thank you. What? Oh boy, it's gonna be a confrontation. I don't know if I'm ready for this. And then we have... What the heck just happened? Everything's inverted. Oh my gosh. I wish I had Pepsi 3 hours later. And then wait, hang on, frick. Oh. Oh. Okay, well I gotta show these real fast. Why am I still in Snivy's house? Get ready, bro. It's about to get interesting. I think I just killed Snivy's trainer. And then this! Oh, frick. So much for the family-friendly tag. Oh no, what have I done? Cops are outside. And then, meanwhile, I feel a disturbance in my white void. Holy frick. The editing on this image. Oh, something about it. That's amazing. And then finally, last one from Taz. Oh, this one's from Ichigo, actually. But it's a meme that's Taz made. A friend requested this, apparently. I guess Ichigo did. More I hate you jokes would make Sonic funnier because it would make him relatable. He would be mean to people he does not like and make it clear he does not like them. It would make him more psychologically realistic. Mac and cheese. Yes, it's definitely Ichigo. For a second I was like, well yeah, but I agree with this. This isn't just like a meme, this is like an actual point. And then I was like, there's the meme. Epic. GG. Wow. So thank you all for sending these. I'm gonna look at I'm gonna scroll up and look at a few of the older ones you all sent because I skipped a few, and then I'm gonna stop for tonight and I'll look at the rest tomorrow. The break for that stream. So we got I'm just gonna look at a few random ones here. This is one from DLG. Kill me, Carson needs to put an end to this meme. What is this? Cereal? Cereal with no milk? Cereal when has milk, when milk have milk. Milk. Yes. I never did get the meme, being honest. But that's beautiful. Oh yes! Yes! Again from DLG. Yes! Wait, frick, I didn't talk about the movie design at all on the stream, did I? Okay, I got it. Well, tonight I'm not gonna talk about it because I feel like I missed my opportunity, but tomorrow I'm streaming Sonic 06, so it'll be perfect. I'll rant about the Sonic movie design tomorrow. It's we'll talk about that then. Oh, that's a dank meme. Alright. Oh, apparently, Taz just sent a new one. Alright, I'll check that out real fast. Wait, hang on. First, what's this? Sega, okay. Nintendo, yeah, good. McDonald's, yeah, alright. This is actually really cool. Like, someone made this, wow. We got McDonald's, Sonic. That's actually funny. I didn't really ever think about all this, like how many different companies have handled Sonic before. McDonald's Sonic looks a little off, but not surprisingly not that bad. It looks like the CG quality is cheap, but the design is Sonic, right? It looks good, other than the CG. Disney's, of course, freaking good. They did an excellent job with Sonic and Wreck-It Ralph. Like they animated him very well. Warner Brothers, I think, is this Ready Player One? Because I didn't actually see that movie. I'm just assuming that's what this is, because I don't know what else Warner Brothers would have done that had Sonic in it. But that actually looks, like, great. Like, wow. Looks fantastic. Lego Dimensions. Yeah. Looks good. I mean, I'm actually shocked by how good the Lego Dimensions design is, because this is somehow a design that, like, no one's complained about it. You know what I mean? It's addressed, I mean, it's a Lego version of Sonic, so it's obviously going to look drastically different from the normal Sonic design. Yet, people were totally fine with it. They're like, yeah, it looks good. Like, when has that happened before? Like, Sega introduced a drastically different Sonic design and people were just like, yeah, that's fine. So that's kind of impressive to me how they managed to make a design that the whole fan base was okay with. How do you freaking do that? Progressive? Yeah, looks good. BioWare? CG looks a little off, but not bad. Looks good. Paramount. It's good. Those were screams of delight and not terror. Everything's good. So, alright, a few more memes Taz just sent. Oh, and Ichigo sent some as well. So we're gonna show those, and then we're gonna stop for tonight. That's gonna be it. So here we go. Some more from Snivy says. Again, Taz's account. Why are people coming to my house? Hey, Snake Lady, do you want a movie? Hey, Snake Lady, do you want a movie poster? Depends. Here. No. I like that. Snivy's in Green Hill. Apparently, this is some sick lore. Oh, it was like several images. I'm sorry. So Sonic was supposed to open the door when I said that, and then this is the movie poster. I really like the pose for some reason, and then like the way you photoshopped it on, it's funny. And then the door closes. That's what I should have done with the movie. This is a gift from Ichigo, so I'll show that real fast. Thanos, creative problem solver. Wait, hang on. Oh wait, if I can't hit you with the hammer, then I'll hit the hammer with you. He's bashing Thanos against his hammer. I'm sorry, Thanos is bashing him against his hammer. Oh my gosh. Thor's hammer can't can't be destroyed, so he's just like, I'll just smack him against the hammer. The frick? That happened? That's hilarious. And then a few more for each to go at it. This is seriously gonna be it. I gotta stop soon, guys. Oh, it looks like female Sonic. It's actually, that is drawn well though. I'm no furry, but that's drawn well. Dwayne the Bob Johnson. I like that. That's funny. It feels in reverse. Oh yeah. Wait, in reverse? Wait. Hang on a second. Hang on a second. You need to explain my knowledge of how to do taxes. My knowledge of. Okay. What's funny about it is the guy's face. That's good. I saw this. What the frick? What the frick? That is some bootleg. I mean, wow. Like, I want to drink some Windows Vista. What if Microsoft made a Windows 10 like soda? Would you have to constantly like update it somehow? Like a great joke, hilarious, rad. No, but seriously, like, the frick? What does that have to do with Windows? That's amazing. There'd be the Windows Vista one probably like you drink it and like every now and then like it causes you to blue screen. I'm sorry. These are the least creative jokes possible. I've seen this already from Ichigo, but this was sent again. Apparently. It's I don't know what art is like. These artists are actually talented, but I do wonder why. These are the things that you know what I mean, like it's like I'm gonna draw female infinite, right? It's like, well, what that's interesting, but it's there's nothing wrong with it. It's just it's just interesting to me, but they're very talented, yes. And Chloe, I think that's Emil's art actually. That's good. And then another female infinite, and then the female Sonic one again. And then, hey Rad, this is me Ichigo from Discord.gg. Can I have a waifus breaks? Wait, we should just have a channel for just waifus. I never thought about that. Well, there is a there is a waifus channel. It's not for breaks, but I mean, you guys can spam as much as you want there. There's nothing wrong with that. One more from Taz, and this is it. It's also for Aspendos, by the way, but no one uses it for Aspendos. I think someone posted like Zavik once or something, which was not what people really wanted to see. But you know, yeah, it's like, oh, it was just like a really buff Zavik. It was like, thank you. But I'm sure some people probably liked it. Anyway, this is from Taz. This happened because after you made the movie poster tweet, the design got leaked on the same freaking day. Oh, really? I've made a severe and continuous lapse in my judgment, and I don't expect to be forgiven. I'm simply here to apologize. I'm sorry to Sonic the Hedgehog for saying no to his movie gift, and I'm sorry for cursing you all with seeing the new Sonic design. Please forgive me. Mac and cheese. Sorry, I had to add that at the end there. That's amazing. Oh yes, we want you to see our waifus on the stream. Well, I get that. I don't know what you want me to say about them, but yeah, they are good. They are drawn well. If you were gay, you'd probably find Zavik hot. Oh well, I mean, probably in that case, yeah. Well, the thing was, I asked Mew, I was like, what do you think of the Zavik? I was joking, of course, but I was joking. But I was genuinely a little bit. I was wondering. I was like, do you think she despises it as much as other people did, or not? I was wondering, right? And she was like, it was freaking terrible. It wasn't drawn poorly. It was just like it's Zavik. Anyway, yeah, those were some epic memes. Yes, I just said epic. I use it ironically, just like frick. Anyway, that was super epic. So thank you all so much for sending those to me. They're all beautiful, and they were so good. Like, oh my gosh. Tonight, especially, a lot of them were great. So thank you all for sending them there. I appreciate them a lot. Yeah, sorry I didn't get as much done as I wanted. There was an unexpected hiccup there because I didn't realize the game did something differently than I thought it did. But we're gonna figure that out next time I do a HedgeLib stream. Or actually, I'll do it off camera, I think. Oh, thanks Mario. I'll do it off stream. Before next time, I think I'll figure it out and I'll implement that, and then next time we have to get something drawing on the screen by next time. My gosh, it's taken so long at this point. We'll get it soon, and then once we get something drawing, it's a lot easier to get the rest of it implemented. Anyway, yeah, for now I'm gonna stop. I'm gonna get my sleep, and I'll see you all tomorrow with some Sonic 06. We're gonna talk about the movie design. We're gonna, of course, play more missions and S-rank things, and it's gonna be a fun time. So, yeah, if you're interested, stay tuned for that. It's gonna be at 7 tomorrow. I'll announce it then as well. And yeah, I'm gonna watch your video test afterwards. Don't worry. I have the tab open still. It's actually what I'm staring at right now on my first monitor, so I won't forget. But yeah, thank you all so much for watching. Hope you did enjoy it, and I'll see you all next time. Remember, mac and cheese.